Hello, and welcome to Skylines Academy. Today we're going to be looking at Microsoft's AZ-204 exam, Developing Solutions for Microsoft Azure. My name is Joe Fecht, and I am an Azure technical consultant with a head. I jokingly refer to myself as a recovering Windows administrator. After 10 plus years of focusing heavily on Microsoft Windows Server ecosystem, I've spent the past few years transitioning my focus more on Azure. I've really enjoyed learning more about Azure, and my hope is that I can help inspire you and share some of my knowledge I've gained along the way. My LinkedIn, Twitter, GitHub, and blog are listed here. If you have any questions or feedback, I'd be forever grateful if you could share that with me. There are no other exams that you need to pass in order to obtain your Azure Developer Associate certification. If you pass the AZ-204 exam, that's all that's required. Additionally, and I can't stress this enough, you will need some hands-on experience with Azure in order to pass the exam. With this in mind, you will need to have access to an Azure subscription. If you don't have one today, a 30-day free trial will work perfectly fine in conjunction with this course. Additionally, experience working with Azure CLI, Azure PowerShell, and working with the Azure SDKs will certainly be helpful as you study for the exam. Those topics themselves are outside the scope of this training, but I will try to sprinkle in bits and pieces throughout to help you have some exposure to it. Let's take a look at the course outline to help give you an idea of what we're going to cover on our journey to the AZ-204 exam. We're going to do an introduction to Azure to help you get more familiar with the Azure portal. We will then take a look at Azure's Infrastructure as a Service, or IaaS offering. This will be your more typical VM type solutions. We'll then take a look at some of the container services, including some information on Docker. Azure App Services will cover some of the web offerings. And with Azure Functions, we explore one of Microsoft's serverless offerings. In Cosmos DB, we look at non-relational databases. Azure Blob Storage is one of Microsoft's storage solutions. We will also take a look at a few different ways we can handle authentication, which segues well into how Azure Key Vault can play a role in secret management. We will then discuss a few ways we can deliver our applications and how we can monitor them. We will look at another serverless tool from Microsoft called Logic Apps. We'll take a look at how we can protect and secure our APIs with API management, as well as look at some event-based solutions and message-based solutions. With that said, I'm excited to get started, so let's dive in. Let's get started and talk about what is Azure. Azure is Microsoft's cloud platform, and it offers a variety of solutions that you can build upon. These include infrastructure as a service, platform as a service, and software as a service. You might also hear these referred to as IaaS, PaaS, and SaaS, respectively. We're going to talk about each one of these solutions further throughout this course. We'll also talk about the multiple ways that you can log into Azure, as well as Azure Resource Manager, or ARM. This is the underlying platform that Microsoft Azure is built upon and managed. As we progress through this course, we'll talk about ARM and the various ways that we interface with it in order to manage our resources within Azure. So let's talk about how to access Azure. The first and most common way that a lot of people use is the Azure portal. And this you can access by going to a web browser and going to portal.azure.com. It allows you to see all the resources, gives you access to the billing and security information, and it's also customizable, giving you the ability to mark the resources you use most frequently as favorites so they're easily accessible from within the portal. Another common one is Azure PowerShell. The advantage to Azure PowerShell is that is essentially PowerShell with the Azure modules installed. So all of your existing experience and knowledge that you have from using PowerShell, you can leverage within Azure PowerShell to manage those Azure resources more effectively. It's also cross-platform as of PowerShell Core 6. So this means whether you're running Linux, Windows, or Mac OS, you're going to be able to have very much a similar experience across each operating system. Another option is Azure CLI, and this is more of a bash-like interface, and again, it is also cross-platform. Between Azure PowerShell and Azure CLI, you're able to do many of the same tasks. We'll cover both examples as we progress through the course. A relatively new one is the Azure mobile app, and this is available on Android as well as iOS devices. It allows you to manage resources in a similar way that you would from the Azure portal. It also offers Cloud Shell, which is a Azure PowerShell or Azure CLI interface from within the Azure portal. So if you have a script saved under your Azure Cloud Shell profile, you're able to run that from the mobile app using, again, either PowerShell or CLI. So it gives you that ability to manage your resources when you might not have your laptop in front of you. And finally, Azure REST API. All of the resources we just got done talking about, the portal, PowerShell, Azure CLI, as well as the mobile app, are all just making calls to a REST API on the backend. So as we become more familiar with Azure, we can start to work with Azure, manipulate Azure using the REST API going forward. Now that we talked a little bit about how to access Azure, let's talk about resource groups and regions. Resource groups are a logical container that is used to hold related solutions. So this could mean if you've got an accounting application, you would logically group those together. The principle behind this is that it's lifecycle based. So that means as you create the resources, you create a resource group, you add the necessary components. Maybe you have some VMs for some compute power, you have SQL to store your data, and then you've got a network security group or an NSG in front of that to provide some network-based access control. You would group those together so that they are maintained, created, and destroyed at the same time. Additionally, you could put resource locks to prevent them from being deleted or manipulated. It can also help with resource tagging so that you can apply tags consistently to all the resources within the group. You can use RBAC or role-based access control to manage access and permissions to those resources. And also you have the option of exporting that resource group to a template. Ideally, you would group your resources together within a single resource group. Understandably, once you move into a more enterprise level environment, it might not be as easy, but it's always something to strive for as you work within Microsoft Azure. Moving on to regions. A region is a set of data centers within a geographical area. Microsoft has over 60 regions today and 160 data centers within those regions. Some considerations as you're deciding what region to deploy your resources in. From a compliance standpoint, whether it's a governing body or it's an internal policy where all of your data needs to be within a defined geographical region, when you create your resources in Azure, by selecting the appropriate regions, it helps ensure that your data is going to stay within that physical location. One of the considerations you want to make is that your resources are closer so that the network latency is lower. Another thing to keep in mind with this also is fault tolerance. So if you have all of your resources in one region and that region were to go offline, unfortunately your resources are going to be offline. So as you design your solution, you're going to want to make sure to keep in mind that you might have your resources deployed in more than one region to give you some fault tolerance if one were to go offline for whatever reason. Now that we've talked a little bit about Azure, how we can access it, and some of the components within it, let's log into the portal and let's see what we can do. So you can see here I've got a web browser pulled up, and I'm going to go ahead and just go to portal.azure.com. And this gives you the option to log into the Azure portal. If you don't already have an account, you can always go to azure.microsoft.com. You have the option to start a free Azure account. This gives you 30 days with a $200 credit to get logged into Azure and start playing with it. And you can follow along our entire course under that $200 credit. So let's close this out and go back to the Azure portal. You can see I've already got an existing email address that I've signed in with. So I'll select this. I'm going to enter my password. We're going to type it in correctly this time. And you guys are using MFA, right? So now that we're signed into Azure portal, you can see this is kind of the default landing page. You can see at the bottom we've got some resources that we have recently accessed, as well as we have some resource types or Azure services that we've also recently accessed up here. Additionally, you have your favorites menu on the left. You can have the services that you use most frequently. This way they're easily available no matter where you are within the portal. With that said, I want to go ahead and take a look at resource groups. So you can see we've got a resource group here called Demo Resource Group. We also have another one down below called Monitoring Resource Group, or RG. These are two examples of the resource groups, and these are individual items down here. We also have resource groups at the top, and this gives me all of the resource groups that are available within the subscription. Additionally, you can see we've got those for other services up here. Another extremely handy feature, in my opinion, is the search bar at top. You can see we can just start typing and resource group shows up. If, for example, we wanted to look at virtual machines, you could type virt and you can see it starts to show up. Or if you also just type VM, Azure's smart enough to realize that VM is synonymous with virtual machines. You can also do SQL, for example, so on and so forth. It is just very helpful because not only does it give you the services that match, it also gives you some of the resources that match. So let's go ahead and just type resource, and then we're going to select resource groups from the top. And you can see here now we have access to all of the resource groups that are available to us. What we're going to do to start with, though, is we're going to create our own resource group. So let's go ahead and click on add. And once we do this, you can see it gives us the subscription to deploy the resource group to. In this instance, we've only have the one subscription, so we'll leave that at the default. We can give the resource group a name. So let's just call this one Demo RG001. And you can see it did yell at us a minute ago, basically saying there's already a resource group with that same name in the subscription. So that's why we added the 001, so it's a unique name for that resource group. And now we also need to define the region that it's deployed to. And you can see we've got a number of choices here. For this instance, let's go ahead and just select Central US. When you select a location for a resource group, you're telling Azure where to store the metadata for that resource group. It is not a hard requirement for the resource group and the resource within it to be within the same region. That being said, if the majority of your resources are going to be in a given region, it makes sense to also have the resource group also be in that region. Again, not a hard requirement, but a good recommendation. Now let's click on tags. So for tags here, this is the metadata that we can assign to these. We're just going to go ahead and give this one. We've already got a tag name called Tech Contact out there for technical contact, and I'm just going to assign myself that tag value. We'll talk about that later. And now we're just going to go to review and create process. Basically, it says passed. If we had any policies, for example, that prevented the resource group from being deployed in a given region or without the appropriate tags, that would be checked now. Again, this is something we'll talk about at a later time, though. We're going to go ahead and select create. And now we can see we've got our first resource group's been successfully created. Do a refresh here. We can see our new resource group shows up. So we go ahead and open that up. You can see right now we don't have any resources within the group, but we do have the tag assigned here. So Tech Contact tag value is assigned to Joe Fecht. Now that we know how to access the Azure portal, we've also talked a little bit about creating a resource group and understanding the regions associated with it. Let's move on to the next lesson. In this section, we're going to talk about IaaS, or Infrastructure as a Service, as it relates to Azure. Before we dive into that, we need to understand Azure virtual machines and their components. So to get started, Infrastructure as a Service, as it relates to Azure, is going to be Azure virtual machines. And what this means is it gives you full control over the operating system, just as if that virtual machine was residing in an on-premise data center. They support both Windows as well as Linux operating systems, and there are multiple sizes and types to support the variety of workloads or solutions that you're going to be deploying to them. So to get started with virtual machines, let's take a little bit of a step back. Originally, we had hardware, physical hardware that resided on-prem. This included the processor, the memory, as well as the storage. And on top of that, we installed an operating system, and then we had an application that ran on top of that. With virtual machines, we start with that same hardware, so we still have the same processing, memory, and storage options or storage resources that are presented, except this time we install a hypervisor layer. And what this does is it's going to take all of those resources, again, that memory, CPU, and storage, and then we're going to create various operating systems or install the operating systems on top of that hypervisor. Those operating systems are not going to be able to tell that they're running on a hypervisor. They think they're talking directly to the physical hardware, just like they would in a traditional deployment. Those various operating systems are then referred to as virtual machines. So you have multiple virtual machines running on one physical piece of hardware. And the advantage to this is when your traditional deployment, there's going to be times when the application and the operating system are not using the full processing capabilities of the physical hardware. And by installing multiple operating systems or virtual machines on that same piece of hardware, you're going to be able to make more use of that hardware. So as one application might be idle, the other application could be running more extensive workloads. It's always a balancing act of application performance versus the density of applications and operating systems running on a piece of hardware. However, the benefits have proven themselves worth the effort. So now that we understand the premise behind a VM and understand the components or how it essentially works, when we move to Azure, talking specifically about Azure, there's multiple different VM types depending on the workload. You can see we've got a type A, which includes basic and standard workloads. You've got burstable workloads, to where you might have a application that typically is going to be pretty low on CPU utilization, but might have those periods of time where it bursts or spikes up, and that's able to address that. You got general purpose VMs. You got those that are optimized for high memory applications, so the memory to CPU core ratio is much higher. You also have the opposite, where you have a higher CPU to memory core ratio available. And there's also the G, or Godzilla size, which is for very large databases or big data use cases. Additionally, there's also specialty VM types. You got your type H for high performance compute, or HPC. This is going to be for your specialized use cases, like, for example, molecular modeling or other scientific applications. You got your L type, which is storage optimized, so they have a much higher disk throughput and I/O. You've got your M type for large memory, and this allows you to assign much larger amounts of memory to a VM than might be typically available. In this sense, you can see we allow up to 3.5 terabytes of RAM to be assigned. Type N, we're GPU enabled, so if you've got a workload that would benefit from having GPU processing power available, this would be a VM type that you should consider. And then there's also the SAP HANA instance, which is purposely built and certified to run the SAP HANA application. We also have specializations within the various VM types to let you know that there's additional options or additional capabilities that you can assign to that virtual machine. For example, if it has the S in the name, that means premium storage is available, which gives you that option for premium SSDs, which again, higher throughput and IOPS. M type for larger memory configuration, so if you want to assign more memory to it or more memory is available to it. Or R for RDMA, so that the network card can talk to the application memory to help improve the application performance. With all that being said, it's very hard to tell how one type might benefit over the other or what the actual performance increase would be. So with that in mind, Azure created the ACU, or Azure Compute Unit. And this is a Microsoft-created benchmark that allows you to compare the CPU performance between different sizes and types of VMs. If you've got a VM that has an ACU of 200, that means it's going to have roughly twice the performance of a VM with an ACU of 100. With this in mind, if you had an application that was deployed to a resource that had an ACU score of 200, and you were looking to save some money with that resource, you could look at reassigning that application to a resource that had an ACU score of 150 or 175, testing the performance again, and then making a judgment call to see if that performance was worth the additional cost savings associated with the resource with the lower ACU score. Additionally, if you have a VM that is not performing as well as you'd like, you can look to see, okay, what resources are available with a higher ACU, and then plan on testing and reassigning as needed. So now that we've talked about the hardware, let's talk about the various operating systems that are supported within Azure. From a Windows Server standpoint, there's marketplace images for 2008 R2 on up. You can run a 2003 Windows Server, but you need to bring your own image. It's not available within the marketplace, and you also need to have a custom support agreement in place. From a desktop operating system, Windows 10 Pro and Enterprise are also available from the marketplace. From the Linux standpoint, there's a number of different distributions that are available. You've got CentOS, Debian, CoreOS, Oracle Linux, RHEL, so on and so forth. There's also the Ubuntu images that are available from the marketplace as well. So obviously there's some additional flexibility here. One thing to keep in mind too is there are multiple different operating systems that are available from within the Azure Marketplace from third-party vendors that are not created or maintained by Microsoft directly. Now that you've determined the operating system as well as the VM SKU size or hardware size you're going to deploy your solution to, one thing to keep in mind is there are some limitations as far as what VM SKUs or hardware sizes are available within given regions. As you can see here with the A8 through A11 compute-intensive resources or hardware SKU size, those are only available in the East, North, and South Central U.S. as well as the West U.S. So if this is something you are looking to deploy or leverage for your solution, those are the only regions which you can deploy to. If you're looking at the version 4 of the D series. You can see right now it's only available in preview in the East US 2, but it is looking at something they're deploying or going to be deploying to the other regions throughout the US and Canada in the near future. I've included a link at the bottom, so as you're getting ready to deploy your solution, you can check back to make sure that the given resource size will be available in the region that you desire. Microsoft also has a handful of usernames that are restricted and prohibited from use. Reason behind it is obviously there's a number of VMs that are going to be running in Azure, and in order to get access, you have to know the username and password. Well, if you use a common username, it's going to make it that much more easier for someone to gain access to it just by guessing the password. So if your username is not default or not well known, it'll become that much harder for someone to gain access to that VM. Now that we understand the basics behind the infrastructure service or virtual machines, let's go ahead and deploy a virtual machine within the Azure portal. All right, you can see here we're signed into our Azure portal. Our goal today is to create a new virtual machine. So we'll go up to VM here. If, for example, that wasn't listed, you can always go up top and type search for virtual. And here you can see from services, we have that option. So we'll go ahead and select it. We do have 2 existing virtual machines listed out already. Our goal is to create a third. So what we're going to do is we're going to go up here and click add and select virtual machine. Once this loads up, you can see this looks pretty similar to when we created a resource group, except now we have a lot more options. So for resource groups, we're going to go ahead and hit the drop down and we're going to select Skylines. Now we need to start filling out some information about the virtual machine. So we'll go ahead and give it a name, Skylines VM001. For the region, we're going to leave this in Central US region. The resources that you deploy don't have to be in the same region that your resource group was created in. It's typically a good idea, but not a hard requirement. We're not going to select any availability options of availability sets or availability zones, so we'll just leave that set to no. For the image, you can see here we can select the operating system or the image that we're going to load onto the virtual machine. You got Ubuntu, RHEL, SUSE, so on and so forth. We also have a number of Windows options here. We're going to leave this with the default of Ubuntu 18.04. And then here we can select the size or the SKU. So if we hit the drop down here, you can see we've got some of our recently selected options. FS1 or standard DS2. If you wanted something beyond that though, you can scroll down here and say see all sizes. Once we have the list up here, you can see there's a number of options to choose from. We're going to go ahead, since this is just a demo, we're going to set it to where we have a maximum number of vCPUs to 1, and we'll hit OK here, and now you can see we've got this list filtered out. If you scroll off to the right, you can kind of get a rough estimate of cost per month. If we go ahead and select the drop down there, so we're sorting by cost per month, you can see we've got a number of pretty simple options here. Since this is just a small Ubuntu box, we'll go ahead and select this one. You can see, as we learned, if it's got the M&S, that means it supports additional memory as well as has premium disk support. So you can see here, premium disks is supported. And if we look at B1S, it has 1 gig of memory. Or if we look at B1MS, it has 2 gigs of memory. So we'll go ahead and select this. And you can see once this loads up, we'll have a price here shortly. Might take a little bit. In the meantime, now we'll go ahead and set our authentication to this. With Linux virtual machines, you have the option to use a SSH public key, or if you want to use a password. We're going to go ahead and select password for this, and we'll define a username as well. Again, if we type admin, and you can see it'll fail here because usernames must not include reserved words. So we'll go ahead and do Skylines admin. And it likes that. We'll give it a generic password here, not too generic. And then here you can see we've got inbound port rules. So since this is a demonstration VM and we don't have any existing networking in place in order to connect to this, the typical option is to set up a public inbound port, or basically allow us to connect to this server using SSH over the public internet. If you have an existing networking in place that has a secure connection, whether that's VPN or an express route, then typically I would recommend avoiding this because you should connect to that VM using the existing secure network. Since that's not the case or not applicable in this instance, we'll go ahead and leave that as default. So we'll select disks, and then here we can select our disk type. Again, you can select the various storage type, standard HDD, which is spinning disk, and then you've got your 2 tiers of SSDs. If you have some existing data disk that you would like to attach, or if you wanted to create a new data disk, you have that option here. We're going to leave the defaults, and then now we're going to go into the networking side of it. You can see here it's going to create a new virtual network for us. If we wanted to connect to an existing virtual network, we can select the drop down, and you can see we've got the 2 virtual networks there. Since we want this one to be isolated, we'll leave that as a default. It's going to create a new subnet within that virtual network for us, as well as create a public IP address. And we'll leave the networking security group, or NSG settings, as default. We'll talk about those in a later module. Now if we go to management, you can see here we have a couple of basic options. We configure some monitoring for it, some identities, so if we want to manage identity or integrate it with Azure Active Directory, as well as some additional options, if we wanted to automatically shut down or enable backup. We have those options, just the same as if you're deploying a virtual machine in on-premise data center. Are we going to monitor? How are we going to monitor? How are we going to back up? What are we going to use for authentication? So we have all those same ideas or concepts here. We're going to leave all these as default for this instance. If we go to advanced, now we also have the option to where we can run some custom commands. So if you were setting up a LAMP server, for example, you could have a script that installed Apache, MySQL, and Python already available. You could copy that script into here so it would execute when the VM's provisioned and have all of those already installed when we first connect. We're not going to do anything with this instance. We'll just go ahead and leave those defaults. For tags here, we're going to go ahead and set a tag of tech contact, and we'll leave that as me. And then now we'll go to review and create. So you can see here that it's past validation. You can see we're going to get roughly a cost. So it's going to cost us between 2 and 3 cents an hour to run this virtual machine. And then also lets us know that SSH has been opened up to the internet, so we can connect on port 22. Again, it flags it. It's not a best practice, but since this is a demonstration, that's okay. For a production environment, though, I certainly don't recommend that. Additionally, this is also going to check any policies that you have. So you can see here, validation passed, but if we had an Azure policy in place that says no SSH or RDP example allowed to public internet, since we'd have that, this would fail. It would say that we can't create the virtual machine because it did not meet all of the policy requirements, and it would specify what policy it had failed or what policy had caused that validation to fail. In this case, everything's good, so we're going to go ahead and select create. And this can take a couple minutes for it to get deployed, so we'll go ahead and sit tight here and we'll come back once this is done. So you can see here we've got our VM that was successfully completed. If we click go to resource here, we can see now we've got our virtual machine that's up and running. Now let's go ahead and connect to that machine to make sure it's working like we anticipated. So we're going to go over here. I'm going to click on this to copy the IP address. And we're going to go ahead and open Windows Terminal here. So now we're going to go ahead and SSH in that machine. So SSH and then Skylines admin @ and then we'll paste that IP address in. And looks like we're getting a prompt here to accept that certificate. We'll go ahead and hit yes. And now it's prompting us for the password. We're going to go ahead and enter the password that we set when we provisioned the virtual machine. And perfect. Looks like we're signed on here. We can see we've got our username, Skylines admin at SkylinesVM01. So it looks like everything's working like it should. Perfect. Now let's go back and take a little bit closer look at the networking and network security groups. Now that we understand the concept of a virtual network and a network security group, let's see them in action on the VM we set up a few moments ago. You can see here we're in the portal. We've opened up Skylines VM 001. We can see that the VM is running, and additionally we can see the public IP address over here. I've also connected to that server using SSH, and I've got a simple website running on it. If I go up and run the curl command of localhost, I'm saying I'm going to open up that website locally here, and we can see that 1, it is up and running, and 2, it is a very simple website, but this proves that we can connect to that server. And since there's not a port specified here when we're calling localhost, it's going to assume the default of port 80. Now, to see if that works outside of the virtual machine, I'm going to copy the public IP address here. I'm going to open up a new tab. I'm going to paste it, and I'm going to go ahead and hit go here. And it doesn't look like it's going to work. So that tells us there's something blocking port 80 traffic from the internet to that virtual machine. If we go back to that virtual machine and take a look at the networking of it, we can see here that it does have a network security group, or NSG, that's associated directly with the network interface, and doesn't appear that there's one associated with the subnet. So with that said, let's go ahead and open up that network security group. And I'm going to slide this off to the left so we can view it a little better. And we can see we've got inbound security rules as well as outbound security rules. Looking at the inbound security rules, we can see we've got the default of the bottom three below. We also have the one up top that allows TCP traffic on port 22, also known as SSH, which we validated is working because we are connected to that server. It also tells us that it's not going to allow TCP port 80 traffic through because it's not listed. In order to fix that, let's go up here. Let's go to inbound security rules. Let's do an add. And then we can see we have an option to specify the source, which in this case would be any. We don't per se care about the source port range, or we don't care what destination it's connecting from, but we do care about the destination port. By default, it's set to 8080. Let's just change that to 80. We're going to specify the protocol of TCP. We're going to give it an action of allow, and we're going to leave the default priority. Please note that the lower the priority number, the more important that rule is, and will take precedence over others that are configured with the same settings. We'll also give it a name here of HTTP, and we're going to go ahead and hit add. You can see here that it's creating the rule. It will take a little while for that rule to set up. Usually it becomes effective within a few minutes, but it can take longer. You can see here it's successfully created. We're going to give it a minute, and then we'll go open up that web page again. We'll do a refresh, and there we can see we do have that traffic allowed. NSG is allowing traffic on port 80. Again, that's not specific to how the NSG is configured. That's how our website was set up. To summarize, we validated that the website was running on the server and was accessible, but we weren't able to access it outside of that server. So we took a look at the network security group, saw that there wasn't a rule to allow port 80 traffic. We created one, able to validate that it was working. We've talked about Azure network security groups and how they give us the ability to restrict access to a virtual machine or to a given resource in Azure from a certain location, as well as connecting to specific ports. You can take that a step further by leveraging Azure Just-in-Time Access, or JIT access. Azure Just-in-Time Access gives us the ability to have time-limited access to a virtual machine. The reason for this is if we have management ports open because we need to connect to that virtual machine to manage the resource, rarely are we going to have to connect to that resource on a constant basis to be managing it for various tasks. Typically, a lot of times once these are set up, you get them up and running, you configure them, and then you don't touch them unless we need to perform maintenance for a given reason or address some sort of issue. With that in mind, there's a lot of times where those resources are left open and vulnerable because those management ports can be accessed and can be used to compromise that virtual machine. By enabling time-limited access, it greatly reduces our risk that that machine is going to become compromised. We can leverage Azure Security Center to configure just-in-time access. We can either do a broad-reaching scope to where we can apply it to multiple machines at a given time, or we can configure it on a single VM. It allows us to restrict access to given ports. So, for example, some of the common ports would be SSH or port 22, or for Windows machines, we've got 3389 for remote desktop protocol, as well as 5985 and 5986 for Windows RM. Additionally, it gives us an audit history of who and where they were connected from. And we leverage RBAC for who can request access. So we're not only making sure only the correct people can access it, we're also auditing every time they do. To understand JIT as a whole, the first thing we need to do is we need to configure access. In much in the same way that we would configure a network security group, we need to determine the ports and the locations that are allowed to connect to that resource. Additionally, we need to configure how long that resource can be accessed, so the maximum amount of time that JIT can be enabled for. Once we have access configured, we need to now place a request in order to connect to that machine. Again, this leverages RBAC to not only control who can make the request, but also who can approve or deny that request. And additionally, we're also able to go back now and audit who has requested access, who has been granted access, and who has actually connected. JIT is a very helpful utility to give us the ability to help not only control access to our virtual machines and make sure they're not unnecessarily exposed, but also give us that audit capability to make sure we can understand who is connected to a machine and why were they connected, and hopefully help identify any issues that may have been caused by whatever activity was performed on that virtual machine. We've talked about Azure virtual machines. We've talked about virtual networks, as well as network security groups. All those are managed in Azure using the ARM, or Azure Resource Manager. ARM is a management layer within Azure that handles all the deployments, updates, and deletes of Azure resources. Any of the ways that we interact with Azure, whether it's through the Azure portal, Azure CLI, Azure PowerShell, or even the REST APIs, is all interfacing with the ARM management layer. With that said, one of the ways that we can simplify the management of our resources is by leveraging ARM templates. ARM templates are code that define a resource. In this instance, you can see we are managing a storage account, and we can tell that by looking at the type. You can see it says Microsoft.storage/storage account. It also has all of the attributes that Azure needs to know about in order to create that resource or manage that resource. We've got the type, the location, as well as the SKU. What this does is it opens up the opportunity to leverage the infrastructure as code methodologies so that we can define all of our resources using code. So this way it's easy to recreate and redeploy those as we need to down the line. We can download the templates from the Azure portal after the resource is created, and we'll show that in the demo here. Additionally, we can author new templates from scratch, or Microsoft has done a great job of providing a number of quick start templates that give us a building block that we can take those, and if they work for what we're after, great. If not, we can easily edit those so that we can get what we need. Now that we understand the principle of ARM templates, let's take a look at the file types. The basis of ARM templates is the ARM template file, and this is going to contain all of the information. If we look at our past example, everything was defined within that ARM template. This works great for simple deployments. If we needed to create multiple storage accounts rather than have to create multiple different template files, one thing we can do that might simplify it and also standardize it is to create one template file and have that pull information from the parameter file. In that parameter file, we would define the name of the storage account, the location, the SKU, and then any potential tags or any other properties that we needed to define. Once we have the parameter file and the template file, this gives us the ability to create modular deployments so that we can take both of those, make sure we're standardizing our deployments because they're all using the same template file, but each unique deployment or each unique resource gets its own parameter file. Once we have everything together, we can create deployment scripts. And instead of having to go through and manually execute each template and parameter file, we could have a deployment script go through and gather everything and deploy it all at the same time. Now let's take a little bit closer look at the template files themselves. Within each template file, you can define parameters. And a parameter is something that, again, you can pull from a parameter file or you can enter them at runtime. But essentially, these allow you to pass arguments into the ARM template. Perfect example of this would be the storage account name and the location. Within the template file, though, you can take that and define variables. And a variable is something that is essentially calculated at runtime. An example of this would be, instead of having to determine or define the location for each resource, you could create a variable that says, I'm going to look at the location of the resource group I'm deploying to, and I want the resource to be defined in that same location. This way, instead of having to enter that parameter in every time, you create a variable that allows it to be dynamically determined at runtime. Resources. This is the actual resource that's going to be created by the ARM template. You can have multiple resources in a single template, or you can have one resource, but every ARM template will have a resource that it's defining. And then finally, the outputs. For example, if we're creating our storage account, one of the outputs that we can have is the resource ID of our new storage account. Once an ARM template is done running, we can output one or more values. This can help let us know how to access the resources that were created via an IP address or the resource ID. Additionally, you can pass the output to another ARM template. For example, if you create a VNet and a subnet in one template, you can then pass the resource ID of the subnet to another template that will create and associate an NSG with that subnet. So with that said, let's create a VNet using ARM templates. In order to do that, we're going to need to find some properties. For the VNet, we're going to need to give it a name. In this case, we're going to call it example VNet. We also need to give it an address space. So with this, we're going to give it a 10.10 address space borrowing 16 bits. Once we have the VNet set up, as we learned, we can't really do anything with the VNet itself, so we need to create a subnet within that VNet. We're going to create a subnet called example subnet 01, and we're going to give it an address space of 1010/24. To do all of this, we're going to create two files. We're going to have the ARM VNet file, and this is going to be the template file. So it's going to have all of the constructs essentially for creating the VNets and the subnets in there, but we're also going to pass it a parameters file, and that parameters file is going to have the specifics, namely the VNet name, the address space, as well as the subnet name and the subnet prefix. Now that we've talked about this, let's go into the portal and let's demonstrate it. Here we are back in the Azure portal. We've got our Skylines resource group opened up. We've got our existing resources that we've been working with, the Skylines VNet, the Skylines VM, so on and so forth. What we're going to do today is we're going to deploy a new VNet using an ARM template. So in order to do that, let's take a look at the ARM templates that we have ready to go. So we're going to open up VS Code here, and we've got our handful of files. We're going to go ahead and open up the templates file. And if we scroll up a little bit here, you can see we've got our parameters. And I'm going to go ahead and collapse the parameters, the variables, resources, and outputs. Looking at this for the AZ-204 exam, Microsoft doesn't want you to be able to write a ARM template from scratch. However, they're going to be able to want you to look at an existing ARM template and understand what's going on and understand what resources are going to be created. So keep that in mind as we're walking through this. One thing I haven't mentioned yet is that all of the ARM templates are written in JSON. If you're not familiar with JSON, it's really easy to follow. It is, as some would consider, very verbose. The biggest thing to note is that everything is defined within a starting and ending bracket. So if we look at parameters here, we've got VNet name, address prefix, subnet name, and subnet prefix. Additionally, it tells you the type of value that's expected with that parameter. All these are strings, and additionally gives you a description, which you can use to describe what that parameter is defining. We don't have any default values defined here, but if there was a default value from a parameter, you would see that below that parameter name. Scrolling down a little bit and taking a look at the variables, you can see we've got one variable here defined called location, and it's taking a look at the resource group that we're deploying to, determining the location of that, and setting that value or setting the output of that as the value for the location variable. So again, we're not defining anything per se, but at runtime it's going to take some information and create a value or determine a value based upon something else. Dropping down into our resources, we can see here we've got a type of Microsoft.network/virtual networks. Again, the big thing is to be able to look at that type and understand what's being created. It usually is pretty verbose, and you're able to look at that and figure out what's going on pretty quickly. Dropping down a little bit to the name, you can see we're taking the value of the VNet parameter, and we're going to define that as the name of the virtual network. For the location now, we're taking that location variable, and the value of that we're going to use as the location for this virtual network. Scrolling down some, if we take a look at the parameters of the address prefix, you can see that's what we're defining for that VNet address prefix. Going down a little further, again, same. We're using that subnet name parameter for the name of the subnet and the subnet prefix for the address prefix of that subnet. As you look through this, you can see we're not doing anything terribly complex with this. You just need to be able to look at this and understand or break it down step by step to see what's going on. And then finally, scrolling down to the outputs, this is what's going to be presented when the ARM template completes. And you can see here we're getting the resource ID for the subnet as well as the VNet. Moving over to the templates file, again, you can see it is in a JSON format. This one's much more concise. We essentially have one parameter block, and underneath that parameter block, we've got the VNet name, address prefix, so on and so forth. So essentially, we've got all of our parameter names, and then we've got the value for those parameters. So if we take all this and we look at our deployment file here, this is essentially a PowerShell commandlet, new AZ resource group deployment, and it's going to take, or we're going to give it a name of VNet demo. We're going to tell it that it's going to deploy to the Skylines resource group, and then we're going to give it our template file, and then we're going to give it our parameter file. And when this runs, it's basically going to take all those parameters, it's going to pass it into the template file, and then it's going to create whatever resource is defined. So let's go ahead and see it in action. I'm going to copy this, and then we're going to go over to our PowerShell console here, and you can see that I'm already signed in to the Azure portal, or my Azure account here. And I'm going to go ahead and paste this in, and we're going to run it. Give it a couple seconds here. And you can see that it went ahead and deployed. It's successful. And additionally, we can look at the parameters. So you can see the parameter names that we passed in as well as the values that we passed in associated with each parameter. And then at the output, we can see we've got the resource ID of both the subnet as well as the VNet. If we go back to the Azure portal now and do a refresh, we can see our new VNets deployed. If we go ahead and open that up, you can see again we've got the address space we defined, we've got the location of that variable value, and we've got our subnets defined with the appropriate address prefix. Now, one of the things we talked about briefly in the PowerPoints is how do we take an existing resource in Azure and create an ARM template based upon that. The vast majority of resources in Azure, if we scroll down under settings, we have this option for export template. If we select that, we can see that Microsoft has a ARM template output here that we can take and we can download. It's not going to be the same ARM template that we used to create it. However, it is something that if we take that ARM template, we ran it again, it would create this resource exactly like it was. This is really handy for one-to-one options, or basically if you're looking to recreate your environment from scratch. However, if we look at this and taking our knowledge of ARM templates, we can see we've only got one parameter value defined here. We're just defining the VNet name. And if we scroll down, we can see it's already hard-coded the address space, as well as hard-coded the subnet name, as well as the subnet prefixes. This, again, would work just fine if we're doing a one-to-one replacement. However, if we wanted to take this and potentially modularize it or create more than one VNet using this ARM template, you can see we're going to have to edit that template itself. It's better, in my opinion, if you're going to do something like this, to look at it, add some parameters like we did in our template demo, so that this way they're more reusable and more flexible. Additionally, we talked about how Azure has a number of quick start templates. So if we do a quick search here for Azure ARM Quick Start, and we open up this first link here, you can see Azure has a number of resources that are already out there, a number of examples of ARM templates. So let's go ahead and look at this VM Linux Create one. And you can see we've got a parameter file as well as a template file. So let's go ahead and open this one up. If we scroll through it real quick, again, we can see we've got our parameters up here with the number defined. We've got our variable files here, or excuse me, our variables here. And then we've got our resources. And what Microsoft would like you to be able to do is take a look at this file and kind of get an idea of what's going on. With that in mind, we can look at this and see that, okay, we're creating a storage account here. And basically it's getting the name, or its name is coming from the variable storage account name. Here we're creating a network security group, and it's using the variable network security group for the name. Here we're creating a virtual network. Again, they're not looking to have you write these from scratch, but you need to be able to look at an existing template and understand what's going on. With that in mind, I do recommend you do 1 or 2 deployments of this, create an ARM template, or use one of the quick start template that's available. Add some of your own variables, deploy it once or twice just to get some familiarity with it. It'll become immensely helpful, not only for taking the 204 exam, but also as you develop or continue your journey in Azure. ARM templates really are extremely valuable, and ARM is something that you do need to understand or at least have a concept of because it really is the underlying structure of the Azure environment. In this section, we're going to talk about container resources. We're going to start by understanding what is a container. We'll look at how to create a container, and then we're going to do a demonstration of that using Docker. So let's start by understanding what is a container. A container gives us the ability to virtualize an application instead of the entire operating system. This allows us to make the images much more smaller and portable since it needs just to contain the application and any dependencies rather than the entire operating system. The advantage this gives us, again, is that it's more portable, and every time we start that container, it's going to be the same, whether it's on our workstation or they're using a container orchestration tool like Kubernetes. To help us understand this, let's take a quick look at what we learned about VMs and hypervisors. We can see on the same piece of hardware we have multiple operating systems with various applications running on top of them. This works well and has worked for many years. However, it also does require lots of care and feeding to maintain the operating system for each application. If we look at containers, we can still have that hardware as our base layer, but rather than having the hypervisor sit between the OS and the hardware, we now have Docker sitting between the OS and the applications. Again, the advantage here is we can package the applications to just include the application code and its dependencies. We don't need to include the OS and all the associated patches, updates, and various configurations. One thing worth noting is that the images leverage the OS that they're running on. This means we still must maintain the operating system. However, this dramatically reduces the number of operating systems that we need to maintain versus a traditional deployment. It is also worth noting that some containers are based on the Windows OS. However, it is much more common to see Linux-based containers. So now that we understand what a container is, let's talk about how they're created. Since we're going to use Docker to create our containers, we'll use what is called a Docker file to create this. As you can see in this example, this is a file that includes a set of instructions for how the container will be built. In this example, we're going to be building a sample .NET application. As we walk through this, you can see the advantage of containers is that they can be created anywhere. This example will be using publicly hosted images, so as long as you have internet access, you can create this container as well. This is also a multi-stage Docker file, so it will basically create an application and then it will repackage it so it is a lighter, more easily deployable container. To start off with, we can see we are downloading the .NET 3.1 SDK image and also specifying the working directory. We'll then copy the project file to the working directory and run .NET restore. We're going to copy some additional files and then run .NET publish to create the application and place its dependencies in the app folder. In the final stage, we are downloading a new image. This is the runtime image, so it's going to be a smaller image, which will in turn make our container smaller and more portable. We are then copying the output of the app folder from the previous build image, which used the SDK, and then finally telling Docker to run .NET when the container is started. Before we run the demo, I think it would be helpful to talk about some of the basic Docker commands so you can understand what is happening when they are being ran. The first is docker build, and basically this takes the Docker file that we just created and builds it. So it will go through and execute those steps in order to create a container. Docker images, this lists all the images that Docker is aware of. Docker run, this would take one of those images that we found and actually start the container so we can utilize that application. And finally, Docker RMI. If we need to remove an image, we can do this, and that essentially goes through and deletes that container image. Now that we understand the concepts behind what a container is, in this demo we're going to go use Docker to build our first container and then run it locally to ensure it works. So we're back at our workstation here, and what I've done is I've downloaded Docker Desktop. If you want to do that, you can go to docker.com, you can click on Get Started, and then you can scroll down here for Docker Desktop. You can download for the appropriate operating system you're running, Mac, Linux, Windows, all supported. So I've already got that running. You can see I've got the icon here. Let's go ahead and jump into Visual Studio Code and let's take a look at what we have here. So what I wanted to do is just kind of walk through some of the commands that we're going to be running. We're going to start by building a container, and you can see here we've got our command docker build. We're using the -t or the tag parameter, and then we're specifying the name of the container, in this case ASP net example, and we're going to tag that with a version of 0.1. You can see I've got two commands listed there. The first one specifies the path to the directory that contains the Docker file. If you're already in that directory, you can use that second command where it just uses the period in place of the path. That's telling Docker to look in the current directory for the Docker file. So when Docker build runs, it is explicitly looking for the Docker file, which it knows will contain a set of instructions. Once we have the container built, we're going to run Docker images to see our container, and then we'll run Docker run to start our container. And then finally, if we did want to remove our container, we could use the docker rmi command. In this case, we're not going to delete it because we'll use it in future lessons, but I at least wanted to present that to you. So with that said, let's take a look at our Docker file here. And I'm going to go ahead and scroll down here. This is a slightly different one than what we had in the PowerPoints, but the the concepts are essentially the same. You can see we're downloading the SDK image again. We're copying over a few different files into the working directory, but we're still going to copy the files over to a .NET restore, copy some additional files over, do a .NET publish, and then in the final stage, we're downloading the runtime now instead of the SDK. Then it will copy the files that the previous state published to the app folder, and then tell Docker to run .NET when the container is started. So with that said, let's go ahead and see this in action. So again here, I'm just going to copy this full command just so we can see how it would run if the Docker file was in a different directory. So we'll go ahead and paste this and run, and you can see it's starting to execute that command. So step 1 of 12. It's going to go ahead and download the SDK images. So we'll let this run for a while and just follow along. Insert bad joke about movie magic. Alright, now we can see we finished, and you can see it just basically follows along step through step here. So let's go ahead and do Docker images, and now we can see we've got our images here. So this is the image that we created, our ASP.NET example with the tag 0.1. And you can also see it downloaded the SDK as well as the runtime. And if we take a look, you can see the big size difference between the SDK as well as the runtime. So that's why it makes sense to download that smaller image so it's much more portable and easier to move around. So now that we've got it, we've created our image, let's go ahead and run it. So here I'm just going to execute the docker run command, and you can see we're basically doing docker run. We're using the -d or detached parameter so that it runs in the background. We're also specifying the port that's going to connect to. So basically we're saying we're mapping port 8080 to port 80, which is the container is listening on. So essentially it's just a translation. So we'll be able to access that port on 8080, which Docker will translate to port 80 for the container, and then we're specifying the image. So ASP.NET example 0.1. So let's go ahead and copy that again. We'll paste it here and run. We can also do a docker ps, and now we can also see that the container is running. You can see that it's doing that translation of port 8080 to port 80 on TCP, and it started a few seconds ago. So now let's go back to our browser. Let's open up a new tab. We'll do localhost 8080. And there we go. We've got our Skylines Academy container demo. So perfect. Looks like it's up and running. Let's jump back into the PowerPoint and see what's next. We have our container created, but if it's on our workstation, it won't do others much good. So this module we're going to learn about using the Azure Container Registry. Azure Container Registry gives us the ability to store our containers in what's called a private registry or private Docker registry. This means that others can access those containers. Additionally, it can be utilized with Azure Kubernetes Service, App Services, Service Fabric, Batch, or Azure Container Instances, which we'll learn about coming up. The big advantage here, it's stored in a location that others can access, and more importantly, that other resources can pull from in order to run those containers. Additionally, there's also the Azure Container Registry tasks. And what that does is it's a feature that gives you the ability to automatically test to ensure your containers build properly. It can also update dependencies within the container or the base images to help address any security vulnerabilities. So if Microsoft was to release an update to one of the base images that were in our example container, whether it's the SDK or the runtime, Azure Container Registry tasks would be able to apply those updates to our container and then verify they are still building successfully. We talked a little bit about some of the Docker commands when we built our image. However, there are a few more commands that I think we need to know about as we start to move our images from our workstation up to the Azure Container Registry. The first one is Docker pull, and while we might not be using this one today, it is helpful to know that you can use this command to pull an image from a registry, whether that's a private registry like the Azure Container Resource or a public registry like Docker Hub. You can still use that same command for both. Docker tag. And this creates a link between a target image and a source image. For our example, we'll be using this to specify the target path for the sample image that we created. And finally, Docker push. What this does is it takes an image and pushes it up to a registry, whether that's, again, Azure Container Registry or ACR or Docker Hub or some other registry that you're using. Let's walk through the steps that are needed to push an image to an Azure Container Registry. To do this, we're going to use a combination of Azure CLI and Docker commands. The first thing we need to do is authenticate with the Azure Container Registry. This is where Azure CLI comes into play. You can see we're running the command ACR login, and then we're specifying the container registry name, in this case, Skylines Demo ACR. Next, we're going to tag the image. And if we remember, this is where we basically associate a target for an existing image. So while it looks like this command is split over two lines, unfortunately it's just the way it had to happen in order to make the text fit on the slide. But we're running Docker tag, we're specifying our source image, which is ASP.NET Example 0.1, and then we're specifying the target, which in this case is Skylines Demo ACR.io in the demo repository with the image ASP.NET Example version 0.1. And then finally, we're going to use Docker push to take our source image and push it to the target location. So again, the command Docker push, specifying the target. Since we ran the tag command above, it knows where that source image is, and it will then take that and push it to the location. One thing worth noting is that you can see all Azure ACRs are going to have AzureCR.io as part of the URL. That's a dead giveaway that you are working with an Azure Container Registry. So with that said, let's take the sample image that we created earlier and let's push it up to an Azure Container Registry. So here we are in Azure. You can see we've got the Skylines Demo Container Registry already created. If you go down here and look at repository on the left, you can see we currently have an empty repository. So let's jump back to Visual Studio Code. And as we talked about in the PowerPoint, we're going to walk through the following steps to associate or log into the Azure Container Registry. We're going to tag the sample container image that we created earlier and associate that with the Skylines Demo Azure Container Registry. And then finally, we're going to push that container image up to Skylines Demo ACR. So that first, we'll go ahead and again, we're just going to log in using the Azure ACR login command, specifying the container registry that we're attempting to authenticate with. Looks like that completed successfully. So now we're going to go ahead and do the tag command. And again, this is associating a source image with a target image. In this case, we're using the sample container registry, or excuse me, the sample container image we created earlier with the Skylines ACR, and that completed. So now finally, we're going to go ahead and push that container up. So let's go ahead and copy that last command and paste it. And here we should actually see much in the same way when we created our container to where it had to download the image or download the SDK as well as the runtime. Now we're taking that and we're pushing it up to Azure Container Registry. So essentially, Docker push. So we'll give this here another second or two to finish up. And look like everything's uploaded. So now let's go back to our Azure Container Registry in the portal. Let's do a refresh here. Perfect. We can see in the demo repository, we've got our ASP.NET example. If we open that up, we can see we've got an example up here with the 0.1 tag. Awesome. So now that it's uploaded, let's go back and figure out what we can do with this image now that it's in the ACR. Now that we have taken our container image and uploaded to Azure Container Registry, let's take a look at one of the ways that we can run that container within Azure. Azure Container Instances, or ACI, give us the ability to run a container without having to manage the underlying infrastructure. We assign the amount of CPUs and the amount of memory we want available to that container, and Azure takes care of the rest. One advantage to this is it removes us from having to worry about managing any of that, as well as it also allows us to integrate with event-driven tools like Azure Functions or Logic Apps so that we can create more containers under certain conditions or scale back depending on the need without having to manually manage any of that. Additionally, we can run Windows or Linux-based containers from within ACI. By default, all of our containers can be publicly accessible, and Azure provides us with a fully qualified domain name in order to be able to access them. It also encrypts it using TLS certificates, so all of our traffic is secure. All of the container instances are fully isolated, so we don't need to worry about crosstalk from one container to another. And monitoring is enabled by default. And since we don't have access to that underlying operating system, this becomes very critical when we're identifying any performance or troubleshooting issues. Additionally, if we need more in-depth information, Application Insights is also available. So now that we understand a little bit more about ACI, let's look into deploying a container using ACI. So we can leverage a container stored in a variety of locations. Azure Container Registry makes sense since that's what we're talking about as of late, but we can also leverage a public image hosted in a Docker Hub. Or if you've got another public repository, you can use that as well. In addition to private repositories, as well as Microsoft offers a couple built-in images to help you get started. When we have ACI, we've talked about being publicly accessible using a fully qualified domain name. That's certainly an option, but Azure recently added private access using VNets. So rather than having to access that container using the public internet, if you want the container to be securely accessed by resources within an existing VNet, you can associate that container instance with an existing VNet so traffic never leaves Azure. And you also have advanced options. So if you've got environmental variables that you need to pass to that container, you can certainly do that, as well as command line arguments. So if there's a command that needs to be ran when that container is started that isn't in the Docker file, you can pass that along to that ACI. So now we've talked about it quite a bit. Let's go into the portal, let's set up an ACI, and let's look at these options for ourselves. Here we are in the Azure portal. You can see we're in the Skylines resource group, and we can see we've got the Skylines demo ACR container registry down below. So what we're going to set up now is we're going to create a container instance. So the easiest way to start is we'll go up to the top, we're going to search for container, and you can see one of the first options there is container instances. So we're going to go ahead and select that. You can see we don't currently have one there today. So let's go ahead and click create a container instance. We'll leave the default subscription. We're going to put this in the Skylines resource group. And then for the container name, let's go ahead and just call this demo ACI. We'll leave the region as the default. And when we were talking earlier in the PowerPoint, you can see there's a number of different options. So you've got some built-in images that are available. And if we go ahead and select these, at the time of the recording, you can see we've got 2 Linux ones, as well as a Windows image that's running on IIS. We can also select Azure Container Registry, or we can select Docker Hub or other registry. And if we select that, you can see it's basically asking for the image path. And if it's a private registry, you can see it's also asking for some information to authenticate to that private registry. Since we're running a container that's currently saved in Azure Container Azure Container Registry, let's go ahead and select that. You can see it defaults to the Skylines demo ACR, and since we've only got one image in there, it automatically selects the image as well as the image tag. So if we had multiple containers in that registry, we could select the drop down to choose the appropriate container as well as the appropriate tag for that container. You can see when it looks at the container, it's able to determine that it's using a Linux operating system, and then now we can go ahead and select the size. So let's go ahead and hit change size. We'll leave the number of CPU cores default, and let's go ahead and reduce the memory to 1 GB, and then we'll hit OK. Now let's go over to the networking, and then here we can determine how this ACI instance will be accessed. If it's public, we need to provide a DNS name. If it's private, then we can go ahead and determine which VNet we're going to place that on. Let's go ahead and leave ours as public for now. We'll call it Skylines Demo ACI. It looks like that's not being used, which is perfect. It's going to ask what ports we're going to use to communicate with that container. And if we remember back when we first set up or did the docker run command, you remember it was using port 80, or we were translating to port 80 when we ran that. So we're going to leave the default here of port 80 because that's what the container is going to be listening on. We can go to the Advanced tab, and you can see we've got a restart policy. If we need to provide any environmental variable information to that container, we can do that, as well as a command override. So if there's a command that needs to be ran when that container started that wasn't specified in that Docker file, we have that opportunity to provide that. We're going to leave these as a default. We're not going to specify any tags for the time being. Let's go to review and create. Looks like it passed all the validation steps. So let's go ahead and hit create here, and we'll let this go through and process. All right, looks like that completed successfully. So let's go to resource. And if we go down here, you can see some basic metrics. You can see it just started, so it hasn't really populated anything yet. But you can see we've got our fully qualified domain name here. So if we copy this, let's open up a new tab and paste that in. And you can see now we've got our container that's running. This is the same container that we saw running when it was on our local workstation. Now it's running in the Azure Container Instance, so it's publicly available to anyone who has that URL. So we're going to go here, let's generate some data. So let's send a bunch of requests to it. And now if we go back, now that we've accessed the page a number of times and we've generated some traffic, let's go back to the ACI instance and let's look at some of the monitoring information. So if we go back to Azure and scroll down here, we can see we've got some CPU activity. We can see the memory being utilized. We can also see the network traffic, so the amount of requests received and the amount of data transmitted. So it helps gives us some good information as far as what's happening on that Azure Container Instance, as well as if we need to assign more resources to it, or if we can pull that back a little bit to save some money. Hopefully this has given you a good introduction to containers, as well as giving you how you can use those containers within Azure by leveraging the container registry as well as container instances to run those containers. Now, let's dive into the next module. In our last section, we looked at hosting containers in Azure Container Instances. In this section, we're going to explore app service plans for hosting our web-based applications. So let's start by understanding what app service plans and web apps are. An app service plan are Azure's Platform as a Service, or PaaS, offering to host your HTTP-based applications. App service plans are what provide resources to the web apps, or the actual applications. One app service plan can host one or more web apps depending on the workload of each web app and the tier of the app service plan. The higher the workload per web app, the lower density of web apps that you can host on your app service plan. The lighter the workload of the web app, the greater density of web apps you can host on a single app service plan. You also have an SLA of 99.95 in most app service plan tiers, the exception being the free and shared tier. Additionally, you can scale out or up automatically to accommodate your workloads. Between the two, this helps ensure your web application should be available for consumption in almost every situation. Additionally, since all code should be stored in some sort of source control, Azure App Services will work with any Git repository in order to support automated deployments. Before we go too much further, let's talk about the type of HTTP-based applications that can be hosted in Azure App Service plans. First and foremost, and probably the most common, is web apps. This is what most would consider a website. This would also include API apps, which are used to host REST APIs. Another very common type is mobile apps. Mobile apps have features built in that make it easy for your mobile app developers to focus on the code rather than worrying about things such as authentication, data access, offline sync, and push notifications. And one that is becoming more and more common is Azure Functions. While the functions do not require an app service plan to run, if you already have one, you can leverage one to host your Azure Functions and make the most use of your existing spend. App service plan features. Since there is a wide variety of workloads, there is also a variety of tiers for hosting your app service plans. This can include anywhere from the free tier that offers some basic features up to an app service environment, which you have a fully isolated and dedicated environment. All app service plans support CI/CD, so you can automate the deployment of your web applications. And similar to Azure Container Instances, App service will support workloads designed to both run Linux as well as Windows. Additionally, you can also run a container in an app service plan as well. It also supports a wide variety of languages. At the time of this recording, it included many popular languages like ASP.NET, ASP.NET Core, Java, Ruby, Node.js, PHP, and Python. Additionally, you can also create static HTML sites in there. And one of the key advantages of web apps is the ability to authenticate users to a wide variety of third parties, or using Azure Active Directory. Some of these third parties can include Google, Facebook, Twitter, and so on. One of the most important parts of any web application is the ability to update it over time. There are a variety of ways in which we can push our code up to a web app. These include FTP, or File Transfer Protocol. You can deploy from a package. You can use Git, and that's whether it's running local on your workstation or if you're using a repository that stores that code somewhere centrally. And then finally, Cloud Sync, which is either OneDrive or Dropbox. So when you update the code stored in OneDrive or Dropbox, it can then be used to update your web application. One advantage to web apps is deployment slots. And deployment slots give us the ability to have multiple versions of a web app running side by side. We can have our production code running in one deployment slot and be testing the QA code in another deployment slot. Once the QA code has passed all the tests, you can simply swap the slots. So the QA code is now in the production slot. It is now serving revenue generating clients. Since the QA slot was already warm, there's no downtime as you make the transition. Additionally, Azure will ensure that all sessions are gracefully switched over to that new slot. And if we do run into any issues with the new production slot, we can always swap the code back so that our previous version of production was running again and now facing our revenue generating clients. Now let's jump in the portal and create a sample web app. So here we are back in the Azure portal. You can see again we've got our Skylines resource group opened up. And what we're going to do is we're going to create an app service plan. We're going to set up a web application on it, and we're going to validate everything works like it's supposed to. So to get started, we need to create the app service plan. So to do that, let's go up to our search bar. Let's type app service plan, and we can see we've got our option right there. And if we open it, we can see we do already have one app service plan here. Eng app service plan 001. You can also see that the pricing tier is using the shared pricing tier, which we'll talk about here in a second. Like I said, we're going to create a new one. So let's go up here to add. And then now we've got the very familiar screen. We're going to go ahead and select the resource group of Skylines. Let's give it a name of Skylines ASP01. We are going to set the operating system to be Windows. And again, since this is the underlying resources that are going to be provided to our app service plan, we need to specify the operating system that it's going to be running on. So we'll select Windows. We'll leave it in the default region of Central US, or my default region, I should say, of Central US. And then we can see here now we get to the pricing tier. Let's go ahead and open this up. And let's start by taking a look at the dev test pricing tiers. So you can see we've got our free tier of F1, which has some limited resources available, but gives us the ability to basically have a free website. If we move up to the shared tier, which is what our other app service plan was, you can see here our cost goes up a little bit, but now we get the ability to purchase custom domain names. And if we go up one level to the B1, now Azure is providing information in ACUs, which if we go back to our virtual machines or infrastructure as a service, ACU is how Azure essentially provides a benchmark for how much compute capacity is available for that resource. If we scroll down now, we also notice we get some additional storage. It goes from 1 gig to 10 gigs. And we have the ability to add a custom domain or SSL, as well as the ability to manually scale. Let's go ahead and take a look at some of the production workloads now, or production options, I should say. And now you can see not only does our storage go up quite a bit from 100 gigs to 50, or excuse me, from 10 gigs to 50 gigs, we also have the ability to auto scale now. We also have staging slots or deployment slots. And now we get backups as well as traffic manager. So as we move from the dev test to production, our web apps have the features necessary for a true production environment. So let's scroll up again. You can see we've got the various tiers available here. So we've got S1, which, as you can see the specs here, 100 ACU for processing, 1.75 gigabytes of memory, and then it goes up depending upon there. So with that said, let's go ahead and select the default here of S1 for our example. We'll hit apply. And now let's go to tags. We're going to leave those as blank for the time being. Review and create, and then create. So now this is going to run, so it shouldn't take too long, but we'll let this environment spin up here. Once the app service plan is created, then we're going to go ahead and add the web apps to it. So it looks like that's done. Let's click go to resource. So you can see here we've got our app service plan created. You can see we've got 0 apps, 0 slots deployed. If we go to apps, again, we've got no results here. So let's go ahead and fix that. Let's type in web apps and select app services. You can see we've got the existing app service, or one existing web app that's deployed to that other app service plan that we saw earlier. Let's go ahead and add, and we'll again select the Skylines resource group. Let's call this Skylines Demo Web App. It is going to be running code. Again, we had the option if we wanted to run it as a Docker container, we could, but we'll leave this as code for now. We're going to select our runtime as .NET Core 3.1, and you can see we have the option to choose some of our existing app service plans. Those were created using a Windows app service plan, so if we select the operating system for our web app to Linux, you can see we cannot select our one of the existing app service plans. We have to create a new one. We'll go ahead and change that back to Windows. We'll select the Skylines app service plan. We'll go to monitoring, and here we have the option to create application insights or enable application insights if we like. Let's go ahead and we're going to turn that off for the time being. We have the option to create and assign some tags. We'll leave that blank for the moment. And now we're going to go ahead and review our settings, and then we're going to go ahead and select create. So while this is deploying, what I've done is I've created I've got a Git repository over here that I have a sample web application set up. So I'm going to go ahead and copy this. And now we'll go back to the portal, give it a moment for our resource to finish deploying, and look at that. So let's go to resource. And you can see here, let's go to our deployment center. And actually, before we do that, you can see our resource here. Let's open up the web page, and you can see there's nothing here. So let's go ahead, or basically it's a filler page, I should say. So let's go to the deployment center. We've got a couple different options for how we can deploy our code. You know, if we're looking at our CI/CD deployment, we can use Azure Repos, GitHub, Bitbucket, or if we've got a local Git we could do that. Since we're using a public Git, we're going to go down to the manual deployment, and we're going to select external. So we go ahead and select that, hit continue, and now let's paste our repository value in there. We're going to leave the branch of master. We're going to select the private repository. We'll leave that as no. It is a Git repository, so we'll leave that. We'll hit continue and finish. So now you can see it's going to communicate with that repository, and now it's going to basically look at the last check-in that was done at that repository, and it's going to pull that code in and then build that site within the web app using .NET Core 3.1, since that is a runtime that we chose when we created our web app. And now after a little while, we can see that it is now active. So let's go back to the home page, or let's go back to the app service plan. Let's go ahead and select that URL. Perfect. Now we've validated that our web app's up and running. Let's jump back into the slides and take a closer look at some of the options available within the web app. We talked briefly about our web app in the last section, but this time we're going to dive a little bit further into these. Now that we have our app service plan and a sample web application up running, let's take a look at some of the settings we can configure on it. So we have some language-specific settings that we can configure. These are unique per language, but have some common examples, such as setting the version of the language, startup processes, as well as running custom commands. Another option is connection strings. If we have data in another platform and we need to configure our application so that it knows how to connect to that and how to authenticate. For added security, if there are any secrets that are part of that connection string, we can leverage Azure Key Vault so those secrets are referenced in the connection string but kept securely in the Key Vault. SSL settings are a common item, and this allows you to configure the minimum TLS version as well as if HTTPS is required when using the web app. Depending on the plan, you can also use a custom certificate to secure your site. And by default, your web apps will have a public name under the azurewebsites.net domain. You also have that option to create a custom domain name as part of your website. App Service Plan metrics are extremely useful to help keep an eye on your applications. Much in the same as we discussed about ACI, we won't have access to that underlying OS, so we need to rely on the metrics to help identify issues. In addition to helping us troubleshoot our websites, these can also be used by auto-scaling rules to scale our app service plan as our workload increases or decreases. There are a number of metrics that are useful to help us identify performance issues. I've highlighted some of the most common below. We've got CPU and memory percentage. Again, this just helps us see how hard our resources or how hard our app service plan is working. We've got data in as well as data out to see how much traffic and bandwidth we have. Disk queue length to help us see if our storage subsystem is causing a bottleneck for us, as well as HTTP queue length to see how much of a backlog for the requests that we have before they're being processed. There are different diagnostic settings that can be configured depending on where you're logging. All the options we're going to show here below are available for Windows-based web applications. For Linux-based web apps, only the application logging is available. So with that said, one of the first ones is application logging, and these are messages that would be generated by the code you're running within the web app. We've got web server logging, which is the raw HTTP request data in W3C extended format. We've got the detailed error messages, and these are copies of the .htm error pages that would typically be sent to the client browser, essentially anytime an HTTP 400 or greater error occurs. We've got failed request tracing. Detailed information about the failed requests. This includes a trace of the IIS components used and the amount of time each one took. And then finally, deployment logging. And these are logs that are generated when we publish content to our web application. In this section, we talked about some of the various configuration options as well as some of the metrics that we can configure in our application and web apps. Now let's jump in the portal and take a closer look. So here we are back in the portal. We've got our Skylines demo web app pulled up, and if we scroll down a little bit, you can see we've got some of the basic metrics listed. So if there's any server errors, so HTTP 500 errors, the amount of data in, data out, response time, number of requests, so on and so forth. So it at least gives us some basic information to where we can see pretty quickly, okay, has the number of responses increased to the point to where average response time is also increasing, so we know we're hitting some sort of bottleneck. Do we have any server errors? Basic data in, data out sort of stuff. If we wanted to take a look now at some of the settings per se of the web app, if we scroll down on the left side and go to configuration, here we can see some of the basic application settings. If we have connection strings, again, that we needed to add so that we were able to communicate or access data that resides somewhere else. We've got general settings here, which again, just the stack that we're using, versions. Always on forces a website to essentially stay warm even if there's no traffic. So if the first person to access the site after a few hours of downtime, it will be the same experience as the 100th person to access that website. If you're looking to utilize application insights for your web app, you need to ensure you have enabled always on. And it is also a requirement for continuous web jobs. Debugging, certificates, some basic certificates, so on and so forth. Default documents, if we needed to change something in this regard, or if we needed to alter the path mapping. So you can see by default, the root virtual path points to the www root path. If we scroll down a little bit under the TLS SSL settings, you can see we've got our minimum TLS version set to 1.2. We do allow HTTP traffic today. We can change that by setting that to on. If we had a custom certificate imported, we would be able to set the binding here. You can see up here is where we would take care of importing those certificates. If we go up a little bit to custom domains, you can see right now we are just using the default one here of Skyline's demo web app.azurewebsites.net. If we wanted to go ahead and add a custom domain, we had the option here, or we could buy one too as well as we like. So with that said, let's take a little bit closer look at some of the metrics. I know we saw some of the preview ones when we were on that home page, but if we scroll down to on the left-hand side down to metrics, under the monitoring category, you can see here we've got a number of different metrics that we can look into. So let's take a look at just CPU time. You can see we had a little bit of a spike there when we first got our website set up, but it's been falling back since then. We can scroll down a little bit to look at the various HTTP response codes, and say, for example, we wanted to do HTTP 400x or any 400 errors, we could do that. I had intentionally generated them by trying to basically go to a path that wasn't valid on the website, just to show show that on the metrics. Additionally, we can scroll down some more, and you can see your memory working set. You can see your response time. So this would be another good metric if you're looking for scaling, auto scaling. If your response time hits a certain threshold, okay, let's look to see if we can't scale out some. If you know based upon your application that is a good metric to look for. You can see we've got a number of different ways on which we can look at the information in our web app to help understand what is going on and the overall health of our web application. If we scroll down a little bit more, you can see we also have our app service logs. And as we discussed during the slides, here's where we can turn on those various options. So if we wanted to enable application logging, which would basically be from the code itself, we can select that and then choose the level that we want to be notified on, or level that we want to log on. If we want to log to be error, warning, information, verbose, etc. We also have the web server logging for W3C logs, error message, failed requests, so on and so forth. If we actually look here, we've got app logging to the file system. We also have application logging to a storage blob as well. So when we do turn this one on, it's going to be logging to the file system of the web server itself. If we turn this one on, it's actually going to be logging to blob storage. And you can see here we can select the same level, but now we can also go through and set what storage blob we're going to be saving it to, as well as the retention. Let's jump back into slides and learn a little bit more about scaling within app services. In this section, we're going to learn about scaling resources in Azure App Services. Given all the capacity available to us in the public cloud, scaling, sometimes referred to as bursting, has become a great mechanism for optimizing costs and ensuring the performance of your application. The ability to scale a web application is what gives us the flexibility to handle dynamic workloads in a cost-effective manner and becomes an example of where the cloud really starts to make sense. Scaling to handle an increased workload comes via two ways. We have the ability to scale out, also sometimes referred to as horizontal scaling. It's when you need additional virtual machines or instances to run your application. By scaling out in this instance means we're adding additional app service plans. So as one does not become enough to handle the workload, we can add 2, 3, or 4. We can scale all the way up to 20 instances depending on your pricing tier. Another way we can do this is what's called a scaling up, and that's essentially adding more resources to an existing app service plan. We can do this by changing the app service plan tier. So in this instance, you can see we're adding more resources, so we're adding or scaling our tier up within the existing app service plan. When it comes to scaling, there are a few different approaches that we can take. Understanding your workload will help you determine the proper way to scale your application or scale your resources. For example, if you know your application will exhaust your memory long before the CPU utilization becomes a bottleneck, it makes more sense to scale based on the amount of memory available versus the CPU utilization. Let's take a look at a few of the approaches that are available. We've got the scale based on an infrastructure metric. This would be something like CPU utilization or memory utilization. It's very simple to configure, but sometimes you might not get the best results because we're looking at one metric. Another approach is scaling by an application metric, and this could be something that's gained by using application insights. And rather than looking at just specifically CPU or memory utilization, this could give us a performance-based metric to see how long does a page take to load. If the load time goes above a certain threshold, then we know we're potentially running into a bottleneck, so let's have a scale event. Another way we can do this is scale to specific instance counts. Say, for example, during a given period, your workload is going to increase dramatically. So rather than let the auto scale rules take into place, I'm just going to say I'm going to have an additional 3 instances running during this time frame. Or on the flip side of that, if during your off-peak hours, let's go ahead and let's scale down. We know we're only going to need 2 to 3 instances. Let's go ahead and do that rather than having to wait for those auto scale rules to happen. Once you've decided on your approach, then you need to configure your rule set. First, we need to configure the criteria for your rule. This is the metric that you're going to use based upon an action. For example, anytime the average CPU utilization is over 70% for a period of 10 minutes. Next, you decide the action to take and the cooldown period. The action could be to increase your instance count by 1, or you may more aggressively expand by 2 or 3, or leapfrog all of this and go to a specific instant count. There are multiple options you can configure here based upon your application requirements. The cooldown time is a time in minutes that will need to pass after an action takes place before the rule will be evaluated again. This ensures we don't continuously add resources without allowing enough time for the previous action to have taken effect. One thing to keep in mind as we're creating skill rules to scale out based upon various activities, we also need to make sure we're configuring a rule at the same time to scale back in. We don't want to have our period of heavy activity and scale up to meet those needs and then not have any rules to scale back in, so we have all those additional resources out there running, increasing our spend without providing any value. So anytime we create a scale out rule, it is also wise to create a scale in rule at the same time, ideally based off the same metric. Remember to take into account the session state for your web application if you're utilizing scale sets. When an instance scales down, they could be removing web apps which were previously had traffic. The next time the user connects to that external website, they will be directed to a different instance, so it is important that their state is maintained using a SQL database or Redis cache. We talked about scaling and scale rules in this session. Let's jump in the portal and take a look at how to put this into practice. So here we are back at our web app again, and now what we're going to talk about is scaling. And remember that the web app itself doesn't per se care about resources. It will use everything that's available to it if it's needed. Since we define the amount of resources at the app service plan, whenever we talk about scale, we need to make changes at the app service plan level. So with that said, let's go ahead and open the app service plan. And let's go down here onto settings to scale. So let's talk about scale up first. And if you remember, when we're talking about scale up, that's not adding additional instances, that's adding more resources to the existing instance. So with that said, we're currently at the S1 tier, which has 100 total ACU and 1 3/4 gigabyte of memory available. You can see here, while we don't have options for the Premium V2 scale units, we do have options under the S2 and S3 pricing tiers. So let's take a look here. You can see if we wanted to essentially double, we could add the S2 instance, which doubles the amount of ACU as well as memory. And if that still isn't enough, we can move up to an S3, which has, again, double the amount of capacity from the S2 or 4 times the amount that we have today available from the S1. So we would go from 100 ACU to 400 ACU and 1 3/4 gigabyte of memory all the way up to 7. That being said, the cost jumps accordingly. So we'd basically pay 4 times as much as we are right now to move from the S1 to the S3. With that said, if we needed to scale up a app service plan, this is how we would do it. We would go into the scale up setting, choose a new pricing tier, and let it run. The advantage to this is that it's a one-time change. We don't need to worry about anything else. The disadvantage to this, though, is that it's that one-time change, so that price is going to automatically increase. And even if our workload decreases, we're not automatically going to scale down to have those savings or basically realize those savings. So with that in mind, the scale out option is something that people tend to look into a little more frequently. And again, the scale out option, essentially, we're going to keep the same size or the same amount of capacity available at our app service plan, but we're going to have more instances. So we would have one unit that had, again, 100 ACU in this instance and 1.75 gigabytes. Or if we scaled out, now we have 2 units available. So essentially the equivalent of an S2, and then so on and so forth. So we can increase all the way up to 10 for this particular tier. So this works well if you know that you've got a increase coming and you want to manually do it and don't have to worry about Azure handling that. However, one of the benefits of the cloud is automating this. Let's take a look at auto scaling. So if we select auto scaling, we have the option now. We can give it a rule name, and then we have a couple different options. We can set the scale mode, which basically means Azure is going to look at a given metric that we define, and if it exceeds a threshold or drops below a threshold, we're going to make a scaling decision based upon that. Alternatively, you can scale to a specific instance count based on a schedule. So you could define a schedule that says between Monday at 7 a.m. to Friday at 5 p.m., I'm going to scale up. And then during the weekend, I'm going to scale down. Or you might have that just during business hours or however, but that gives you the ability to essentially manually scale, but on a schedule and have the process be automated. We're going to look at scaling based on a metric in this instance. Let's go ahead and leave the default of scale based on metric, and let's go down to add a rule. So similar to what we looked at in the PowerPoints, you can see here we've got a scale rule. And we can do a couple different criteria, the average, count, max, min, so on and so forth. We'll leave it as a default for average, and we can look at the metric name. You see here, we've got a number of these metrics available, are very similar to what we saw when we looked at the metrics underneath the app service plan. We're going to leave the default of CPU percentage. So and if we scroll down now you can see where we get into the operator, or basically where we set those thresholds. So what we're saying in this instance is if the CPU utilization is greater than 70% over a 10-minute period, we're going to increase the count by 1, and we're going to give it a 5-minute cooldown period. So essentially, if our CPU threshold is above 70% over 10 minutes, we're going to increase the instance count by 1, and then we're going to wait 5 minutes. We're not going to look at anything. We're going to let that additional instance come into play. We're going to see if that addresses our workload issue. And if it does, then we're not going to do anything. We're just going to sit there and continue to monitor, but we're not going to make any changes. If we add that additional instance after 5 minutes and our CPU threshold is still above 70%, we're going to auto scale again. That will repeat until that threshold drops below 70% over 10 minutes, or we hit our maximum instance count. With that said, let's leave these defaults and we'll go ahead and click add. Now you can see we've got our scale out rule. And when the CPU utilization is greater than 70%, increase by 1. And you can see down below, here's where we've got our instance counts, our maximum as well as the minimums. Like we mentioned during the slide though, anytime we create a scale out rule, we should also create a scale in rule. So let's go ahead and add another rule. We're going to leave all of these by default because it should essentially match the same scale out rule, or should use the same concepts as our scale out rule. However, instead of being greater than 70%, we're going to select the operator to be less than 20% over that same 10-minute period. And this time we're going to decrease the count by 1 with the same cooldown period. This is essentially using the exact same concept, except if the CPU utilization is below 20%, we're going to say our usage is relatively low, so we don't need all of those instances. So we're going to go ahead and remove one. And we'll go ahead and click add here. And this will continue to happen if our CPU utilization keeps dropping below 20%. It will go ahead and keep scaling down until we hit our instance limits, which in this case is 1. So again here, we've got our scale out rule for when our utilization is very high, and then we also have our scale in rule when our utilization is low. This way we're being as efficient as we can within Azure to help reduce our spend. That covers scaling within app service plans. I would recommend going through and creating a scale rule or tool, or at least looking through the interface so you understand what happens. As you take your exam, don't be surprised to see a question on the scale rules, and you need to understand if you look at a scale rule, what's happening. In this section, we're going to discuss Azure functions. So let's start by introducing Azure functions and how they can be utilized. Similar to an app service plan, Azure functions run code without us having to worry about the underlying infrastructure. But two big differences is that Azure functions aren't restricted to just HTTP-based applications, and that Azure functions only run when needed. Once their given task is completed, they shut down. This is Microsoft's serverless offering. Again, there is a server, air quotes, or compute resources in the backend, but it is not something that we need to worry about managing. Functions use a trigger to start the process. These can be a variety of things which we'll talk about shortly, but essentially once a trigger has been fired, that function will start, run the code associated with it, and then output whatever value is needed. Once that's done, they shut off. While an Azure function running a bubble that only outputs data has some use, the real value comes when you can pass data to the functions. We use bindings to allow data to be passed to a function which can then process that data. We would also then use a binding to output that data once everything's complete. Depending on how your functions are configured, you can have one function call another, so you can have a multi-step process that can use logic depending on the original data. There are a few different pricing models that you can use depending on the frequency and the time sensitivity of your requests. As you can see, there is a wide variety of supported language available to Azure functions. Version 3 is the most current version of Azure functions at the time of this recording. We can see we've got C#, JavaScript, F#, Java, PowerShell, so on and so forth, and a couple different varieties of each language. So we talked a little bit about triggers earlier. Trigger essentially initiates a function or causes a function to run. With this in mind, there can only be one trigger per function, so we're not allowed to have a function that starts based off of one or more things happening. There are a variety of trigger types available to functions which we'll review shortly. The triggers are defined within the functions.json file. We can see in this example we have an HTTP trigger. Since that trigger is externally generated and passed to us, the direction is set to in. Depending on the trigger type will depend on the details associated with it in the functions.json file. We'll dive into this file during our demo, but this example just shows the basics of how a trigger is defined. As mentioned, there's a wide variety of trigger types available. As we just saw, there's an HTTP trigger request. Essentially, this trigger is just an HTTP request that comes in, which will start the Azure function. There's a timer job, and this would be similar to a cron job in Linux or a scheduled task in Windows. The function will start on a given schedule. If you have other resources that are writing to the service bus in Azure, you can have a function that listens to that and responds accordingly. It will work with both service bus topics and queues. Much in the same way with Event Hub. If you have resources that are sending information to the Event Hub stream, you can have Azure functions monitor that. As with Cosmos DB, you can essentially monitor the change feed for inserts and updates and process events accordingly. And same with storage blobs. Whether it's a blob or a queue, if you have blobs that are being updated or created, you can use that information to initiate a Azure function. We also have a link at the bottom to discuss more about triggers, and ironically enough, it also talks about bindings. Speaking of bindings, we talked about this briefly, but this is how data is passed to and from an Azure function. Each binding has a direction, whether it's in or out. There are some use cases when the bindings can be both. We can see in this example, we have a queue trigger which has a direction of in. While it is a binding, because we have a direction of in, it is also essentially a trigger, so it is looking for data to come in. So if an item is added or updated to the storage queue, that data will be brought in to that Azure function or utilized by that Azure function. Once the data has been processed, we have an out binding which is connected to a storage table. So the function will start, pull the information in from that storage queue, do whatever processing is needed, and then output it to that storage table. There are a wide variety of bindings available to Azure functions, but this is just one example. So now that we've talked more about an Azure function and understand some of the components of it, let's talk about the various plans associated. The first is a consumption plan. With this plan, the billing is based entirely on the number of executions that are ran and the amount of resources those executions take. You only pay for the time and resources that your function runs. It will scale automatically based on the frequency of the triggers. So if you have just a handful happening, you only have a handful of instances running. But if you have thousands of them, you can have thousands of instances running. Azure will take care of all of that scaling on its own. Again, you just pay for what is needed. Since it only runs when triggered, there can be a warm-up period where the compute resources need to be allocated. Depending on the time sensitivity of your workload, this may or may not be an issue. With the premium plan, we have all the same features of the consumption plan, except that the functions are kept perpetually warm. So that delay from when it is triggered to when the actual function runs is much smaller. It also supports VNet connectivity, so if you want to have a function talk directly to resources within a VNet, you have that option within the premium plan. And with that said, since it is running all the time, there's going to be a cost associated with that function, regardless of whether it's in use or it's idle. The final option is a dedicated plan, and what this does is it actually leverages an app service plan to run our Azure function. This is a good option if you have an app service plan already that's used for other web apps, but it is underutilized. Since you're already paying for it, this allows you to leverage it to run your Azure functions as needed, and when it's not in use, those resources are available to the rest of the web apps. Depending on timing of your workflows and when your functions run versus when your web apps run, this may be a great option. If you have web apps that are active during the day and then you have some utility functions overnight, you could have a good balance between the two. This is also the only option available if you're going to use a custom image to run your function, say a container for example, then you are required to use a dedicated plan. Now that we understand some of the concepts about functions and the plans associated with it, let's jump into the portal and create our first function. You can see here we're back in the Azure portal at our favorite resource group. Our goal today is we're going to set up a Azure function. So let's go ahead and start by typing function up top. And you can see one of our first options here is function app. So we'll go ahead and select that. You can see we don't have anything in place today, so we'll go ahead and select create function. Now this should be a familiar page for us. We're going to go ahead and set the resource group again to Skylines. We'll leave the function app name, let's do Skylines demo FX app, and we're going to go ahead and use code. If we wanted to do a Docker container, we had that option as well. We do need to select the runtime that we're going to use, and in this example we're going to use PowerShell. You can see there are a number of other ones there. Now let's go ahead and select our hosting plan. You can see it does require a storage account for Azure Function to store the various files as part of it. We're going to go ahead and select an existing Skylines demo storage account. Our operating system for the function app is going to be Windows since we're using PowerShell. And now we can go ahead and select the plan type. You can see we've got consumption or serverless, we've got the premium, and there's also the app service plan or dedicated down below. We're going to leave this at the default of serverless or consumption. We have the option now to enable monitoring, so we have some additional logs that are gathered as part of our function apps. We're going to leave that as no for right now, or set that to no. We'll leave the default of no tags, and now we're going to review our settings here quick, and everything looks good, so let's go ahead and hit create, and we'll let this run in the background here, and we'll check back in a second when everything is deployed. Alright, looks like everything's set up, so let's go ahead and go to our function app here. And if we go to the left, you can see under functions that we don't have anything in place there today. So let's go ahead and add one. So we'll click add. You can see here they have a few templates that we can use as a starting point for our function. A lot of them are based off the type of triggers. So if we go through and look, you can see we've got HTTP trigger, Tiber, Azure Queue Storage, Blob, so on and so forth. For this example, we're going to stick with the default of HTTP trigger. And we'll just go ahead and call this sample FX. And now we set the authorization level. And this is basically what credentials are needed to be passed to that function in order for it to be initiated. You can set it at a per function level. You can set it to where it's anonymous so anyone can do it. Or you can do an admin level so pretty much everyone within the app service plan can do that. We're going to go ahead and leave ours at anonymous for the time being. And let's go ahead and create function. So this should happen pretty quickly, and there it is. And Azure is going to automatically open that up for us here. Once we're in here, we're going to go over to code and test on the left. And by default, it's going to open up where we have a basically sample PowerShell file that it's going to call here. So it's pretty straightforward. It's passing in the request parameter as well as some of the metadata in the background. It's going to do some basic checking to see how that request parameter was passed in. It's going to take that information and pass it to the name variable, and then depending if the name variable is populated, we'll determine the body variable or what the body variable is populated with. And finally, you can see the body variable is then included in part of the output binding name response. So we have taken the request parameter, processed it, and then pass it along to the output binding name response. So I've got some sample code that I'd like to use here. So I'm going to go to Visual Studio Code. I'm going to select everything here. Let's go ahead and copy it. I'm going to go back to the code in the function, and I'm going to paste that in here. We're going to go ahead and hit save. And while that's running in the background, let's go take a look at the function.json file. So I'm going to go ahead and close the logs here. We've got two bindings here. We've got an inbound and an outbound. On the inbound side, we've got an HTTP trigger. You can see that the authorization level is set to anonymous. The name of the trigger is request, which if we remember from the PowerShell script, that's the parameter it's passing in. And then it essentially accepts two methods, get method and a post method. If we look at the outbound binding, it's basically a type of HTTP and the name is called response. So let's go back to our run.ps1 file and scroll down again to the bottom. You can see that the name of the output binding here is set to response. So now that we have that, let's go to test run. And you can see here we can pass some query parameters to it, or we can pass them along in the body. If we scroll up here and look at this first part of the code, again, you can see is the name being provided as part of the query or as part of the body. Just to see what happens if there's not a variable or not anything passed along, let's go ahead and remove this. So I'm just going to cut that out of here, and we'll go ahead and hit run. So we can see here that we saw on the left, and if we scroll up just a little bit, you can see we've got an informational event that it's executing the function because it was initiated via an HTTP call, or an HTTP trigger, I should say. And then in a response, you can see that we've got the function completed successfully. There wasn't a name passed in the query string or the request body. Let's go ahead and close out of this since we know our function's working. And let's go to Overview. And then you see we have this option up top to where we can get the function URL. So let's go ahead and copy that. And we'll go up here and we're going to paste it. And then you can see we can go ahead and run this again and we get the same result. It's triggered successfully, but there wasn't a name passed. So let's go ahead and pass in a name. So name equal Joe. And we'll go ahead and run that. You can see now it comes back with a different response. Okay, well, let's go ahead and annoy all the security engineers. Let's copy that and let's paste that into a new window and see what happens. Hey, it's true. Who does have two thumbs and likes Azure? This guy. Now we understand what a function is, we've seen one in Azure, let's talk a little bit about durable functions. So one of the key points with Azure Function is that they run when needed, they process the data, and then are shut down. This is very helpful for simple applications, but it's terrible for maintaining state. One way to get around this is by utilizing durable functions, because they become stateful. How this works is you are essentially stringing multiple functions together to pass information necessary between each one. By leveraging the bindings and triggers, we can pass the necessary information from one function to the next, so they can process the data as defined within the function and then hand it off to the next one. With this in mind, there's a couple different function types that we need to be aware of. Activity functions are essentially the individual functions that process the request. In our previous example or our demonstration, we created what is essentially an activity function. It takes data in, does its process, and outputs that data. Alternatively, there are entity functions, and that read and update the state throughout the process. These are defined by a trigger type of entity function. So now that we understand a little bit about how durable function works, let's look at some of the patterns that are available. There are a number of patterns available depending on how your function needs to run. I wanted to highlight a couple of examples here to help explain the concept. The first one is called chaining, and essentially you have the first function, f1, that runs, which in turn passes data to function 2, function 3, so on and so forth. So it's a very logical and linear approach to it. Another option is the fan in, fan out. So you would have the first function take some data and output it to a queue of some sort. Then the various functions in F2 would sit there and check that queue. Is there new data? Grab it, process it, and output it. It would then go back and check, is there still new data in that queue? If so, grab it, process, and output it. And this would repeat until there is no new data in that queue. And then finally, the F3 function would sit there. It would grab the data that was outputted by the F2, handle it accordingly, and then output or do whatever is needed. Hope this helps explain durable functions and functions in general. Look forward to talking with you shortly as we jump into Cosmos DB. We recently talked about Azure Web Apps and Azure Functions. These are great tools, but typically when working with those, we need to have some sort of resource to store the data associated with the applications. One of the ways that we can do this is by leveraging Azure's Cosmos DB. So let's start by learning about what Cosmos DB is. Cosmos DB is Microsoft's NoSQL non-relational database solution. The topic of relational versus non-relational databases is one that is beyond the scope of this course. But the underlying concept is that with a relational database is that you create structured tables with specific data. With non-relational databases, each record is essentially a document that could contain different points of data. You then present these to the application and let it filter them as needed. You can utilize different APIs or models to connect your application to Cosmos DB, which we'll talk about in just a second. It also provides the ability to scale throughput and storage to meet the needs of your application today and as it grows over time. With Cosmos DB being globally distributed, you can have your data as close to your users as possible, even if they reside in multiple locations. And as you serve your global users, the question always comes into play is how do you make sure your data is in sync? There are 5 different consistency options available so your Cosmos DB can meet your application performance and data consistency requirements. Cosmos DB gives us the ability to connect using a variety of methods. So if your application was designed to work with one of the following APIs, you can utilize Cosmos DB to store the data. This is not a final list, but is what Microsoft currently supports at the time of this recording. Core is the default. It's Microsoft's NoSQL solution, and it leverages the SQL API. It was previously referred to as Document DB. The MongoDB API allows you to leverage Cosmos DB while using your existing MongoDB client drivers and SDKs. Cassandra is used for storing data for Apache Cassandra. The Gremlin API is used for storing graph data. And the Table API allows you to interact with data as if it was in Azure Table Storage. etcd API is useful as a backend store for Kubernetes. However, note it is currently in preview. Let's talk about the structure of Cosmos DB. The database account is the first thing that we create. Some of the important items defined at the account are the consistency level, the global distribution, backup settings, and capacity type. Capacity type determines if you are going to use provision throughput or serverless, essentially reserved capacity or consumption-based. As part of the database account, we then define the API we are using. It defaults to core, but you can choose any of the ones we mentioned previously. We then create our databases, and here's where we define the throughput and request units, or RUs. An RU is defined as the compute needed to perform an operation. Typically it will cost 1 RU to fetch 1 kilobyte of data. To write that same data costs approximately 5 request units, or RUs. You can define a fixed amount of throughput here, or have it set to auto-scale. Within the database, we then define our containers, and this is where we define our partition key. The partition key is what Cosmos DB uses to group our documents together. We can see in the diagram how the account includes the databases and containers, and then you can see if within the database you can hold one or more containers. Within a container, we then create our physical partitions. A physical partition consists of one or more logical partitions, which we'll talk about in a second. An important thing to note with the physical partition is that they have a limit of 10,000 RUs per second. This means if your application is under 10,000 RUs a second, typically you're going to have one physical partition. Once you go above that, then you need to have more than one partition. If you configure your database to autoscale, Microsoft will automatically create the additional partitions for you. If you configure your database throughput to have a set number of request units, Microsoft will automatically provision the number of physical partitions up to that limit, but will not provision past that. If your application needs greater performance, then those requests will start to queue up behind that. All of the actions at the physical partition level are managed by Microsoft. You don't need to do anything in that regard. Logical partitions reside within the physical partitions, and they group documents by the partition key that we defined at the container. Each document that has a unique partition key will have a logical partition in a 1-to-1 ratio. All documents that have the same partition key will be in the same logical partition. Each logical partition has a maximum size of 20 gigabytes. We'll need to keep this in mind when determining our partitioning key. There is not a limit for the number of logical partitions that can be created. If we look in the diagram again, we can see we've got our database and containers from the previous example, but now within that container you can see we have a physical partition with multiple logical partitions within it. If you want to find out more information, we've got a link at the bottom to help explain this in greater detail. Now that we understand how the components of Azure Cosmos DB work together, let's start by looking at a sample document. We have some generic data about a city. This one is specific to Chicago. So for this example, we use city as our partition key. For all documents in the same city, they will be grouped into the same logical partition. That means that for every document that is created that has a unique city defined, we will have a new logical partition. To put this in action, we've got our sample document. And as we add additional sample documents that have the city set to Chicago, you can see they'll group together to form a logical partition. As we add additional documents that include additional cities, we will have a new logical partition for Paris as well as San Francisco, or for every other additional city that we add. Here's another example that takes a look at it from a little bit bigger scale. Here we have two containers. The one on the left is using city as a partition key. The one on the right is using user ID as the partition key. We can also assume, since we've got two physical partitions in each container, that the throughput or RUs needed are between 10 and 20,000 a second. You can see we've got multiple logical partitions, each being associated by the city, since that is our partition key. On the right, you can see we've got different user IDs that are grouped together to form our logical partitions, again, since our partition key is set to user ID. Now that we've learned the basics of CosmoDB, let's jump in the portal and create an example. So here we are back in the Azure portal. We've got our Skylines resource group open up, and we're going to be looking at creating a Cosmos DB. So to start, let's go up to the search bar. Let's type in Cosmos, and you can see here we've got Azure Cosmos DB. So let's go ahead and open that up. You can see we don't have any Cosmos DB defined today. So let's go ahead and click on Add. And now we've got the very familiar screen at this point. Let's go ahead and select our resource group of Skylines. We're going to give it a name, so we'll just call it Sample Cosmos DB. We'll put JF on the end. Perfect. And now we define the API. So here you can see we've got a number of different options available. We're going to leave the default of core. We scroll down and we define our location, as well as our capacity mode, whether we're going with the reserve capacity or if we're doing a consumption based. And then finally we can scroll down to the account type. We've got production, non-production, and you can see if we switch the account type to production, it also configures multi-region rights as well as geo redundancy. So let's go over to networking and we'll take a look here. You can see we can define our connectivity method, whether we're allowing open access, specific networks, or if we're only allowing private endpoint. We're going to go ahead and leave the defaults here, and then we're going to go ahead and select just the Skylines VNet and the default subnet here. You can see here we've got our backup policy. So we're going to back up every 4 hours. I'm going to retain that backup for 8 hours. So let's go ahead and move on to next to encryption, and then here we have the option of basically letting the Cosmos DB account handle the encryption, or we can do a BYOD and specify the key vault that contains the key that we're going to use for encryption. We'll leave the default right now of service managed encryption. We'll go to tags, and then we're going to go to review and create. And you can see we've got validation success here. We're going to do something slightly different this time. Rather than finish creating this in the portal, we're going to go to Cloud Shell and create this using Azure CLI. So to do that, I'm going to go up to the top right here, and we have the option for Cloud Shell right in the portal. So I'm going to go ahead and open this. And this is the first time you ran it, it's going to ask you to basically select a storage account. Since this has been open before, what I'm going to do now is I'm also going to hit this tab to open up a new session. So it's basically going to open this up in a new window for us. Now we've got a little more real estate where we can run our commands. So let's figure out what command we need to run in order to create a Cosmos DB using Azure CLI. So I'm going to open a new tab, and we're going to type Azure CLI Cosmos DB, and if we scroll down to the results here, you can see we've got the AZ Cosmos DB command. So let's go ahead and open that, and now you can see we've got a number of commands that we can run within Cosmos DB or as part of the Cosmos DB command. So we're going to look for create. So let's scroll down through our list. You can see we got a lot of Cassandra options here, collection, and then here we can see create. If we open that up, now you can see the command that we need to run in order to create a Cosmos DB database account, as well as the parameters that go along with it. And if you scroll down, you can see we've got a few basic examples, and it also goes through the required parameters as well as some of the optional parameters. To skip ahead a little bit, I went ahead and created a command that's going to go ahead and deploy our Cosmos DB database account. And you can see here we've got a name of Skylines demo account. we're putting it in the Skylines resource group. And the default consistency level is session, but in this case, we change it to bounded staleness. So with our max interval command, what we're essentially saying is since we're using the bounded staleness, we have a certain window that we can allow Cosmos DB to be out of sync. And with max interval of 300, that means 300 seconds or 5 minutes. So within 5 minutes, any information that's put into Azure Cosmos DB or written to Azure Cosmos DB will be available in all of the instances of that Cosmos DB. With the same concept in mind, we have configured the max staleness prefix parameter to 100,000. This means that we can have up to 100,000 updates to our database before Cosmos DB will force all instances to sync up. Whichever of these two thresholds is reached first between the max interval and max staleness prefix will determine the maximum lag time or lag threshold our Cosmos DB database account will have. And what we're also doing with this is we're deploying this Cosmos DB instance to multiple regions. You can see for the first locations parameter, we're pointing to West US 2, and for the second locations parameter, we're pointing to East US 2. So with that said, let's go ahead and let's copy this command. And now let's go back to the portal. Let's go back to our Cloud Shell instance, and let's right click and paste this, and go ahead and hit enter to let it run. This will probably take 10 to 15 minutes, so we're just going to sit back and let this run. We'll come back in a second to check the status. And here we can see after a little while that the resource did complete successfully. You can see we've got our new Cosmos DB instance. You can see we've got the consistency level set to bounded staleness with our settings. So now let's jump back into the portal. And we're going to go ahead and go home, go back to Azure Cosmos DB. We're going to quit the Cloud Shell. Here you can see our instances online. You can see we're reading out of both the West US 2 and East US 2. And our right region right now is West US 2. Let's go ahead and open up our database account and start creating some databases and containers. You can see now that our database account is open, we've got our read locations as well as write locations defined. And we can scroll down on the left. And now we can go to containers. Let's go ahead and browse. You can see we don't have anything in place there today. We're going to go ahead and add one. And then you can also see now that it is using the SQL API because that is what we defined when we created our database account. So we're going to go ahead and define our database ID now. We're going to use demo DB. And now we can define our throughput. Again, you can define this to autoscale or you can set it to manual. We're going to leave ours with the default of 400 because we don't anticipate really a lot of activity with this database, being it's just a demo. Now we're going to go ahead and define our container. So we'll just call this one demo container. And now we get to the partition key. If we remember back from the PowerPoint, the partition key is how we define how the logical partitions are segmented. And from the examples there, we use city as our partition key, so we're going to go ahead and use that as well this time. So /city. So let's go ahead and we're not going to define anything else here. We're going to hit OK. And then you can see kind of down at the bottom, we're going to go ahead and start creating that new database and also creating that container within it. We'll let this spin for a minute and we'll come back in just a second. All right, now we can see everything's been created. So let's go ahead and we're going to expand demo DB. We're going to expand demo container. And within here, we can see we've got a few items listed as far as store procedures, functions, and triggers. We're not going to look at those quite yet, but we're going to go ahead and look at items. And if we expand this here, you can see right now we don't have any items in play. So now let's go ahead and upload an item. If we go up here to the top right and select upload item, we can go ahead and browse. And then we can see in our examples, we have the city file. So we're going to go ahead and select that. We'll hit open and upload. And while that's uploading, if we go back to Visual Studio Code, you can see here's the example. This is the same sample we had during our slides when we talked about logical partitions and documents within there. So we'll go on ahead and we're going to take this same file and then we're going to update the city to Paris. So let's go ahead and do a file, save as, we'll call this city2. Save it, and now if we go back in here and we're going to go ahead and upload city2, open and hit upload, we can see both files have been uploaded. So let's go ahead and close this. If we do a refresh, you can see now we've got the two files. We've got Chicago as well as Paris listed. We now have our database account created. We've got our database as well as a container created. We've also uploaded a couple documents as well. Now that we understand how data is stored in CosmoDB, we need to talk about how it handles operations at a global scale. As we have one resource that is writing data on one side of the world, how do we manage how that data is presented to users on the other side of the world? You want to have your data closest to the user as possible to provide the best user experience. The closer the data is, the lower the latency to access that data will be. CosmoDB allows this to happen by providing a multi-master experience. This means that by leveraging CosmoDB, your application is going to be able to read and write data using a local CosmoDB instance. In this example, user A will talk to the traffic manager, which will then route traffic to the closest region the application is deployed to. In this example, it would be in the same region, region A. Region A has a web app and a CosmoDB instance. The user will read and write data to that local CosmoDB instance. User B and C will also talk to their appropriate regions when interacting with the application. The consistency level settings within CosmoDB is how we configure how data is written to one instance of CosmoDB and replicated to the other instances. Another advantage of this is that it also greatly increases your availability since you're now running the application in multiple regions. If one region were to go offline, your application will still remain available. So now let's talk a little bit about the consistency levels. Typically, your distributed application will have two consistency levels. Strong, and a strong consistency level, when an operation is completed, it will be available on all nodes right away. Users will never see an uncommitted change or a partial change. They will always be in order. This would be similar to how a traditional database would work. And we can see here in the example, as we write the data ABC, we can read the data ABC essentially in real time. On the opposite end of the spectrum, we have eventual. When a write happens in one instance, it will eventually be in sync with the other instances as capacity becomes available. There's no guarantee the data will be available in the order in which it was written. A good example of this is DNS. When we make a change, we know it will generally be available within a few hours, but have no expectations it will happen right away and be the same for everyone until after a period of time. Another example of this may be for a point-of-sale system. Once a user completes a transaction, typically there won't be any more writes. Your local CosmoDB instance will complete that order and trust that it will eventually update on the other instances. So we can see here in the example, again, we're writing data ABC, but we can see the read, there might be a big delay and the order might come in CBA or some other variety. Somewhat of a middle ground with this is constant prefix. We still have the same issue when we read the data. There's no guarantee as far as the time that it will be available, but it will always be in order. So if you write an ABC, the order which it can be viewed will always be in ABC. CosmoDB also provides two more options here to kind of find a middle ground. The first one is bounded staleness. And this gives us the ability to define a limit for the amount of time that a staleness is allowed. The limit can be the max number of versions that you're behind or a time interval. Reads will always be in the same order that is written. Essentially, if that time limit is reached or the number of versions you are behind has exceeded that threshold, it will temporarily use the strong consistency level to where it will go through and ensure that all of the writes are available on all of the instances. Essentially, you're defining a max acceptable amount of lag when using bounded staleness. Session is another consistency level available, and it is the default within CosmoDB. Essentially, connections using the same session will appear to have a strong consistency level. And by session, we mean that the application will pass a session token as part of its request. Cosmos DB will understand that token and ensure that all requests with that same token will be able to see all transactions in real time, regardless of the region. If the request uses a different token, then Cosmos DB will then default to using constant prefix. To put this in another perspective, let's take a look at a table comparing the options and also bring up how it works depending on the deployment type. And you can see here for the deployment types, we've got same region, single master, same region, multi-master, and then the same to where we've got multiple regions, single master, and multiple regions, multiple master. Strong, again, is going to have every transaction available in real time. Eventual, on the other hand, will eventually sync up, but there's no guarantees on when, or things may be out of order. Bounded staleness, again, within the same region, it has the same consistency level of strong. If we move to multi-region or multi-master, it will behave like consistent prefix within the staleness window. Once we go outside of that staleness window, again, either we've passed a certain time threshold or we are a certain number of versions behind, it will convert to strong essentially and go through and make sure all of those writes are available across the board. For session, on the other hand, again, all sessions that use the same session token will have a strong consistency level. For requests that use a different session token, then we'll have a consistent prefix level. The exception here being if it's multi-region or multi-master where it becomes eventual. And finally, consistent prefix. There's no guarantee on when the data will sync up, but it will sync up in order, and again, the exception here is multi-region, multi-master, where it becomes eventual. When choosing the consistency level, you naturally want to focus on leaning towards strong, but be aware there's a performance impact for this depending on how your application is deployed and used. Be mindful that if it's predominantly reads versus writes, this may not be as much of a concern. However, the higher the ratio of writes to reads, the more important it becomes to review this. Session is the default and ensures that the application writing will see the consistent data for the entire session. This works for many real-world applications. If your application requires strong consistency, regardless of the session, then consider using bounded staleness. This provides a strong consistency level outside of the staleness window, but can give you the performance benefits of consistent prefix within the staleness window. If your application can get by with eventual consistency, it's recommended to use consistent prefix. The main reason is to ensure that the data is available in the same order that it was written. For the highest level of availability and lowest latency, select eventual. There are no real guarantees with this, but it helps ensure the fastest user experience. Again, think of DNS. It's a relatively low write but high read service that will work in this scenario. With all that said, there is a metric called probabilistically bounded staleness. This will help show you the probability that your clients are getting strong and consistent reads. This metric can be used to help ensure you're choosing the appropriate consistency level for your application. Since Cassandra and Mongo use different consistency levels, that each one has their own approach for maintaining consistency levels. Cassandra, the write level consistency is the same as what is configured for your Cosmos DB account. However, the read level is set by the Cassandra client driver. Since MongoDB doesn't offer precisely defined consistency levels, it considers the write replica as the primary and the others as read replicas. With this in mind, when you define which region is your primary region in Azure, this will be considered your write replica. All other instances will be considered read replicas. Azure will map the read consistency level to what is configured dynamically by the MongoDB client for the read request. Let's see how we can configure the consistency level for our Cosmos DB. Here we are back at our database account. If we scroll down on the left, you can see we've got a couple options again that we're looking at. We just got done talking about consistency, so let's go through and take a look at this. If you remember right from when we deployed our database account, we chose bounded staleness. We also set the maximum lag time per 5 minutes, as well as the maximum amount of lag operations to 100,000. If we wanted to go in here and change into that, we could easily do that just by updating the value. We'll change this to 10. Click off, and then we have our option to save up top now. If we go through and look at the other consistency options, we've got eventual, consistent prefix, session, as well as strong. You can see Microsoft has used the music notes in the bottom right to help explain how the consistency level will work. You can see the top line is writes, and the ones below that are reads in various regions. If we look at eventual, you can see we have data coming in. It doesn't look like it's in order, but we are running with the assumption that everything will come in sync eventually. Again, think about DNS when you think of eventual. Let's discard our changes and go take a look at how we can determine where our data is located. So if we go over here to replicate data globally, we can see right now our write region is US2, our read region is East US2. Additionally, if we look on the map, we can see we've got the light blue check mark over on the west coast, and we've got a darker blue check mark on the east coast. If we wanted to add a new region, say for example we wanted to put something in North Europe, we could click that box, and we can see that not only does it also get a dark blue checkbox, but it also shows up under read regions. Same if we wanted to go down to Australia and Southeast, we could set that up as well. One thing that you might notice as well is we only are allowing writing right now to the West US2 region. If we wanted to change that, we could go up here to enable multi-regions writes and select enable, and then you can see that every region still has reads available, but now if we scroll to the right, we can also see that writes are also enabled. Let's go ahead and discard these changes for the moment. Let's go up to failover. If we click on automatic failover, you can see currently it is turned off. If we wanted to enable it, we can hit OK, we hit save, and now it's going to essentially enable automatic failover. Now we can see automatic failover has now been enabled. If we go back up and select it, we can see it's turned on. If we go back, you can see we still have the option for manual failover. We can select the region that we want to become the right region. Obviously we only have one here, but if we added more to it, we could go ahead and select those from the list. So that covers how we can configure our consistency level, as well how we also would enable multi-region write or expand our Cosmos DB to additional regions. Let's go back and take a closer look at some of the other options within Cosmos DB. Let's talk quickly about how scaling works in Cosmos DB, as well as take a quick look at some of the server-side programming. As your application load increases, the number of request units or RUs also increases. As we remember from earlier, there's a 10,000 RU limit per physical partition. Once you hit that limit, Azure will automatically add another physical partition and reallocate the logical partitions. In doing so, you have increased your available RUs to a total of 20,000. As we see in this example, we started with 2 physical partitions today. If we had an increase in our application load and we needed to expand beyond 20,000 RUs, then Azure will automatically add a 3rd partition and reallocate the logical partitions for us. By doing these 2 actions, we have spread the load across 3 physical partitions to increase our total available RUs to 30,000. This again depends on if you have auto-scaling enabled or have allocated enough RUs to allow it to scale out. We briefly touched on this when we created our demo earlier, but I wanted to revisit these items just to quickly give you some more insight. Stored procedures are application logic that runs one or more tasks in a single transaction. The advantage of a single transaction is that it is completed in the same session, so it will ensure it either completes 100% or not at all. Storage procedures are defined specific to a container. A trigger, again, is logic that can be executed before or after a CRUD operation. They do not take parameters, and similar to stored procedures, they are written in JavaScript and specific to a container. And then finally, change feed listens to the container for changes and will output a list of documents that have been modified or created in order. Hopefully this helps explain Cosmos DB and how you can utilize it. In our next section, we're going to talk about another resource we can use to store data. In this section, we're going to take a look at Azure Blob Storage, which provides us with another tool to store data in Azure. Let's start by making ourselves familiar with the basics of Azure Blob. Azure Blob is one of the services that are offered as part of a storage account. There are others such as table, queue, and file shares, but for the moment we're only going to focus on Blob. Azure Blob provides us a way to store unstructured data. This is a similar concept as to how data would be structured on a file share. However, instead of using SMB or CIFS, Blob storage is accessed using HTTP and HTTPS, though it is typically recommended to only allow traffic on HTTPS. It can also be accessed using the REST API, which provides us the ability to work in Azure Blob Storage via PowerShell or Azure CLI. There are a variety of tiers that we can store our data on depending on the frequency in which it's accessed. This gives us the ability to store data that is infrequently accessed at a lower cost tier. Backup data would be a good use case in this example. We also have the ability to have our data stored in more than one region. If one region has a failure, we can still access that data in a second region. This helps provide fault tolerance, however not quite at the scale we saw with Cosmos DB. To get an understanding of how Azure Blob is configured, let's take a look at how we would create our storage blobs. The first thing we need to do is create our storage account. Everything we do from here on will be done within the storage account. Within the storage account, we create containers. The containers can be thought of as folders. Please note, there is no RBAC or any sort of permissions that we can apply to containers. And then finally, within the containers, we can then create the blobs. These are various objects that you are storing. It could be a text file, virtual disk, video or audio files, backup data, images, etc. It is unstructured data, so you can store just about anything you want in a blob. Now let's talk about some of the storage tiers. Storage tiers are available with only the general purpose V2 storage accounts. The first one we're going to talk about is hot, or the hot storage tier. It is optimized for storing data that is accessed frequently, so any data sets that you're working with typically should be in the hot tier. Cool is used for storing data that's accessed less frequently. Typically consider this tier for data that won't be accessed for at least 30 days, maybe short-term backups or older data sets. Finally, archive. Archive is used or optimized for data that's rarely accessed and won't be accessed for at least 180 days. The delay to retrieve data or rehydrate it from the archive tier can take hours to complete. Only the hot and cool tiers can be configured at the storage account level. The archive tier is available at the blob level as well as the hot and cool tiers. So what this means is if you have data that's in a storage account or specifically within a blob storage, you can either configure the storage tier at the account level for hot and cold, or if you want to on the specific blobs or individual blobs, you can configure it there as well. Data in the cool access tier can tolerate slightly lower availability, but still requires high durability, retrieval latency, and throughput characteristics similar to that of the hot data. For cool data, slightly lower SLA, but still has the same durability as the hot data. As you move between tiers, you're charged for the writes as you move to a lower tier. As you move to a warmer tier, you are then charged for the reads. So as data goes from cold to archive, you are charged to write that data to the archive tier. And then as you rehydrate from the archive tier to the cold tier or the hot tier, you charge for the reads as part of that operation. Now we're familiar with Azure Blob Storage, let's go into the portal, let's create a couple storage accounts and create some blobs within. Once again, we're in a favorite resource group, and we can see here we actually do already have a few storage accounts. If we look down below, we can see we've got the Skylines Demo storage account, as well as the Skylines Diag 911 storage account. However, we want to create a new one, so let's go up top and let's search for storage account. And you can see here we've got a few listed already. We're going to go ahead and do add. And again, pretty familiar screen at this point, but let's go ahead and look at the options. We're going to set our resource group to Skylines. We're going to call this Skylines STG ACT for Skylines storage account. We're going to leave our location as Central US. We'll leave the performance as standard. We're going to leave the account type as general purpose v2. And then as far as replication goes, we've got a few different things to look at here. We've got locally redundant, which basically means we've got our storage account is defined within one data center within a given region. It's going to be replicated 3 times within that data center, but it's only going to be within one data center. Zone redundant means that we're going to take that data and we're going to replicate it to multiple data centers within a given region. Geo-redundant, then we're going to take that a step further, and now we're going to replicate that to 2 different regions. With RA-GRS, or read access geo-redundant, we're going to take our data and we're going to have it read available in the secondary region. In the primary region, or the region that we're defining, it's going to be read and write, but it'll be read only in that secondary region. And then the next 2 options for geo-zone redundant means that, similar to the difference between zone and local, when we do geo-zone redundant storage, is we're going to have the data replicated to multiple data centers within a region. So rather than just having it in one data center in a region and then in a separate region having it in another data center, now we're going to again replicate it between data centers in those regions. And then read access geo-zone redundant storage builds upon that same concept. We can have read access in our secondary region, but we're also going to replicate that data to multiple data centers within both of those regions. For this example, we're just going to go ahead and select zone redundant. And we also now notice we have the blob access tier. Since we're using general purpose v2, we have that option. If we were to change this to version 1, you can see it goes away. We'll go ahead and leave ours on v2, and we're going to accept the default of the hot access tier. If we go to networking now, we can look, we've got our same connectivity methods we're pretty familiar with at this point, to where we can determine what networks can access this resource. If we look at data protection, you can see we have the ability to turn on soft delete for the blobs. Additionally, we can also turn on versioning for blobs, as well as a change feed for blobs. A change feed could be useful for something like, I don't know, Azure Functions maybe. If we go to advanced, now you can see we have some of our more in-depth options. So is secure transfer required? If we mouse over this, we can see essentially, is it HTTP or HTTPS or some of the other protocols that are required. Minimum TLS version, large file shares, some of this other stuff, we're not per se worried about that since we're focusing on blob at the moment. We'll go ahead and take a look. We're not going to define any tags. We can review and create. Looks like everything passed. So let's go ahead and create this. So while that's running in the back end, I also wanted to look at another way to deploy our storage account. So if we go minimize this, we've got Visual Studio Code set up here, and we've got a Azure CLI example for creating a storage account. If we walk through this, you can see we're using AZ storage account create. If we did a quick Google search for storage account Azure CLI, we would be able to find the document walking through this. I'll also include a link to it in the example files. But in the meantime, if we take a look here, we've got name. We're doing second storage account. We're putting it in the same resource group. We're setting the location to Central US. We're specifying the kind, storage version 2, which is the general purpose v2. Again, we're using standard ZRS for our SKU. We're requiring that access is done via HTTPS, and we're also setting our access tier to hot. So let's go ahead and copy this command. And let's go back to the Azure portal. And looks like this one's done. But while we're running, let's go ahead and open up Cloud Shell. And let's go ahead and paste this command in and run it. And while that's running, let's scroll up here. We're going to bring this down just a bit. Let's go to resource. And then here we can see we've got our storage account that's up and running. You can see we've got our access tier standard hot. We're using local redundant storage as well as general purpose v2. And if we scroll down on the left, you can see we've got our blob service. And if we open up our containers here, you can see we don't have any in place yet. So let's go ahead and add a container. And we'll just call this container 1. Let's go ahead and create it. And remember, if we thought about containers, essentially this is a folder. But let's go ahead and open that up. You can see sometimes new items might not show up right away. So let's try to refresh the browser. That looks a lot better. You can see we don't have any files in here. So let's go ahead and upload a file. If we go to select file, you can see we've got the city and city2 JSON files from when we looked at Cosmos DB. Let's go ahead and open those files, hit upload, and now you can see we've got a couple files there in our container. If we want, we can click on these and we can change the access tier if we wanted to make it from hot to cold, or we can also right click on here and we can download them or view the file. So here you can see we can view it just as easily. If we wanted to make a change to it, we have that option. Let's go ahead and discard for now. So now we've discarded those changes. Let's go back to home real quick. Let's go see if our other storage account finished running. So let's go back to storage accounts. And here we can see second storage account. If we open that up, again, you can see this one's using ZRS for zone redundant storage. If we scroll down, containers, we don't have any here yet because we just created it using the Azure CLI command. Let's jump back to the PowerPoints and take a close look as far as how we can manage our storage account. Let's talk about one of the ways that we can secure Azure blobs called shared access signatures. Shared access signatures, often referred to as SAS, provide us with a way to secure our storage blobs and provide delegated control to resources. When you create a SAS, you are creating a query string that is included as part of the request. The string includes a token that is used to authenticate as well as details with what type of access is granted. There are a few different types of signatures. One is the account SAS. This type of SAS is associated with one or more storage services. These would be blob, tables, queues, or file shares. This uses a token to provide authentication. You can define a specific service that is used as part of a SAS token, and it would be a service SAS token. When you create a service SAS token, you are specifying one of the services that can be used. For example, blob storage. Like an account SAS, this uses a token to provide authentication. The final type is a user-delegated SAS. The difference between this and the other two we talked about is this is going to leverage Azure AD credentials to provide authentication rather than using a token. Additionally, user-delegated SAS can only be associated with blob storage services, so it cannot be used with table, queues, or file shares. Once you have created a SAS, you'll be given a URL that includes a SAS token used to authenticate. Let's break this down a little bit so we can understand the specific components of the SAS token. This is an example of an account SAS. The first part of the URL is the storage account URL. In this example, we are looking at a blob named images in the storage account named SLS AS demo. The second part of the URL is a SAS token. And we can see there's a lot of information here. So let's dive in to break this down a little further. The first part is the signed version, or SV. This specifies the version of SAS that is used and will dictate what options are available, similar to an API version. However, an API version is not specified within the SAS. The second item is signed services, or SS. This specifies the services that are authorized with this SAS. Since this is an account SAS, we can specify one or more, and in this specific example, we have specified all of them. We have B for blob, F for file share, Q for queue, and T for table. So again, we've specified all services will be available with this account SAS. Next item is signed resource type, or SRT. This is providing the ability to more granularly control the access on top of the signed service. There are 3 resource types that can be specified. The first is S for service. These would be service level access, so you're able to see items at the storage level account and list items within the storage account. The next is C for container. This gives you the next level of access within the storage account. Now we can see items within the container. We could list and view the properties of the objects, but we can't modify them. And in order to modify them, that's where the O comes in. This gives us the ability to modify those objects. So to take a step back, S gives us account level access. C gives us the ability to see all the resources within the storage account, but we can't modify them. That comes with O, which gives us object level access. So in this example, we have SCO, so we essentially have full control of the objects within the storage account. If it was set to SC, we'd be able to view all the objects, but we couldn't modify them. The next is signed permissions, and this takes us one step further. Now we can define the specific permissions that can be performed. The options for signed permissions are R for read, W for write, D for delete, L for list, A for add, which is specific to queues, tables, and blobs, C for create. Similar to add, except for blobs and files, it doesn't allow you to overwrite an existing blob or file. Update allows you to update queues and messages, and P allows you to process queue messages. These work in conjunction with signed resource types, so if there's a mismatch between the signed permissions and the signed resource types, signed permissions becomes invalid. The next item is ST, which stands for signed start and signed expiry. This determines when the SAS is valid and when it becomes invalid. You can see in this example, it became valid on May 18th at 5:21 p.m. and expired on May 24th at 1:21 a.m. SPR, or signed protocol, determines what protocols can be used with the request. The options are HTTP and HTTPS. Unless there's a unique use case, typically HTTPS would be recommended and is required in this example. The final part is the signature, and this is the token that is used to authorize the request. I know that's a lot of information, so let's go into the portal, let's create a few shared access signatures, and let's see how they work in action. So here we are back in our Skyline storage account, and what we're going to do today is we're going to focus on setting up a shared access signature. So to do that, let's scroll down on the left. Let's go to shared access signature under settings, and let's go ahead and review these options. Scroll down a little bit. So if you look, we've got our allowed services. And if we remember right from allowed services, if we're able to select multiple, that's an account shared access signature. If we only had the option to set up one, it would be a service shared access signature. Just so we can have the allowed resource types, permissions, start and stop dates, as well as the allowed protocols. So now let's set one up for our specific use case. Since we're only working with blobs, we're going to go ahead and deselect the other services. From a security mindset, we want to allow the least permissive option. So if somebody else were to inadvertently create a queue or table storage while this shared access signature was valid, we wouldn't want to inadvertently provide access to that. Additionally, if you notice, as I turn off and turn on some of these options, the allowed permissions also change. And what Azure is doing is basically making sure that we're not creating allowed permissions that don't work with our allowed services. This way, the resource type and permissions don't conflict with each other. So we'll leave allowed services to blob. We're going to allow access to everything. We're going to give them full permissions as well so they can do anything they want with those blobs. We'll leave the default start and stop times of today because essentially we want to make sure that the users are able to access just for the day, and then after that it's going to go away. We're going to make sure they're accessing using HTTPS, and then we're going to go ahead and generate our SAS string. So now we've got our SAS token down here. Let's go ahead and we're going to copy this out. And let's open a URL. We'll paste this in. And now we're going to go ahead and type container1 because that's the name of our container. We're going to type city.json and enter, and it's not going to allow us to access that. Essentially, it's saying the resource isn't found. However, we know that's there because we uploaded that file just a little bit ago. Now if we go back and we take that shared access signature and we copy this, and if we notice the SAS token is basically just added on to the end here. So let's go back up here. We're going to paste that on, hit enter, and now we can see that file. If we went up here then and typed, if we go here and type city2, again, now we can see the other files there as well. So that shared access token essentially gave us access to view those blob objects. Hopefully that helped explain how those work, or how to create them and how you can use them. Let's jump back in the PowerPoints and dive a little bit more into how we can work with the blob objects. Let's take a few ways that we can interact with Azure Storage Blobs. So one of the first things we need to understand is how do we move data around in storage blobs? And thankfully Microsoft has given us a few tools to be able to do this. One of the first ones is Storage Explorer. And that's a GUI tool that allows you to browse and download and as well as upload objects to storage accounts. Since we're focusing mostly on blob, that's what we're going to work with. However, Storage Explorer will work with almost all the services within Azure storage accounts. Another tool that we'll take a look at is AZ-copy. And this is a command line tool that lets you download objects from the storage account or upload. So it's basically just a command line version of Storage Explorer. And you can also leverage Azure PowerShell and Azure CLI to interact with blobs in a similar way that you can do with AZ-copy. When a decision has been made to prevent your data from being modified, the idea of worm comes into play, which is write once and read many. There's a few ways that we can configure this. And essentially what we're doing is we're making sure we're defining our storage so that it cannot be modified. There might be a couple reasons for doing this, but there's also a few different ways we can configure this. And one is a time-based retention policy. We can specify a certain interval, and when that policy is set, the blobs can be read and created, but they can't be modified after they've been created or deleted. After that retention period has expired, the blobs can then be deleted, but they cannot be overwritten or modified essentially. Another one is legal hold, and the retention period here is often known because who knows how long a legal case can take. When legal hold is set, blobs can be again created or read, but they can not be modified or deleted. Each legal hold is associated with a user-defined alphanumeric tag, such as case ID, event name, etc., and this is used as an identifying string. With that said, I think we need to talk about metadata. The definition of metadata is a set of data that describes and gives information about other data. When speaking about blobs, there are a number of properties that can be defined. By default, there are system properties. And some examples of this would be content type, created on, last modified, and so on. There are also user-defined metadata, and these are custom key value pairs that you can create and add to the blob. There are a number of ways that we can view and add metadata to the blob. We can do this using .NET, Azure CLI, or within the portal. We've talked about a couple different ways that we can work with a storage blob. Let's go see them in action. So what we're going to do in this demonstration is we're going to look at 3 different ways that we can act with Azure storage accounts. We're going to use the Azure Storage Explorer to upload a file. We're then going to use the AZ-copy tool to download that sample file, and then we're going to use the Azure CLI tool to upload that file to a second storage account. It's worth noting that any of these tasks that we're doing can be completed in any one of these tools. We're just using 3 different tools to give you an example as far as how each one works. We're going to go ahead and open up Azure Storage Explorer, and you can see here we've got ability to interact with storage accounts, Cosmos DB, as well as Data Lake. Today we're just going to focus on storage accounts. So in order to get started, we need to add a storage account. Let's right click on storage accounts and then connect to storage account. We're going to use the storage account name and key to connect, but you can see there's a variety of options. So we'll go ahead and select that and then click on next. It's going to ask us for some basic information. Let's go to the portal and you can see we already have the Skyline storage account opened up. And if we go down to access keys on the left, you can see we've got the information here we need to get connected. So to start, I'm going to go ahead and copy the storage account name. We'll go back to Storage Explorer, and I'm going to paste that in there for the display name as well as the account name. And now it's asking us for the account key. And if we go down here, we can select this and we'll hit copy. And the account key is basically another way to authenticate to the storage account. It's similar in concept to the shared access signature we created earlier or discussed earlier, except this is full access to the storage account. It's not going to give you the ability to granularly control permissions. So with that said, let's go ahead and paste that account key in there. We'll hit next, and then it's going to validate. And you can see here we are connected, and if we go ahead and open up blob storage and then container1, we can see the city.json and city2.json file that we were working with earlier. So our goal this time is we're going to upload a file. So we're going to go ahead and select upload, files, and then we're just going to grab a file from our desktop. So let's go ahead and hit the ellipses, select the sample file, hit open, and upload. And you can see it's starting the transfer of that file up to the storage account, and it's completed. Now we can see that sample file, that text is there. So what we want to do now is we're going to download that file using the AZ copy tool. Let's go back to the portal and click on Storage Explorer. And this is very similar to what we just used with the desktop application. However, it is specific to the storage account. But we're going to go to blob containers, expand container 1, and then we're going to select our sample file.txt. What we're going to do up here is we're going to copy that URL. And now if we go over here and if we tried to open that, it's going to fail because again, we don't have any sort of authentication here or any shared access signature. We'll go ahead and close this though for the time being. We'll go back to Visual Studio Code, and you can see I've got some basic information already populated here. So for the first example, we're using the AZ copy tool. So what I'm going to do is I'm going to paste in the source, which is that file we listed. However, it's worth noting though that this is going to fail because AZ copy doesn't have any authentication information. So to make this work, we also need to go in and create a shared access signature. So let's do that real quick. If we go back to the portal, let's go down to shared access signature. And again, we're only going to be using for blob. We're going to want to give it full permissions here, and we'll leave the default start stop times. We're going to require HTTPS, and let's go ahead and generate a string here. So we're going to go ahead and copy our SAS token. And if we go back to Visual Studio Code, we'll paste that on the end here. We're going to go ahead and copy this to define our variables. And if we go back over to Windows Terminal, let's go ahead and paste these in. So now we've got our variables defined. So now we're going to run the command AZ-copy, which we have downloaded and installed. We're going to do copy source to destination and hit enter. Now it's going to go ahead and run. It's going to see that it is looking for that file, and now it's going to go ahead and download that locally to that destination, which we defined in examples blob storage. So now let's go over to our window here. Let's go open up examples, blob storage, and now we can see that sample file is there. So let's go ahead and take a look at that file. Hi, Bob. My kids are a big fan of Hotel Transylvania 3, so we hear that all the time around our house. Anyhow, so now that we have that file there, what we're going to do is we're going to then now take that file and use AZ-CLI to copy that up to a second storage account. So let's go ahead and minimize this. We're going to close this and minimize this. Let's go take a look at that second storage account. And if you remember right earlier, this is the one that we created using Azure CLI. If we open up this file here, we can go through and go to Storage Explorer, go to our blob accounts. You can see we've got a test blob created, or excuse me, a test containers created, and we can see we don't have any information here. So what we need to do now is we need to get the URL for that container. So if we scroll down here to containers, we can select our test one, and if we click container properties, we can see we've got our URL there. So let's go ahead and copy that. We're going to go back to Visual Studio Code, and now we're going to paste in that destination. So you can see we've got our destination there. We also have the source defined as that sample file in the blob storage folder. And if we look with this one, we can see the parameters are slightly different. We've got AZ storage copy because it is within the Azure CLI underneath the storage properties, and we define our source and destination this way. Additionally, you might notice that there's no shared access signature or any sort of authentication that needs to be provided. And that's because in order to use the AZ storage command, you have to already be logged into Azure CLI. So to do this, I'm going to go down here. We'll do AZ login. It's going to prompt us to sign in. We're going to go ahead and pick the account we want to log into. So we select that. We can see login is successful. And if we minimize this, you can see we are now logged in. So let's go ahead and validate this works. So we're going to go ahead and copy this again. And again, we're defining our source and destination variables. And then we're going to use those in that command, the AZ storage copy command. So let's go down here. We'll right click paste. It's going to give us the warning that we're going to paste lines. That's okay. We'll go ahead and paste anyway. And now let's go ahead and run enter. And it's seeing that it went ahead and copied that file. It's giving us some warning information about RBAC roles. That's fine. Let's validate it worked. Let's go back up to the second storage account. Let's go back to Storage Explorer here. Look at our blob container. And now we can see our test file is there. So, our sample file is there. So everything worked like it should. I do recommend that you play around a little bit with Storage Explorer, with AZ Copy, as well as the Azure CLI tools. I think all three of them would be important to know for using Azure in general, and I wouldn't be surprised if you saw a question or two on the test. In this section, we're going to discuss how identity is managed in Azure with regards to applications. To start off with, we're going to learn about what Azure AD is and how permissions are managed. Azure AD is Microsoft's cloud version of Active Directory. While there is some carryover in the concepts, Microsoft did not just do a lift and shift of Active Directory running on a Windows server. It is very much its own product. It is still an identity provider, which we will dive into shortly. It is the backend for Office 365. So even if you're not using Azure, if you have any part of the Office 365 product suite, Azure AD is the backend for that, keeping track of the users and their roles. So Teams, Exchange Online, SharePoint Online, all of these are using Azure AD. It has the built-in ability to federate with other Azure AD tenants, as well as applications that are outside of the Azure ecosystem. The use case for running ADFS or Active Directory Federation services is much smaller as they continue to expand this offering. There are different licenses available depending on what features are needed. This can include conditional access to require users to be prompted for MFA or multi-factor authentication when they're outside of the corporate office. Also has self-service password resets or helping to discover users with greater access than they should have. We won't be diving into the different licenses, but I wanted to bring them up so you're aware that they existed. Before we get started, let's talk about two things that happen when a user or application attempts to connect to a resource. The first is authentication. This is sometimes referred to as auth-in. The user or application attempting to connect to a resource will first need to validate they are who they say they are. This can be done in several ways, but the most common is a passphrase of some sort. This is where the identity provider comes into play. They either maintain the identity themselves or will federate with another identity provider to authenticate the user or application. A good analogy for this is when you're getting an apartment. They get your information, run a background check to confirm you are who they say they are, among other things, and if everything checks out, they give you a specific key for authentication. Authorization is determining if you can access a specific resource. This is also referred to as Auth-Z. The user or application will present their authorization token to the resource, which will then validate it with the identity provider. Once they determine if it's valid, the resource will then check to see if the user has access. If so, they will let the user application complete the request. Going back to our apartment analogy, once you have been authenticated and given a key, you can now only unlock the door to your apartment with that key. You are not authorized to access any apartment in the complex except for yours. Azure AD is an identity provider solution. This means that Azure AD is able to authenticate a request. As we just learned, this means validating a user or service is who they say they are. Additionally, if a request for a resource is in the same Azure AD tenant, it can also provide authorization for that user to see if they have access to the resources. OAuth 2.0 and OpenID Connect compliant. These are authentication and authorization standards. This gives you the ability to work with a variety of users who may be authenticating with an account provided to them by work or school, as well as with a personal account. It also gives us the ability to leverage Azure B2C, or business to consumer. This allows us to integrate with other providers like Twitter, Facebook, or Google. MSAL, or Microsoft Authentication Library, is a framework that provides token-based authentication for web apps without having to work with OAuth libraries. It can provide tokens for a user or on behalf of an application. Being able to look at more than if the username and password are correct. Azure AD is able to determine if the authentication attempt needs to have additional validation, like multi-factor authentication, or if it just needs to block the request altogether. Rather than having full access or no access, we can granularly control who can access what resources and what specific actions they can do. This is done using role-based access control, or more commonly referred to as RBAC. An advantage of this is that you have a number of authorization options created automatically. If you didn't have this, you would have to create various groups by selecting from thousands of granular permissions, which would be a nightmare at any sort of scale. Once we have created our user or application in the identity provider, such as Azure AD, we can then give them authorization to access certain resources via an RBAC. We can assign permissions to a specific resource, a resource group, a subscription, or a management group. By leveraging role-based access control, we can provide users and applications with the least permissive access to resources. And equally as important is we can do it consistently, since the RBAC roles are built into Azure. For each resource type in Azure, there are typically going to be 3 roles: owner, contributor, and reader. Each role type has multiple permissions associated with it that allows it to perform various actions against that resource type. Some examples of these roles are virtual machine owner, network contributor, or monitoring reader. Each one can quickly give you an idea of what access is provided and to what resource type. Owner contributor permissions typically give you the ability to perform write actions against the resource. The primary differentiator is that the owner gives you the ability to manage permissions on that resource, while contributor cannot. By write, we mean you're able to edit that resource. The reader role allows you to view information or make a GET request. You're not able to make changes to the resource when using the reader assignment. You can use PowerShell to see the latest roles that are available by running the command get AZ role definition. You can also search Microsoft Docs to get the latest role definitions there. Application registrations in concept is an account within Azure AD that you can assign permissions to. They are used to represent an application so it can be accessed by another resource. You may also hear them referred to as app registrations or app reg. For example, if your application needs to be able to get a secret from an Azure Key Vault, you would need to create an app registration for your application and then assign the necessary permissions in the Key Vault to allow it to access that secret. There will be one app registration for every application. If your application is deployed to multiple tenants, there will still only be one app registration. Behind the scenes, for every app registration, there's a service principal. And this is very similar to an application registration, except it is a local representation of that. So for every Azure AD tenant that your application is used in, there will be a local service principal to represent that application registration. This also means that if your app registration is deployed to a single tenant, you have an app registration and a service principal. If your application is deployed to 3 tenants, then you'll have one app registration still, but then you'll have 3 service principals, one in each tenant to represent that application. Let's take a look at the process for creating an application registration. To start with, we're going to have a user who has the necessary permissions to create an app registration. As we learned earlier, this is based on RBAC. So there are a few roles that can be assigned to give us the ability, ranging from global admin to application developer. Assuming the user has the correct permissions assigned, they can log into Azure AD and create the app registration. Once created, they then define a key, or essentially a password, for that app registration. The key also has an expiration date assigned to it so that this doesn't extend indefinitely. We have a way to authenticate, but it's not authorized to do anything yet. So to fix this, we assign an RBAC role to that app registration to perform the necessary tasks. For example, we may give it the VM contributor role. Now if you have an application like Octopus Deploy, we can give it the information about the app registration we just created. This would include the app registration's client ID as well as the key we created in step 2. Now with that information, it can log in as the application registration. And now if we needed to execute a pipeline that deployed a VM, for example, Octopus Deploy would be able to perform the necessary tasks based on the VM contributor role that we granted or assigned in step 3. Now that I understand more about how RBAC works and what a service principal is, let's jump into the portal and see it in action. So here we are in our Azure portal, and what we're going to do is we're going to create our application registration. So to do that, we need to start by going up to Azure Active Directory. So we can see we've got the option here, or if you type up top, Azure Active Directory, you can see we have the option. Once we're in here, we're going to create an application registration. So to do that, we go down to App Registrations, and then let's go ahead and click New. And we'll give this one a name of Sample Apple 1. And then if we look, we've got a couple different account types we can look at. In this example, we're going to basically be using it in this tenant, so we'll select that first one or leave the default of single tenant. If we wanted to work with other organizations, we have the option of doing a multi-tenant or a multi-tenant with a personal account, and that's where that Azure B2C or business to consumer connector comes into play. The other option is we can also work with personal accounts only, so it's only Azure B2C. We're going to leave this at the default. We'll go ahead and click register, and this will create the app registration for us. And if we notice, it gives us a client ID as well as an object ID, just like if we had a user account. With that said, what we're going to need to do now is we need to create a secret or a key for the app registration. So we're going to go over to certificates and secrets on the left. We're going to create a new secret, and then let's go ahead and give it a description of sample secret. And then we're going to set the expiration time or leave the expiration time for a default of 1 year. We'll go ahead and click on add, and now it's going to give us the value for this. So let's go ahead and copy this. I recommend you keep a hold of this in some safe place or some sort of secret management service, because this is a very important bit of information. You're not going to be able to retrieve it after you leave this page. So let's go ahead and paste this somewhere extremely secure, like Notepad. And now we're going to go back to our home screen, and we have created our application registration now. So we've given our application a way to authenticate, but we haven't given it access to anything yet. So to do that, let's go ahead and let's go into subscriptions. Let's go ahead and select the desired subscription. And now we're going to go to access control or IAM. And we're going to click on add role assignment. And let's go ahead and give it the role of virtual machine contributor. And let's go ahead now and select the application. So in this case, we've got our application called Sample Apple 1. We'll select it and we'll hit save. And now we have validated that. We can go through and check now if you'd like, then by typing sample app. And now we can see it has a virtual machine contributor permissions or RBAC roles assigned. So what we've done now is we've created the app registration. We have defined a key for it, and then we've also assigned an RBAC role to that app registration. So now whatever application that we assign this role to, they're going to be able to have VM contributor permissions against this subscription. Going back to our PowerPoints, if we had an Octopus deploy or some other CI/CD pipeline tool, we could leverage that then to deploy virtual machines to our organization. We talked about service principals and app registrations in the last module to see how authentication works for our applications. But now we need to look at how we grant access from one Azure resource to another. You don't want your database to have anonymous access, so you require applications to authenticate to it in order to reach the data. So if your application needed to access that database, you give it the necessary account information to do so. Managed identities provide us with a way to authenticate between resources within our own tenant. We create managed identities on a trusted resource, and then on the trusting resource, we assign the necessary permissions in order to access the information. Going back to our example, the trusted resource would be the application. The trusting resource would be the database, and we make sure that the trusted resource or the application has the right permissions to view the information within that database that they need to. An advantage of using managed identities is that there's no credentials to manage or to worry about. You don't have to worry about passwords expiring and password rotations. Additionally, since there's no passwords to share, the likelihood of that identity becoming compromised is almost non-existent. There are two types of managed identities. The first is system assigned. These are created and assigned directly on the resource. User assigned are created independently of the resource and then assigned to one or more resources. Thinking back to the example we just talked about, managed identities are essentially a special service principal that is used within Azure AD specifically and only for authenticating two or more Azure resources. Authorization is still a separate task from creating the managed identity. You'll still need to go into the trusting resource and define what permissions the trusted resource or managed identity can provide. You can see in this example we have a trusted resource on the left, which is a virtual machine. We have a managed identity in the middle and a key vault that's on the right. We have associated that VM with the managed identity. We have also authorized the managed identity to have certain permissions on the key vault. By completing both of these actions, the virtual machine is now able to talk to the key vault and, depending on how the authorization was configured, can access whatever resources were provided to it. As we mentioned, there are two types of managed identities. We've got system assigned and user assigned. With system assigned identities, it is created on the trusted resource. You don't need to do anything else outside of enabling the managed identity on the trusted resource. You still need to go through and provide authorization, but the authentication or assignment part is handled automatically. With user assigned, it has to be manually created. Once you create that managed identity, then you also need to go through and associate with the resource. So there's two steps with the user assigned versus the one with the system assigned. Once you have a system assigned identity, it will remain in place until that resource is destroyed. So it's very low maintenance. So you don't have to go in and think about it once it's created, because again, it is tied to that one resource. A user assigned identity doesn't have any expiration date or any sort of built-in mechanism to remove it after it's created. It is again user managed, so you need to ensure you keep track of them and remove them after they are no longer needed. A disadvantage to a system assigned identity is that it's a one-to-one mapping between the identity and the resource. You can't create an identity on one VM and then go through and associate that same identity on a separate VM. With user assigned identities though, you can create one identity and associate it with multiple resources, so you can have that one step that's done and then it can be shared with multiple resources. The use case for each of these I think becomes pretty apparent after reviewing the two identity types. System assigned identity is good for a workload that is contained within a single resource, one VM or one web app, for example. User assigned identities excel when there's multiple resources associated with the workload, or if you have a resource that is frequently recycled and redeployed, as this allows you to have that identity in place and configured as that new resource comes online. Now that we understand managed identities and system managed versus user managed, let's go into the portal and see how they work. We've got an app service here and we know our long-term plan is to integrate with a key vault. But before we can do that, we need to have a way that it can authenticate and be authorized to access that key vault. So to do that, we're going to create a managed identity. And if we scroll down on the left under settings, we can find the identity option here. And if we select that, you can see we have two options. We can do a system assigned identity or a user assigned identity. We're going to go ahead and leave this on system assigned. So we'll go ahead and click on and save. You can see that yes, it's going to be enabling a managed identity. So we'll let this go through and create, and it'll take a minute or so. And now you can see we've got that system assigned identity ready to go. So what we're going to do is we're going to copy this, and we're not going to assign it any Azure RBAC roles because we're not going to have it create VMs or do anything like that. However, we are going to need it to authenticate with the key vault. So to do that, let's go ahead and search for key vaults up top. We'll select key vaults and we've got our one key vault listed already. So let's go ahead and select that key vault. And now we're going to go to access policies. And the access policy is essentially how you define what can access this key vault and additionally what permissions are available to that. So let's go ahead and add an access policy. You've got a couple templates that you're going to select from. We want ours to be as restrictive as possible because we don't want that identity accessing something it shouldn't. So I'm not going to select any of the templates. However, I'm going to go into secret permissions and I'm going to select get and list. And this will allow it to view all secrets that are in this key vault. Now that we've selected what permissions are there, we need to go through and select which identity or which user can access this. We're going to go select this, and now I'm going to paste that ID that I copied when I created the managed identity. And we can see it also notes to ing-app01. So let's go ahead and select that and hit select and add. And now if we scroll down under the access policy, we can see that the application, so it does recognize that it is an application and not a specific user, has the secret permissions of get and list. Let's go ahead and save. And that is a process of creating a system managed identity and then assigning permissions to a key vault. If we needed to assign permissions so that it had roles or the ability to make changes within Azure, then we would go and assign a Azure RBAC role to that identity. If we go up top now and search for managed identities, you can see it's not showing any here because this is actually only for user managed identities. So let's go ahead and do add here. It's going to ask us what resource group we want it to be in. We'll put it in our Skylines resource group. We'll leave the default of East US region. And let's go ahead and call it user MI for user managed identity. We'll go ahead and review and create. We'll create it. And now we've created that user managed identity. And if we need to go through then and assign permissions to it, if we go to ing-app01, we'll go back down to identity. And if we go to user managed identity, we can go ahead and select a user MI that we just created and save. And essentially this is the process, so that would be the process for creating a user identity, is that we go through, you create it in advance, then you go assign it to your resource, and then from there you would go back and do the exact same steps from this point forward. Whether you're going to assign it to a key vault, or if you wanted to assign permissions within Azure, then you would assign an RBAC role. The process from this point forward is the same whether you use a user assigned identity or a system assigned identity. In this section, we're going to take a look at Azure Key Vault and how it can be used to help us secure our applications. Azure Key Vault provides a secure way to store our secrets, keys, and certificates within Azure. The data can be accessed with the REST API, so it can be integrated with other services. It can also be integrated with Azure resources, so everything is handled in the backend. You just need to point to the secret and let Azure handle the rest. So it can go in there and extract the key or pull that key information or that secret information so that when it goes to authenticate or connect to resources, it's able to do that. With the premium tier, you can use keys that are secured by HSM or a hardware security module. This is a specifically designed hardware that is used to store data and keep it secure, and also it would alert if any tampering is detected. It also provides built-in versioning, so we can see what a password is today as well as the previous versions of the password in case we need to revert back if something was prematurely changed. Since we have the ability to view and modify secrets within an Azure Key Vault can have a very wide-reaching effect, there are a few different ways that we can help ensure that everything is secure and that we have a minimal amount of access to that Key Vault. The first is using RBAC, and let's start by controlling who can view and edit and alter permissions to the Key Vault. This should be one of the first things we consider with any resource that's created, but it is especially true for Key Vaults. The next is access policies, and we talked a little bit about this in the last module. However, it's similar to RBAC, and it can control how a resource can be accessed. However, this provides a greater level of control. So within the access policy, we can control what secrets they have access to, what keys and certificates, as well as what they can do. Can they only see if the secret is there? Can they actually view the content of the secret? Can they alter it? Can they delete it? So on and so forth. So it gives a lot more granular access to the information within the Key Vault. We also have the ability to control where the Key Vault can be accessed from. This includes filtering to a specific IP range or having it only available from defined VNets. While we can control who has access to what type of secrets, we're not able to control individual access on a per secret or per key or certificate level. So if we have secrets that should be accessed by one group but not by another group, then we need to set up another Key Vault. So this is one of those things to keep in mind as you're deploying and creating Key Vaults, is what groups need to access these Key Vaults so that we can help to make sure that we have segmentation as needed. Let's jump in the portal, let's get a Key Vault set up, and let's look at some of the access policies. So we're back in the Azure portal, and what we're going to do is we're going to set up a Key Vault today. So to start, let's go to Key Vaults. You can see we already have a key vault listed, but we're going to go ahead and add another one. So let's go ahead and select add. We're going to place this one in our Skylines resource group. We're going to give it a name of Skylines KV. We're going to go ahead and put that in the central US region. And if we look at the bottom, we've got a few recovery options. And essentially what these are is if a key or secret is deleted, if it is actually truly deleted, or if it goes to a recycle bin that has a grace period, and that by default is enabled. So if something is inadvertently deleted, we have the ability to recover it. Additionally, if a vault itself is deleted, Microsoft will hang on to it with a default setting here of 90 days. And then we also have purge protection. And what this says is if we actually delete the entire vault, can we go through and then run another command to delete it on the back end? Because when you delete a vault, it essentially kind of goes into a holding period. You can't access it, but you also can't create a vault with that same name. So what you can do here is you can basically have the purge protection enabled, which by default it is disabled. So if it is a production key vault, I do strongly recommend that you enable purge protection. This way, if the vault is inadvertently deleted, whether accidentally or maliciously, it prevents somebody from going through and fully deleting it. You'll have the ability to recover that vault within that 90-day period or whatever you decide to set this to. We're going to leave these with the default settings. We're going to go to the access policy. And if you remember back to the past module, this is very similar to what we set up when we allowed manage identity to access that key vault. We're going to go ahead and leave these with the default for right now. We'll set these up later. If we go to the networking tab, here we can define what resources can talk to that key vault, or what networks can talk to that key vault. You can have it to where it's public. You can have it talk to specific networks, or you can set up to where it's a private endpoint only. We're going to leave this with public and go to next with tags. We're not going to define any in this example. And then if we go to review and create, we can see validations pass. Let's go ahead and create this key vault. Looks like it deployed successfully. Let's go ahead and click go to resource. And now we can see we've got our key vault here. We don't really have any information with it at this point, but let's go back to the PowerPoints and talk a little bit about how we can integrate or leverage this key vault with our other resources. So we talked about Key Vault, we've got one set up, now let's look at ways we can leverage it. So while having your secrets stored in Key Vault is great, it doesn't really do us much good if we're only storing our secrets in there. So if we take a step back, really the whole point of a Key Vault is to remove our secrets from being stored in plain text. This can be something as simple as a connection string in a web app, code within an application or a function, or it can be part of a code such as infrastructure as code for virtual machines, SQL servers, or disk encryption. All these ways that we can interact with Azure, or that resources within Azure can interact with one another, we can leverage Key Vault to help make sure that any sort of authentication that's happening is being handled in a secure manner. So I know that was a really quick slide, but let's go into the portal and let's see how we can leverage Azure Key Vault to set up a connection string between a web application and a SQL database. So here we are, we've got our nJAPA One App Service open, which is basically a web app that's running a simple to-do list. So let's go ahead and take a look at that. So we validated that it works. We can see we've got a few examples here. We have the ability to go in and edit, say we want to call this example 4 now. So we'll go ahead and save, and we can see it's updated here. We have the ability to create new if we wanted to do that. So again, pretty simple to-do list. Now if we take a look at a little bit at the architecture, we've got our web app up front, which we're looking at now, and then we've got a SQL database backend where it's storing our data. So in order for the two to talk, we're using a connection string. To view that connection string, if we go down to settings and then configuration, and then scroll down, we can see we've got our connection string. If we go to the right a little bit, we can edit it, and you can see we've got a pretty long value here. So this is kind of hard to read here, so let's go ahead and copy this. Let's go down to Visual Studio Code, and then let's paste it in here. You can see here we've got our SQL Server defined, as well as the database that we're using. More importantly though, or more concerning I should say, is we've got the user ID and the password defined here as well. So anyone who has access to this web app can go in here and view the credentials to also access SQL. And obviously that's not a good thing. So what we're going to do here is we're going to take this connection string, and then we're going to create a secret in a Key Vault and have that secret be the connection string. Then we're going to reference that secret within the connection string settings of the web app. So what this does is this basically hides the contents of the connection string, and all we can see is the reference. So unless you have access to that key vault, you're not going to be able to see what the connection string is, more importantly, the credentials within that connection string. So to do that, let's go ahead, and we've already got this in our clipboard. Let's go back to Azure. We are going to open the Skylines key vault that we recently created. We're going to go down to secrets, and then we're going to create a secret. And then I'm going to go ahead and paste the value, which is that connection string that we just copied. And then we need to give it a name. So in order to do that, I'm going to select this, I'm going to copy it, and then we're going to go ahead and go down here and paste it. So if we hit create, it's going to create that secret. And if we look here, we've got a version to the secret. So let's go ahead and open that up. And then now we've also got a secret identifier. So let's copy this real quick. Let's go back to Visual Studio Code and let's paste that in here. So if we take a look at this URL, which is essentially what it is, you can see we've got a few different parts to pay attention to. The first part is in front of vault.azure.net, we're defining the key vault name. So in this case, Skylines Key Vault. So that first part defines what key vault we're looking at. Then you can see we're looking at a secret. And then the secret is called NJAP01 connection string. And then finally, we got a bunch of numbers after that. And those numbers are the identifier. So if we go back to Key Vault here, you can see those numbers that we just looked at match a secret version. So if we went in and say, for example, updated the password or updated some part of that secret value or that connection string, we would then get a new secret version. So that secret version would then change that URL or that secret reference. So now that we've got our secret created, we've got the identifier for it, what we're going to do then is we're going to go over to this next tab, and I'm going to paste that into here. So this first part, this at Microsoft.KeyVault, what that essentially is doing is that is telling whenever Azure sees that, it knows, okay, I'm going to be referencing a key vault. And then from there, we give it a secret URI. So we're basically defining what specific secret am I going to be looking at. So if we take this whole string here and paste it into the connection string within the web app, Azure is going to see that and recognize because of the at Microsoft.KeyVault saying, hey, I know this isn't a literal value. I need to be referencing a key vault. And then from there, with the secret URI, we are specifying what individual secret or what specific secret and version we're going to be referencing. So let's go ahead and take this. We're going to copy it. And if we go back to Azure now, when we go back to NJAP01, we're going to go ahead and clear this out. And then we're going to paste in that value. So again, it starts with at Microsoft.KeyVault so that Microsoft knows we're referencing something and don't take this as a literal value. We'll go ahead and hit OK here, and then we're going to save it, and just telling basically when we save it, we're going to be restarting our application. So we'll let this run for a second here. Looks like it's updated, so I'm going to close this out. We'll go back to Overview. And let's go ahead and open up our website. And if we look here, it's basically saying, hey, this isn't supported. Something's not working right. All right, well, let's take a step back. What have we learned using managed identities last time? We set up a managed identity on NJAP01 previously, so let's go take a look at that. Yep, this confirms we've got our system identity. So we've basically created our identity here. But did we set that up when we created our new key vault? Let's take a look. So we're going to go back to our key vault. We're going to go look at our access policies. And if we look here, we don't have it defined. We set that up with another key vault, but we didn't do it after we created a new Skylines key vault. So let's go ahead and access policy. We're working with secrets, so we're going to give it the get and list permission. And then for service principal, we're going to go ahead and select the NJAP. We'll select that. We'll go ahead and add it. Save. And then now we can see again that the NJAP01 showed up as an application and not a user, which makes sense considering it is a service principal essentially in the back end. Let's go back to our app service here. We're going to go ahead and restart it just to make sure it gets those refresh settings. And now it's restarted. Let's go ahead and now it's working. In summary, we took the connection string which had credentials in it to the database. We created a secret from that connection string. We then went to the connection string settings of the web app, and then we updated it so that it's basically using a key vault reference now. And once we completed that, we had some issues because it still wasn't able to basically view that secret because the web app didn't have permissions. So then we went back to the key vault. We updated the access policies so that the system identity of the web app did have access to view the secrets. Once we did that, we went back over to the web app. We restarted it to get the updated settings, and then from there we were able to view everything, or there we were able to access the web application. In this section, we're going to talk about a few of the different ways that we can deliver our applications to our users. When we are serving content from our applications, there are a number of tools that Azure provides to help us ensure we are securely and efficiently delivering that content. We're going to discuss Content Delivery Networks, or CDNs, Azure Front Door, as well as Azure Cache for Redis. So let's start with a traditional delivery. With the simplest deployment, you have a user, who we're going to call Theodore. He's trying to access the content that you're storing. This could be web content or some sort of multimedia file. Either way, each time Theodore makes a request of the content, the source or origin needs to process and then provide that content back to him. The only caching that occurs in this scenario would be on the user's workstation. And since that workstation is most likely only used by Theodore, each time a new user makes a request, the origin needs to process and return everything again. A CDN, or Content Delivery Network, sits between the origin and the users. It can be referred to as an edge server or point of presence. It essentially acts like a man in the middle that gets a request from the users, passes it along to the origin then processes and serves the request, and then sends it back to the CDN, which then sends it back to the user. So going back to our previous example, Theodore again is going to request the content. It's going to reach the CDN, which will then pass it along to the source. The source will then respond to the CDN with the content. The CDN in turn then sends that content back to Theodore. This may just seem like an extra step at this point, but when Theodore tells his friends about how awesome your application is, they will attempt to access that same content. This time though, the request will hit the CDN, and since it already has that content cached from when Theodore accessed it, it will then pass the response back to them. This removes a lot of the processing from the source or origin so that it can be free for other requests. Another advantage to CDNs is the ability to more effectively serve our global audience. Since we may have users close to our regional data center or on the other side of the world, we need to keep that content as close as possible. Much like when we talked about with Cosmos DB, the closer the user is to the data, the more likely the application performance will improve, which will also increase the user satisfaction. As you can see here, we're leveraging the CDNs from various regions around the world. This allows users to get content from a local CDN rather than having to transverse intercontinental connections to talk to the region where the web application is deployed. When we deploy a CDN, we don't specify a specific data center. It's considered a global service, so as your content is accessed around the world, it will be cached at one of the many CDNs automatically. There are a number of CDN SKUs available. One from Microsoft will work for a lot of your basic needs, as well as another from Akamai and two from Verizon. Each has their own advantages. For the AZ-204, you shouldn't need to worry too much about the specifics of each, but I wanted to make sure you're aware that there are multiple offerings. I've also included a link at the bottom that provides a comparison between each if you'd like to investigate further. Since we're talking about caching, we also need to discuss caching rules. Since we don't want our content to live in cache forever, there may be some items that we don't want cached at all, and we can use caching rules to help manage the cache of both of the items that we want to be cached as well as the ones we don't want to be cached. There are two general types of rules. The first is global, and this is defined at each endpoint and affects all requests on that endpoint. The other is a custom caching rule. This would match specific paths or file extensions. They are processed in order, and the custom rules override the global rules. Typically on your content, you set the cache control header to determine how the content should be cached. We have custom rules to override that cache control header on the CDN, and there are three main settings. The first is bypass. What bypass does is it prevents content from being cached altogether. So if you have something that you absolutely do not want to be cached on the CDN, you can use the bypass caching behavior. The next is override. Override deals with cache duration. This will override the cache duration setting defined on the content. Please note that if the content is set to no cache, the override will obey that and not cache the content. It is only for items that typically would be cached. And the final rule is set if missing. This will honor any existing cache settings defined. However, if there are settings that are not defined, then we'll populate those settings with what you have defined within the rule. Examples of this could be max age or minimum freshness. Let's go set up a CDN and take a look at some of the caching rules within. Our goal here is to create a CDN, and let's take a look at some of the rules that we can define within it. So to start, let's go to CDN profiles. And you can see here we don't have anything today, so let's go ahead and create a CDN. We're going to call this Skylines CDN. We're going to put it in the Skylines resource group, and then we're going to select a pricing tier. We're going to go ahead and select the standard tier for this one. Now if we do notice, there is a resource group location that's being defined, but we're not actually defining a location for the CDN itself. And that's because it is a global service. The only reason that the resource group location is mentioned here is because there is some metadata that is associated with the CDN profile, and it needs a place to store that. So in this case, it's going to be East US for the CDN metadata, but the actual CDNs themselves are going to be a global service. So let's go ahead and hit create for now. And while this goes through and runs, this is going to take a little bit of time. So let's check back here in just a second. Alright, looks like it was successfully created. So let's go ahead and do a refresh. You can see it didn't show up. Sometimes you got to refresh the page. And now we can see our CDN is there. So let's go ahead and select that. And I'm going to kick this off to the left. You can see we've got a pretty straightforward setting here. There's not a lot of properties we define. However, we do need to create an endpoint. And an endpoint is essentially how users are going to access the CDN, and then more importantly, what's the origin for that endpoint, or what's information is being served via that CDN. So let's go ahead and up to endpoint, and then you can see if we look at origin type, we've got a few here. So if we've got storage, so maybe we're hosting a multimedia file, or if we've got a static website hosted in storage, or some other cloud service or whatever. So there's a few different options here. We're going to go ahead and select web app, and then we're going to use the eng-app01 that we've been using and recently used as part of the key vault. And we also need to give it a name. So let's call this Skylines CDN endpoint. And we're going to go ahead and add, and that's going to take a few minutes for that to go through and get created. Alright, you can see that it's created, but it also popped up so there might be a few minutes before it's actually accessible. So if we open up that endpoint, you can see now we do have a endpoint URL. And if we go to select that, it's going to come back and say page not found. And that's expected right now because it's going through and creating that on all the various CDN endpoints throughout the world. So we're going to go ahead and close this for right now. And while that's populating, let's go through and take a look at some of the rules that we had talked about. So if we go to the rules engine, you can see we don't have any defined right now, and we're working with a global rule. So let's go ahead and add a rule. We'll just call this demo rule 01, and then we need to add a condition. So let's go ahead and add a condition, and we'll just do device type, and basically saying if the device type equals a mobile device. So now we're going through and filtering, say we're only going to look, or this is only going to apply when the device is a mobile device. So now we're going to add an action. And let's go ahead and take a look at the cache expiration. And then if we look at the cache expiration, you can see we've got a few different options, and we talked about these in the PowerPoints. But we're going to go ahead and we're basically going to say set if missing. So if there is no cache setting defined within the content, we're going to go ahead and apply that. So we're basically going to say the cache expires after 1 day, 1 hour, 1 minute, and 1 second. So basically we've created a rule to where if the device type is a mobile and there's no cache settings defined, we're going to basically say the cache is valid for 1 day, 1 hour, 1 minute, and 1 second. So let's go ahead and hit save. Alright, you can see that saved. So now let's go back up to overview here, and let's see if our endpoint is now working. And you can see now we've got our to-do list. So now you can see here we've got a CDN pointed up. We know we're leveraging the CDN because of the URL we're accessing. And we also know that we now have a rule defined so that if it's a mobile device and there isn't any cache settings defined, we're automatically going to cache that content for a given time frame. Azure Front Door is another way that we can help present our applications to our users. Azure Front Door is another tool that we can use to help deliver our application. It offers a variety of features to help give you the ability to host your web-based application, ensure it is secure, has fault tolerance, and be local to your users. It It provides a layer 7 firewall so that you can help protect against SQL injections, scanners, or other attacks that would come across port 80 or 443. We can provide path-based routing, so if you have a subset of servers that handles your search and another set that handles request forms, you can route traffic accordingly between the two. In addition to that, we also load balancing, so if you've got multiple sets of servers, you can load balance between them. Additionally, it offers caching in there to help offload some of the processing of your servers. Along the same line, it does also allow you to offload SSL processing. This is another way where you can take some of the processing off of your web apps or server. If you prefer, you can still have traffic between Azure Front Door and your servers protected by using end-to-end encryption. It is also a global tool, so it is not deployed to one single data center, much in the same way as a CDN. In many ways, Azure Front Door is very similar to Azure Application Gateway if you're familiar with those. The main difference is that Azure Front Door is a global service, whereas application gateways are a regional service. Let's talk specifically about some of the other caching features within Azure Front Door. The first is object chunking. Since it's acting like a man in the middle between your users and your web app or server, if we are sending large files, this can cause a delay as the file is sent from the origin to Front Door and then to your user. To get around this, we use object chunking. Essentially, it will break the file into 8 megabit sections. As Front Door receives the first chunk, it will ask the source for the second chunk. While that is happening, it is sending the first chunk to the user, and this will repeat over and over and over until the entire file is sent. By doing this, the user is getting the file much quicker since the Azure Front Door can send and receive chunks at the same time. It also supports file compression. Obviously, as we compress a file, we typically send it faster since there's less data to transmit across the wire. There is a static list of files that are not allowed to be decompressed, and this is managed by Microsoft. This will improve application performance as long as your application isn't using that list of files that aren't supported. We can also look at how files are cached based upon the query string. We can have it to where it ignores the query string and will cache the content regardless of it, or we can have it to where it treats every query string as unique. So if a query string gets changed from one request to the next, it will get its own cache. Whatever option you choose is really up to you based upon how your application works and is structured. And the final thing worth noting is that the request headers, content length, and transfer encoding will not be forwarded to backend service when caching is enabled. As with all good things, they must come to an end. Cache must be purged in order to keep space for newer content. By default, cache has a TTL, or time to live, where once it's reached that, it will be purged from cache. The next time the content is requested, it will be pulled from the origin or the source, and then repopulated in the cache with the new TTL. With that in mind, it is recommended to version your content so there aren't duplicates. So as new content is added, we make sure we put a version number on it, so this way we don't have any overlap with the items that are already in cache. We can also manually purge cache if we need to. Say we pushed out a major change, or we found an issue and we want to clear it up as soon as possible. The first option to purge cache is single path. And this would be for a single item. We are specifying the full path to that item, say if it's an image file that was updated. This way we can remove that from cache if we found that was an issue. The next is a wildcard purge. And this is for a directory or folder, maybe a pictures folder or forms folder. This will include any subfolder that lives within that directory as well. And the final option is root domain, and this will wipe out the entire cache for a site. We can also specify a cache duration, which is the minimum TTL that Azure Front Door will cache an item. However, it is worth noting that if the origin's cache control header max age is a value that's less than the minimum TTL on the front door, the value in the cache control header will take precedence. Azure Cache for Redis helps us ensure that our applications are performing consistently as we manage our web servers. Redis Cache is an open source in-memory caching engine. It provides us with the ability to offer a distributed cache to support your applications. And since it runs in memory, it provides very fast retrieval of your content, which helps improve the performance and scalability of your applications. Azure Cache for Redis is Microsoft's managed service version of Redis Cache. They have dedicated servers that provide full compatibility with the Redis API. It is also worth noting that it can be utilized for resources within Azure or in another location. Let's take a look at how Redis Cache works. We have a pretty simple example here where we've got a user on the left who is making a request to the web app. Behind that web app, we have Redis Cache set up as well as a SQL database. So the user is going to make the request to the web app. The web app will then check the Redis Cache to see if the data for the request is present. If it is, it will provide it to the web app and complete the user's request. We're going to say for this example though that the data is not in the cache. So now the web app will need to talk to the SQL database to retrieve the data. This increases the total time for the request because it has to process with the SQL database, and that's going to take longer than retrieving the data from the Redis cache. Once the SQL database provides the data back to the web app, it will then complete the user's request and also add that data to the Redis cache, so it will be available for the next request. In this example, you might be asking yourself, why don't we just increase the memory size of the web app so we don't need to utilize the Redis cache? If you remember, we said it was a distributed cache engine. So as we add multiple web apps, they can all utilize the same Redis cache, so we can have consistent performance regardless of which web app the user reaches. There are 3 different SKUs of Redis cache. All tiers offer encryption and transport, as well as firewall rules, so you can configure and control access to your cache. However, each tier has various performance and features. The first tier is going to be the basic SKU, and this offers a single Redis cache node. It allows you to use from 250 megabytes of cache all the way up to 53 gigabytes. Since it is a single node, Microsoft does not offer an SLA. This would be recommended for a dev test or a non-critical workload. The standard is very familiar to the basic SKU with the exception of that you now have a 2-node cluster. There's a primary replica configuration, which is managed by Azure. Since we have 2 nodes, Microsoft does offer an SLA with the standard SKU. They also offer a premium tier, which allows you to store up to 1.2 terabytes of data. At this tier, you can get a number of unique features such as georeplication, data persistence, and the availability to import and export data to your cache. This is very useful to ensure your application performs well even after a reboot or maintenance. There are a few different patterns in which we can use to help make the best use of Redis cache. The first is a data cache. With this deployment, we are loading data that is accessed by the application to Redis cache. This most closely resembles the example we showed earlier, where we are caching a subset of data from a database to improve application performance. Content cache is also very similar to our first example, except rather than user data, we're going to be using with more general content. Headers, footers, banners, for example. This content does not frequently change. If we think about the Azure portal, for example, a lot of the screens look very similar, so this would be a great use case for content cache. Session state is commonly used for e-commerce instances. If a user is browsing your website and is adding products to their cart, you may not want that to be permanent, or you may, depending on how much data you're gathering. By keeping that information in cache for their session, you will still have the products in their cart available. So if they come back, they'll be more likely to complete the sale if they don't have to go through and add everything back to their cart again. And then finally, job and message queue. Basically gives you a place to hold data while it's waiting to be processed. If you have a number of tasks that run or a few that take a while, you can write data to the cache and then it will be processed as capacity becomes available. In this section, we're going to be looking at a monitoring tool called Application Insights. Before we dive into Application Insights, let's take a step back and look at Azure Monitor as a whole. It is a central location to monitor all resources within Azure. This includes the monitoring of activity within Azure itself. This is nice because if you're already in Azure looking at your resources, you can now see the various metrics about the resource in the same location. At the same time, you also need to be able to identify issues as they arise. There are a few different ways that Azure helps simplify this, and we'll look specifically at how Application Insights helps with this in just a bit. And finally, monitoring information is extremely helpful, but being able to sound the alarm when an event happens is more important in my opinion. Within Azure, you can create an alert to send notifications, or you can have it start a predefined task to auto-remediate issues as well. I love this image because it really helps paint the picture for Azure Monitor. We can see on the left we have a variety of resources and resource types that can send information to Azure. This includes your various resources in Azure, your IaaS VMs, your applications, Azure subscriptions and tenants, and also application VM that live outside of Azure. It is then broken down into metrics and logs. Metrics are point-in-time information, say CPU percentage, or HTTP response time. Logs, on the other hand, are essentially messages that can contain a variety of information, maybe an event log entry from a Windows VM or an access log from Azure Front Door. And then on the right, we have all the ways that we can process this information. We can use Power BI to visualize the data. We can create alerts to send notifications or to start auto-remediation tasks. And then we can also leverage Application Insights to help understand what's happening with that data. Application Insights is a feature that gives us the ability to see how traffic is moving within our applications. By using this data, it helps paint a picture of how the application is performing and make it easier to understand any bottlenecks or problem areas. Some examples of this information could be the request rates and the response times, and it also looks at the dependency request rates and response time to see how long the backend might be taking to respond. Application Insights leverages an SDK to gather the information. This can be installed on most resources within Azure by simply selecting Enable Application Insights. This is also known as a codeless deployment, since we don't need to do anything with the application code to have it report the data to Application Insights. They also have a code-based deployment that does require some changes to the code, as the name would imply. By using this, it means we can enable Application Insights for non-Azure resources, so you can utilize it for all of your workloads. All the data in Application Insights is stored in Log Analytics. Not only does this provide a robust backend, but it also gives us the ability to review the data if we need to find some specific information that might not be available within Application Insights. And then we can also create a custom report based upon that if needed. One of my favorite features within Application Insights is the application map. The application map gives us details about each of the components of an application. This becomes incredibly useful as we leverage distributed applications where we have process occurring on multiple resources. By providing details not only about the components, but specific requests, you can see that your application worked fine for most of the requests, but there are a handful that are having consistently higher response times. This can help you understand if there's something that isn't optimized or is perhaps undersized, and you need to investigate that further. As we can see in this example of an application map, we have a web app and a SQL database backend. This is the NJAP01 web app instance that we've used for the past few demonstrations. We can see on the right we have the slowest requests by name, and we can see we've got the two GET requests that are pretty consistent, but then we have a POST request, which is about double the response time. If we think about it, that makes sense because GET doesn't have any writes, whereas a POST does. So as we look at this, it can help understand where any potential issues lie. If we had problems with our SQL database backend, we could see that the response time there is typically going to be much higher, or is going to be a larger portion of the overall time. So maybe we need to look at investigating how our performance is on our SQL database versus on the web app. As you're monitoring traffic on your website, it can be really helpful to see how your users are interacting with it. Here are a few of the ways that Application Insights can help you understand your user's experience. The funnel helps you determine if your users are completing the entire process, whether they're completing a sale or filling out an application. If they're exiting before it's completed, it can be helpful to know that and also where that is happening. User flows is much in the same breath. You want to see how your users are interacting with your site and how they're browsing it. Using this information can help understand and adjust how your site is laid out to improve navigation. Impact is measuring to see how load times are affecting if a user will continue using your application or not. If you have a high load times, your users may be less likely to continue using that application. Conversely, fast load times would typically keep your users more engaged. Retention is measuring how many times the user is coming back. If you have a lot of one-hit wonders, that may make the case that your site needs to be restructured. But if you have a high retention, this supports the argument that any changes need to be more carefully reviewed. Cohorts then helps paint the picture for what users have in common. Maybe you have a group of users that visit a page with a high frequency. These users may also be interested in another feature that is similar. It may make sense to have that second feature more visible from the first page to help drive up its usage. One thing worth noting is that if you want to enable these features, you need to ensure that your web app has always on enabled. This is to help prevent that web app from being unloaded due to inactivity. Now that we've talked about Application Insights, let's talk about how it's deployed. As we mentioned earlier, there are two ways to deploy Application Insights. The first and probably easiest way is what Microsoft calls the codeless deployment. This is available to only certain resources within Azure, and it's simply enabled by selecting the option to enable Application Insights. It's essentially a push button deployment. The next option that we have is a more universal approach, and that's called a code-based deployment. With a code-based deployment, you need to have an existing Application Insights instance already set up. Within Application Insights, there's a unique field called Instrumentation Key. We use the Instrumentation Key to uniquely identify each Application Insights instance. So when we configure a code-based deployment, we use that Instrumentation Key so that the application knows what's Application Insights instance to write back to. Once we have the Instrumentation Key, we also need to install the appropriate Application Insights package. There are packages for ASP.NET, .NET Core, Java, Node, Python, as well as non-HTTP based applications. With the package installed, we define the instrumentation key and then specify the logging level, as we can see in this example for ASP.NET. We've got the Application Insights instrumentation key, and then we also have the logging level. One thing worth noting if we learn from key vaults is we probably shouldn't put the instrumentation key right there within the code itself. We should probably create a reference to it, shouldn't we? Now that we've talked about Application Insights, let's see how we can leverage it for an existing web app and then what kind of data that can provide. So here we are back in the Azure portal, and what we're going to do is we're going to take a look at Application Insights. We can see it here under our recently accessed, or if it's not listed there, we can always go up top and search for application, and then we can see it showing up here in one of the first few items. So let's go ahead and select that. And you can see we do have an existing Application Insights instance there today, but let's go through the process of adding a new one. So if we go up here and click Add, and then we're going to go through the familiar screen again to where we select the resource group of Skylines. We're going to give it a name of Skylines App Insights. We're going to go ahead and select the East US region, and we are going to use a resource mode of workspace based. And what this is going to do is it's basically going to save all the information in Log Analytics. So to do that, let's go ahead and select an existing Log Analytics instance. And we'll go click on Next to review the tags, which we're not going to define for this example. Review and create. Everything looks good, so now we're going to go ahead and select Create. So while that's creating in the background, let's go back and take a look at that existing Application Insights instance. And once we're here, one of the first things we notice is the instrumentation key. And the instrumentation key, again, is that unique identifier for this Application Insights instance. So as we're using a code-based deployment, we're going to use that instrumentation key to tell that application which specific instance of Application Insights we're going to be sending that to. With that said, let's go ahead and take a look at some of the features within Application Insights. If we scroll off to the left, under Investigate, we see Application Map. And again, this looks very similar to that example that we saw in the PowerPoints. We do have our web app, Eng-App01, which we've been working with, which is talking to the Eng-SQL01 database engine. And if we go through and take a look, if we select this, you can see what some of the calls are that we've been experiencing as well as the response times. Or if we go through and take a look here, you can also see the typical response time for the SQL backend. So this is really good information, but let's go ahead and take a look at one with a little more history. So let's go ahead and look at the last 30 days. And here you can see, we have a number of calls, but we also have some failures here. So let's go ahead and take a look at those failures and select that. And again, we'll select the response codes here, and we'll select the first suggested. And if we go through here and click this one and scroll down, you can see we've got an error where the login failed. And if we click Show More, we're going to get the full stack here. But you can see the second line down where we've got login failed for user Joe admin. This is an example of an error we would get if we had some sort of issue talking to the backend. So if the part of that connection screen, if there was a bad password listed, this might help explain it, or this would help give you some insight as far as what happened, and then how do I dive into that to find out more information. So if we close out of this and then go back to the Application Insights, again, this is a really good tool because not only does it help you see how things are working, but if there's errors, it also helps you to dive in to see where those errors are occurring and also provide some logs so you can dive into that error a little further. So let's also take a look now at one of the other options, which is live metrics. So if we select this, this is going to take a few seconds to spin up. But what this is doing is this is basically a live stream of information that's happening on your application. So this is looking, you can see right now we don't have any data going on here. But if we go back to that web app, let's go ahead and edit the details here. And we'll call this request 8, save. And then if we go back, now we can see those requests happening. So you can see we had the initial request and then we saved it. You can see any failure rates that were happening, dependency calls, which again, as we're writing to that SQL database backend, memory utilization, CPU utilization. So this again gives you helpful insight to where you can, if you're having an issue at real time, you can use this to help see if maybe it is a CPU constraint or a memory constraint or response times to various parts throughout the process. Just one more tool that you can have to help you troubleshoot as issues come up. Additionally, if we scroll down here, you can see we've got a number of the usage options. So these would be the funnels and user flows and so on and so forth that we talked about in the PowerPoints. And then finally, one last thing I wanted to point out, if we go to properties here, again, we've got our instrumentation key as well as a connection string that we might need to use depending on the resource or how that information needs to be provided. And then one last thing, if we look at the logs, we are using a log analytics workspace on the back end. So hopefully this helps explain Application Insights and some of the ways that you can utilize it to help troubleshoot and monitor your resources within Azure. Let's discuss how Logic App handles templates. With anything we do, we want to be sure we're at least asking ourselves if this can be completed by using some sort of infrastructure as code, or IAC. With Logic Apps, this is no different. We have the ability to create a Logic App and then export it to a custom template. It will include not only the steps to create the Logic App, but also any parameters that we define. This is essentially the same way that Microsoft provides all the built-in templates we saw when we created our Logic App. When we first create a custom template, we are essentially creating an ARM template. I know this may not be surprising, but in case it hasn't clicked yet, the more you work with Azure, it becomes immensely helpful to understand ARM. Logic Apps, again, is no exception. We can create these templates using Visual Studio or PowerShell. Unfortunately, Visual Studio Code doesn't work for this. You will need to use the Community Edition or higher of Visual Studio. Here's an example of taking our Skylines Logic App and creating a template from it and then outputting it to our current directory. We're defining a parameters hash table where it's looking at the Logic App called Skylines Logic App and the resource group Skylines, and then it's taking that and passing it to the get Logic App template commandlet, and then taking the output of that and then saving it to the Skylines Logic App.json in the current directory. So again, it's basically taking the information about our Logic App, creating a template from it, and then outputting it to a file. Once we have our custom template created, we can deploy it using any tool that supports ARM templates. This can include Azure PowerShell or CLI, Azure DevOps, using Visual Studio, or directly within the portal. Here's an example of how we would do it using Azure CLI. You can see here we're taking the command AZ group deployment create to create a new ARM deployment. We are then deploying it to the Skylines resource group and using the template file that we just exported from the previous slide. This covers how we would create and then deploy custom Logic App templates within Azure. One of the features within Azure that we can use to help automate our tasks is Logic Apps. Logic Apps provide us with a way to orchestrate tasks in a way that makes it easy to get started, but also offers us the flexibility to really customize it in a way that make it work for our business. These workflows can include everything from simple automation tasks to complex business processes. There are a number of connectors out there to help integrate with your applications, whether it's a Microsoft application or one of the many third parties out there. Additionally, you can create custom connectors if needed. With this in mind, it can be extremely useful to help your existing applications work with new ones by handling how data is processed between them. So as you migrate your applications away from legacy technologies, this can make sure you can still expose the data to the newer technologies that may not have the ability to talk natively with one another. There are many similarities between Logic Apps and Azure Functions. They both use a trigger to initiate their process, and they're both serverless. Again, I say serverless with air quotes because essentially we are leveraging Azure to maintain the server instead of having to worry about it ourselves. The biggest difference is that with Logic Apps gives you the ability to create logic without writing any code. Additionally, there are several connectors available so you can easily integrate with other applications such as Salesforce, SAP, GitHub, as well as many others. Since we're familiar with the general concepts of how a Logic App works, since in many ways it's similar to Azure Functions, let's take a look at how we would set up our first one. The first thing we define is a trigger. Similar to a trigger in Azure Functions, this is what initiates the Logic App. These can be run on a timer or initiated by a connection. There are two main types. A polling trigger will use a recurring schedule to check another resource for activity. If there is a certain type of activity, it will then initiate the Logic App. A push trigger, on the other hand, is always listening, and as soon as the defined event happens, it will initiate the Logic App. The main difference is that a polling trigger runs according to a defined schedule, where a push trigger is always listening. So whenever a qualified or defined event happens, it will run right away on the push trigger, and then it will run during the next polling cycle on the polling trigger. Connections allow you to integrate your Logic App with other resources. This can be an Azure resource such as blob storage, or it can be a resource outside of Azure. There are also third-party resources such as Salesforce, Office 365, RSS feeds, Google's G Suite, as well as many others. As mentioned, you also have the option to create a custom connector if needed. As part of the connection, you define what you're looking for. For example, if you want it to run when a blob is added or modified within a storage account. Once you have the connection defined, we now define the action. The action can include any number of steps that you defined. This can be as simple as sending a notification when the storage blob is updated to deploying a new environment when a request is submitted. The options are essentially limitless depending on what your needs are. Logic App Designer is a graphical way to design your Logic Apps. It is the default option when you create a Logic App, and there are a number of existing templates that Microsoft has created that will help you get started. You also have the option to start with a blank Logic App. Within the Logic App Designer, you have a number of options for how your Logic App will be triggered. It can be on a schedule using a polling trigger, or you can have it on a connector so it'll be triggered once the event happens using a push trigger. Once you have your trigger defined, you can now create a workflow. The example on the right is checking Twitter and then filtering for tweets with the word Azure in them. Based upon that logic, it will execute either the true or false workflow. An advantage of Designer is that you can easily view the associated JSON code in the same window. As you get more complex Logic apps, it may be helpful to create part of it within Designer and then do some fine-tuning within the code. With Logic apps, there are two deployment models. The first is consumption-based or serverless. This tier only charges you for the resources that you use. But instead of runtime or memory consumed, you are charged based on the number of actions, triggers, and connectors that you use. So if you have a Logic app that has many steps and a number of connectors, it will typically be more expensive than a Logic app with fewer steps. It is also worth noting that the type of connector you use will have an effect on the cost. There are built-in connectors which are typically used with Azure services. The standard tier offers many more options for third parties and does have a higher cost. The enterprise tier is used when integrating with IBM and SAP. The other option is the ISE or Integrated Service Environment. This is a fixed price. You are limited by the capacity of the SKU. With an ISE, you do not pay for the connectors regardless of the type. There are two options, the first being Developer. This is a lower cost tier that offers no SLA and does not allow scaling. Additionally, it offers no redundancy, so if any maintenance is done in the backend, there could be temporary outages. The Premium tier does give you the ability to scale up to meet your Logic app's needs. Additionally, it offers an SLA and is geared more towards production workloads. Another important difference that may help determine the appropriate SKU is if you need to integrate your Logic app directly into your VNets. The consumption-based tier does not offer this. The only way to have this feature is if you use an ISE. Now that we understand the components of Logic apps, let's go into the portal and create one. So here we're back at the Azure portal. What we're going to be doing today is looking at Logic apps. So let's go ahead and take a look at Logic apps. And you can see right now we don't have one deployed, so let's fix that. Go up here and click on Add. And we're going to select the resource group of Skylines once again. And now we need to define a name for Logic app. So let's just call it Skylines LA for Logic app. We're going to leave this in basically a region deployment instead of selecting an ISE, which basically means we're going to be doing consumption based. And then we're going to go ahead and leave the defaults here. We're not going to define a tag, but let's go ahead and create this. So once this starts deployment, it should finish up here pretty quickly. Our goal is, once this is deployed, we're actually going to go through and create a Logic app so I can show you how it works. So now that it's completed, let's go to the resource. And you can see by default it opens right up to Logic App Designer, which, as we talked about, is basically a graphical way to deploy a Logic app. Let's go and take a look at the Logic app as itself first before we dive too far into that. So you can see for the deployment tools, we've got the code view as well as the designer that we just saw a little bit ago. We've got versions as well as connections, and then we've got some of the settings as far as authorization and access keys, as well as if we need to set up any sort of managed identities. Let's go take a look now at the code view. So what I'm going to do now is I'm basically going to remove all this. I've got a template that I've already created here in Visual Studio Code. So I'm going to select this and I'm going to paste this in here and save it. So now that we've got this saved, let's go actually to the designer view so we can take a look at what's going on here from a graphical perspective. So what it's doing is basically it's looking to see when a new tweet's posted. So we open this up, searching my account to see if a new tweet's been posted, and it's going to check that every minute. Then if we drop down to conditions, it's going to go through and say, okay, does that tweet contain the word Azure? Well, if so, let's go ahead and send an email. Let's call a sample function, and if we remember right, this was a function that we created earlier, and then we're going to post another tweet. However, if it does not contain the word Azure, then we're just going to send an email. Well, let's go see it work in action. So if we go to my inbox here, you can see we don't have any unread messages, which as a side note is a first. And then if we go to Twitter, let's go ahead and say sample tweet Azure. And let's go ahead and hit tweet. So we've got our sample tweet here. And just to speed this up, I'm going to go ahead and hit run. So now it's basically going to go through and do its process. And if we notice, hey look, I got an email up here. Sweet. So it looks like, hey, I've tweeted. Sample tweet Azure. All right, that's cool. Now let's go back to Twitter, hit home, and look at that, I sent another tweet, and if I open it up, hey, look at that, it's still true. So again, to take a step back and look at what's happening, a tweet's been posted, it looked at that tweet to see if it had the condition there, it sent an email, it called a function which then in turn created this image, and then it posted a tweet again with that image, so it was able to pass that along. So now if we go back up here and just say, sample tweet without any fun words. And we go ahead and tweet that. And now let's go back here and let's run it again just to speed things up. And look, I got another email here. And sad face. It's cool, but whatever. So go ahead and look over here. No follow-up tweets, just that one that I sent. And if we did notice here, you can see here though it actually came up twice, and that's because just that timer that was every minute happened to pick that up at the same timer before I hit the run command. So just because of timing and because I manually ran it, that's why we got this twice. If I would have let things be, we'd only had it once. But this is just an example of how you can use logic apps to connect multiple systems together. If we look here, we can actually see the logs of this command. Because now we can see the outputs, we can see what happened, and basically, did this condition, the output was false. So in that case, it didn't do anything here, but it did go through and run down here, and you can see we've got the X versus the green check marks to basically say this didn't run. So again, you get a nice kind of output here as far as what's going on. If we go back to Designer, which again is basically the same thing we're in, if we wanted to change this to where, it searched for every 10 minutes, we could go through and update that. Or for the condition, if we wanted to look for a different word. As you're working through this, it gives you a lot of flexibility to connect many different systems. Because again, we're looking at a tweet, we're sending an email, we're calling a function, and then we're following back up with a tweet. So if we look back at Logic App Designer and we want to take a look at some of the connectors, we can hit this plus arrow. We're going to go ahead and add an action. And then we can see here we can go through and select all. And now we're going to take a look at some of the various connectors. So we have some of these here, but if we hit the drop down, now you can see we've got a pretty massive list. And we've got our built-in ones. If we start there, these are going to be typically mostly Azure resources. If we go up to your standard, now we start getting into some of the third party. And given what we see here is a lot of Azure related or Microsoft related, if we scroll down, you can see now we're starting to see some of the other ones. So Ally, Amazon, Bitly, Bitbucket. And as you can see the list, we're still in the B, so the list is pretty massive. And if we go to Enterprise, now we see the IBM and the SAP type applications. And if we remember right, those have a higher cost here. But again, the overview of this is to kind of help show you some of the power of Logic Apps. And not only can we do everything via code-based, as we did when we started this, since we basically copied in an existing code, but you can also use the designer view. Again, I think the designer view is great if you're looking to get started or fine-tune an existing Logic app. But once you have that set up, copying that code and then being able to paste it and move it around is incredibly helpful. And it gives you the ability to templatize your Logic apps in a very effective and efficient way. Let's take a look at how custom connectors work within Logic apps. There may be times where you're working with Logic apps and you're trying to interface with an application that does not have an existing connector available. For these occasions, Microsoft has provided the ability to create a custom connector within Logic apps. A custom connector is essentially a wrapper around a REST API, or if you prefer, a SOAP API. They can be public or private. If you are using private, then also need to be aware that an ISE SKU for your Logic app is required. Once you decide how your API will be presented, you also need to ensure it's secure. Currently, you can secure it using OAuth 2.0, an API key, or by using basic authentication. When it comes time to define your API, you need to provide information so that the Logic app can understand how the API operates and its data structures. There are currently 3 ways we can do this. By providing an open API definition, this is previously known as a Swagger file, by uploading a Postman collection file, or by creating one from scratch. It is worth noting that regardless of how you define the API, Logic app uses Open API once it has been uploaded. I know this is a quick section, but I think this is one where it really helps to see it in action. So let's jump into the portal and create a custom connector for our Logic app. So here we are back in the Azure portal. What we're going to do is we're going to create a Logic App custom connector. And what that custom connector is going to do is going to integrate with the Text Analytics Cognitive Service. So to start, we need to create a Logic App custom connector. Before we do that, before we proceed, what I've done is I've already created the Text Analytics Cognitive Service. So we have this already defined. So now we're going to create the Logic App that's going to integrate with that. So to do that, we go to Logic App Custom Connectors. You can see we don't have one defined today, so let's go ahead and click on Add. And we're going to select the ever popular Skylines resource group. We're going to just give it a name, so we'll just call this Skylines Logic App CC for custom connector. We're going to define a location or leave that as a default of Central US. We're not going to define any tags at the moment. And then let's go ahead and create our custom connector. And this should happen pretty quickly. Alright, so let's go to the resource. You can see we don't really have a lot here. Let's go ahead and click on Edit up top. While this is happening, I'm going to switch to full screen mode, and that makes it a little bit easier to see. Unfortunately, due to the screen resolution, I'm not able to get the full window here. The general steps would still be the same. In order to proceed, we need to provide the Open API file so that the connector knows how to talk to that service. So we've already got that created, so I'm going to go ahead and do an import. I'm going to select the file that we've got here and open. If we come out of full screen mode for a second, we'll go look at Visual Studio Code and we can see the file here. Again, it's basically just, it gives it some description, the path, what it produces, and then some of the information that we need to go through or what information needs to be provided. We'll look at this a little bit closer towards the end. So let's go ahead and scroll down here. We're going to go to Security, and per the Open API file, we are using API as our authentication. If we select down here, you can see we can use no authentication, basic, or OAuth 2.0. We'll leave that with Open API. And again, I need to go full screen here. And then we'll just go ahead and tab down and then hit Next for definition. And this just gives us a little more information about how the request is, where the request is processing, responses, so on and so forth. But now we need to go through and test this out. So to do that, let's switch to the Swagger editor. And now we need to authorize in order to validate everything works. So to do that, let's go ahead and grab the key that we need from the Text Analytics service. And then we're going to go back here and go to Authorize. Go to full screen again. And paste that key in. And then we'll go ahead, and I had the tab down and hit authorize or log in, down below. But now you can see we're authorized, and now we're looking basically at a post request. So let's expand this out and take a look, and you can kind of see here's the general body as far as how information is being passed in. And this is all defined within that Open API file. If we scroll to the left here, you can see here we've got our language, we've got the ID, as well as the text to analyze. So language, ID, and text. So let's go ahead then and try it out, and let's provide some values here. So we're just going to use EN/US for the language. We're just going to give it an ID of 1 for starters, and let's go ahead and give this a value of Skylines Logic App Custom Connector. So now we've got all this, let's go ahead and execute. And you can see we got a response of 200. It did go through and run it and gave us a score. So that tells us that our custom connector is working. So now that we have this defined, we can go up here and update the connector, and now it'll go through and save it. So now we have that custom connector. So now if we went back into Logic Apps and looked at connectors, we would be able to see our Skylines Logic App CC available, and that would allow us to integrate with the Text Analytics service. In this section, we're going to learn about what API management is and how we can use it. With more and more of the technology world working to integrate with other applications, this is driving the increased use of APIs. At the same time, we need to ensure that any APIs we provide are both secure and visible only to the appropriate groups. Azure's API management is a great way to achieve this and more. Azure's API management solution gives us the ability to host our APIs in a way that provides a layer of protection between the users of that API and the product's backend services. This layer of abstraction not only provides additional security, but also allows us to create policies that we can use to control how the API management will handle the incoming request. These policies can include restrictions on who can call the API, rate limits, or ensuring a valid token is presented. As with most things, we are constantly adding new features and improvements to our applications. For others to be able to leverage these, we need to make sure we are making changes to our APIs. API management lets us present these in a phased approach and also gives us the ability to roll back if an oops does happen. Let's take a step back and look at the bigger picture view of Azure's API management. We can see on the right we have our company's services or products. They can be hosted on one of the many services in Azure or in an external location such as on-premises or in another cloud provider. We then have our users of the API on the left. This will include the developers, other applications or users of our services, as well as the administrators. We can use API management to sit between our products and the people and applications that will be using them. This provides a layer where we can not only control who can access our products, but also how they interact with those services. There are features within API management that are specific to the type of interaction that will happen. The applications who will be using our backend products will be connecting through the API gateway. The developers who are looking to leverage our APIs will use the developer portal, and the people who need to manage our API instance will use the Azure portal. Let's start by taking a look at the developer portal. When you create an API management instance, a developer portal is created automatically. Its purpose is to provide the documentation of your APIs so the developer can learn which APIs are offered and how to use them. The portal can also be customized to meet your organization's branding needs. Additionally, you can control how the interface is presented using various widgets, layouts, and there is a built-in style guide to help. By default, there are a number of widgets available. If you need to expand beyond that, the developer's portal code base is hosted in GitHub, so you can fork the repo and create the necessary widgets as needed. When you create your API management instance, Azure creates a fully managed instance of the developer portal. You also have the option to self-host one or more developer portals. They are hosted on Azure storage account that has a static website feature enabled. Self-managed portals are required when you are running more than one developer portal. They are also required when you have created a custom developer portal from the GitHub code. Understanding what APIs are available and how to leverage each API is extremely important, but at the end of the day, using the services offered by the API is the ultimate goal. Let's say you have created your various products and you have your developers who need to access them. One of the most common ways that we can do this is by utilizing subscriptions. Subscriptions allow us to create scopes around the APIs we want to present. Depending on how the products relate to one another, we may use a simple one-to-one scoping for each subscription to a product. In this case, subscription A may map to product 1, or subscription B to product 2, and so on. You may also want to group multiple products to a single subscription. So we may have subscription A offers the services of both product 1 and 2. Subscription B is still a one-to-one map with product 2, but subscription C offers products 2 and 3. In this case, it may be safe to assume that product 2 is a core dependency of both product 1 and 3. You can also create a subscription to scope a single API, or you can have it include every API within the API management instance. When you have people and applications that are looking to interact with your application, many times you want to ensure they are who they say they are. This could be used to keep unauthorized users from accessing it, or it could be assist with logging. In the developer portal, we can utilize anonymous access. As it sounds, this means that there is no authorization requirement to view the API documentation. You can also utilize the locally managed credentials in the API management instance. This is useful if you have a small number of users who you need to manage access to the portal but don't want to set up an identity provider. With that said, you can also leverage an identity provider. Rather than maintaining a list of users who can access the developer portal, by letting the identity provider manage a list of users, you don't need to worry about individual user accounts. There are several identity providers that you can utilize. Some examples are Azure AD, Twitter, Google, as well as Facebook. On the API Gateway Management side, we also have 3 options in how we can authenticate. Much in the same as in the developer portal, we do have the ability to use anonymous access. We do also have subscription-based. And one thing we didn't mention when we talked about subscriptions is that each subscription will have a key associated with it. If a request comes in without a subscription key, it will be discarded. So this is a way we can use to authenticate how users access our products by using that subscription-based key. The third option is to use a client certificate to authenticate. This requires some additional configuration on the backend services in addition to configuring our API management instance. Each of these has their appropriate use case. It all depends on how you want the developers and subscribers to use your API management instance. As with most things in Azure, API management has multiple tiers that you can choose from depending on your needs. Depending on the feature set and the capacity required will help you determine which tier is appropriate for you. The first is consumption. It is the most limited tier in terms of features, but also has the lowest base cost since you only pay for the number of API calls that you use. Since it is consumption-based, it does use a shared model. It also does have some limits that you will need to be aware of regarding the size and quantity of your APIs. It does have an SLA associated with those, so that is something to keep in mind. The next is the developer tier. This is one that does offer an isolated instance, so will have a fixed monthly cost associated with it. It only has one scale unit, so there's not going to be an SLA associated with it. As such, this is recommended for non-production use cases. We then have our basic tier, which offers 2 scale units, so there will be an SLA associated with it. As having twice the number of scale units, it also has roughly twice the performance of the developer tier. This would typically be used for your entry-level production workloads. The next two are standard and premium. These also increase the number of scale units to 4 and 10 respectively to meet your performance requirements. Additionally, they offer some more features to cover more advanced use cases. If you're more interested in comparing the various tiers, we have included a link below to help you explore some of those differences. Let's jump into the Azure portal and create our first API management instance. Once again, we're back in the Azure portal, and now we're going to be looking at setting up API management. So to start, let's go up top and search for API. And then here we can select API management services. We'll select that, and we can see we don't have any today, so let's go ahead and add a new one. So click on Add. And now we're going to choose the resource group that we're going to be deploying to. And once again, we will be selecting the Skylines resource group. And now we needed to go through and define a name as well as the organization and an administrator email for this. So we'll select the Skylines APIM for the resource name. We're going to put this as Skylines, and then we're also going to set the administrator email to joe@joefect.com. The administrator email is slightly different, and APIM uses that just for notifications. So now let's go down and select the pricing tier. And you can see, if we remember back from the PowerPoints, we've got a few different options. In this case, we're going to select developer, and then we're going to go next to monitoring. We are going to set up application insights, so we'll go ahead and set that to on, and then now we're going to go ahead and select the application insights instance. And if we remember back, this is what would also be known as a codeless deployment, since we're not defining any code at this point. We'll go to scale, and scale is not an option considering we are using the developer tier. If we used one of the basic, standard, or premium, we would have that choice. We're not going to select the manage identity at this point. We can always turn that on later if we need to, and that again would be used if we wanted to integrate with Key Vault or some other Azure resource. We do have the option, since we selected the developer tier, to integrate with an existing VNet. We're going to leave this off for the time being. If we go to protocol settings, you can see here we've got a number of options. We'll leave all these as the default, and we can come back and change these later if we need to. We're not going to find any tags in this instance, and then we'll go back and look at the review and create. One thing worth noting is when you create an API management instance, it can take anywhere from 45 minutes to an hour for it to deploy. Just something to be aware of as you're working through this. So let's go ahead and select create, and we'll go ahead and get that submitted. And again, this will take probably about 45 minutes to an hour. So let's go ahead and hit pause here, and we'll come back once that's deployed. So now after a while, our API management instance has been deployed. So let's go back to API management. And here we can see we've got our Skylines APIM instance, and we can validate the status is online. So let's go ahead and select it. And let's go ahead and move this off to the left. And then here we can see we've got our API management instance. And if we scroll down on the left, we've got our products. And these are 2 built-in products. So we've got the starter and unlimited. You can see that their state is set to publish. If we wanted to limit them to a certain group, we could do that, but you can see right now that it's available to administrators, developers, as well as guests. If we go through then and look at the subscriptions, you can see we basically have our default ones. So we've got the starter and unlimited products available, and they're both active. And if we go through and look at the APIs here, we can see we just have our default Echo API. And let's go ahead and kick this off to the left, give us a little more space. And we can go through here and you can see we've got our various operations. So we've got post, put, so on and so forth. We can select the option. We can also go test and then do just a sample request to validate that it's working. So this just gives you some of the abilities to see what you can do within the APIs. You can look at our settings here to see what specifically it's being looked at. Again, if there's any products it's associated with, requirement for security, and so on and so forth. So it just gives you a lot of options. Additionally, we can get into some policies, which we'll talk about in a little bit. So now that we have basically our APIs defined, or the operations defined, we've got our API and we've got our product. And if we go back to API management and look, we've got our subscription set up so that we've got everything basically flowing up so that it can be consumed. Now we need to go to developer portal. So to do that, let's go to overview and let's go ahead, to do that, let's go to developer portal and then let's go take a look at it. So here we've got our basic developer portal. And since we've accessed that from the Azure portal from within the API management instance, we can come in here and we can edit. So let's go ahead and let's update this to say, welcome to Skylines Academy. Helps if you spell, huh? And we'll go ahead and leave that. And you see we've got a couple different options. If we wanted to change the font, we'll go ahead and leave that. And we don't like this Contoso up here, so let's go ahead and get rid of that. I think that looks pretty good. Now that we've got that, we're going to go down here and save the changes, and then we'll go down to publish. So we'll give that a second to publish here. And let's go up here. Let's copy that URL. And then let's go ahead and open up a new private browser window and let's paste that in there. Since we're not signing in from the Azure portal, we'll be accessing this in a way an external developer would. We'll give it a second to load here. And you can see we've got our changes there. So it's saying welcome to Skylines Academy. And now we can go through and look at the APIs that are out there. And you can see we should have our Echo API. So now a developer will be able to go in here and take a look at this. And he would be able to see the various operations associated with the Echo API. So let's say Git, and he can go through and look to see, okay, here's what it's doing, here's the parameters that are required, so on and so forth. And if he wanted to try it out, he has the capability to go through here and do that and hit send so he can validate everything works. This is the advantage of API management, or one of the advantages of API management. It gives the developer the ability to come in and take a look at the products that you're offering, the APIs associated with each product, as well as the operations within those APIs. And then you can see how to use each one of the APIs and also test prior to writing the code so they know how to define their code or how to write their code to integrate with your API. Hopefully this helps. Let's go back and take a look at some of the policies that we can define for our APIs. We now have our API management instance deployed. Let's take a look at how we can utilize policies to manage the API request. One of the more powerful features of API management is the ability to manage traffic that is passed to your backend services. Without any policies in place, an API request that comes in that reaches the API gateway will be passed unaltered to the backend services. With the policy configured, we can review the request and make alterations to both the incoming request as well as the outgoing response. Policies can be defined at multiple levels within API management. These include the following scopes. Global. So this would mean all items within the API management instance. Product covers a specific product that you have configured within API management. API covers a specific API within the product. And then operation is a specific request of that API. As you have policies configured, there can be some conflicts. So policies are applied in the same order in which they are listed. This means that if you have two policies with the same setting type, say IP restrictions, the one that is applied last will be the winning policy. You can view the effective or combined policy under the policy editor. When applying policies in API management, you can do it using a GUI-based editor. Additionally, since the policies are written in XML format, you can easily edit them directly using XML. Some examples of ways that we can define a policy include IP filters to restrict who can utilize the API, rate limit to prevent overrunning the backend service, URI rewrites so we can modify how the request is sent to the backend service, validate JWT tokens, and authenticate the backend service so that the incoming request doesn't need to worry about managing any of that information. As you can see in this example, on the inbound policy, we have an IP filter. We're using this to restrict who can access our API. On the outbound side, we are setting the content type to application JSON. In this demo, let's see how we can configure a policy within Azure API Management. Now we're back in the portal with our Skylines APIM API Management instance open. Let's go down and take a look at our products. So if we look at our product, we're just going to go ahead and select the starter one. And then here you can see we've got the APIs that are associated with it, but we also have the policies. And you can see basically the policy is just an XML file that we have set to help control how our requests and responses are handled. You can see here that we have a rate limit in place as well as a quota. So let's go ahead and leave those changes by default. So now if we go back to the APIM instance and then look at the APIs, we can select the Echo API, and then you can see here for all operations, we can have some more policies that we can define. So if we select this and add a policy, say we're just going to go ahead and IP filter, we want to add an IP address, and we're just going to go ahead and set to 10.0.0.0 and then 10.0.0.255. So we're just allowing that basically that one subnet to allow access. Let's go ahead and save. So now that we have that open, we can go down and see that IP filter here. So we just took a look at the first post operation here, and if we look at the inbound policies, you can see we've got the base policy plus the JSON to XML policy that we're adding here. Let's go ahead now and we'll just select this one, and let's go to code editor, and you can see we've basically got that defined there. One thing too that we've got now is this calculate effective policy. So if we do this, and we're going to go ahead and say for the starter, because this operation belongs to both the starter as well as the unlimited product, you can see here we have all of the policy scopes being applied. Starting at the top, we have the API scope and the product scopes listed. The operation scope is not explicitly defined, but is implied. Within the product scope, we have the rate limit and quotas. In the API scope, we have our IP filter. And in the implied operation scope, we have the JSON to XML setting. Moving down to the back end, we can see the only thing we have defined here is within the global scope, and then we have no outbound or on-air policies defined. So if we switch this to the unlimited, you can see we no longer have those rate limits defined. So our effective policy removes those rate limits. Now we just have the policies that are defined at the API level as well as the operation level. Hopefully this helps you understand how policies can be defined, how they can be configured, and then how they are inherited. In this module, we're going to discuss how we can leverage events from within our environment. Before we go too far, let's discuss what is considered an event within Azure. Per Microsoft site, an event is the smallest amount of information that fully describes something that happened in the system. They go on to say that it includes some specific information for each event type. So if you added a file to a storage account, it might include the path to the file, the size of the file, as well as the storage account's name. There are 3 different features in Azure that we're going to look at to handle these events. The first is Event Grid. This is going to be used for event-driven automation. Events are submitted, and then another resource can review and act based upon the information of that event. The next is Event Hub. This is used to ingest events and can store them and stream them to another service. Say if you're using a third-party SIEM tool and want to get the data from Azure to that tool. And then finally, Notification Hub. This is useful if you want to push information to one or more devices quickly, typically mobile devices. I tend to relate this to a severe weather alerts on our mobile phone. If there's a severe storm coming in, often many people in the affected area get a notification about the storm so that they can stay safe. This will be using Notification Hub to facilitate this. Event Grid is useful for applications that use event-based architecture. In event-based architecture, the resource that is generating the event doesn't care about who is receiving that event. Since it is decoupled, it makes things easier to manage as you don't have to worry about writing back to the source. Event Grid is utilized to collect information from the various event sources and then pass them along to the event handlers. The event source could be a variety of Azure resources, like storage, resource groups, or container registry. So as the events are generated from these resources, Event Grid will receive the events. Depending on how Event Grid is configured, you can take those events and then pass them along to another service that will respond or react to those events. You can use logic apps or functions to perform an action, or you can send it to a storage queue to be processed later. The advantage to this approach, again, is that everything is segmented and decoupled, thus giving you the ability to define your process flow in a granular approach, which allows it to scale with ease. Now that we understand the concept of event grid, let's take a moment to review some of the terminology associated with it. An event is a small subset of information that defines something that happened. It doesn't contain the raw data of the event, only the metadata to describe it. Using a storage account example again, the event doesn't contain the file, it only describes the file. Publishers are the user or organization that sends the event to EventGrid. Microsoft is an example of a publisher. If you are sending an event to EventGrid from an on-premises location, then your organization would be the publisher. Event sources are the resources generating the events. For example, Azure Storage, container registries, key vaults, so on and so forth. If your application is sending an event to event grids, then your application would be considered the event source. Continuing on, topics are how you define to the event source where to send its events. They're used to collect related events within EventGrid. An event source can select one or more topics to send to events depending on how the topics overlap and the type of events it generated. There are 3 general topic types. The first is system topics, and these are used for built-in Azure services. Custom topics are used for applications or third-party topics. And there's a subset of third-party topics called partner topics, and these are ones that have basically worked with Azure and met various requirements to be considered a partner topic over a custom topic. Once the event is sent to a topic, then a subscription is used to filter the events. This gives you the ability to remove the noise and only receive events that are actionable. Finally, after we've gone through all this work of ingesting the events and filtering them, we now have the event handlers to process the events. This is where we can act based on the events received. These can include webhooks, storage queues, or Azure functions. In summary, EventGrid takes the information in, can filter it, and then pass it along to a handler so that it can be processed. Let's jump in the portal, create an EventGrid, and see how they work in action. Here we are back in the Azure portal. And what we're going to do for this demonstration is we're going to create an EventGrid topic so we can send data to EventGrid. We're then also going to create a subscription in it that's going to send information to an Azure storage queue so that we can view that information. So let's get started. The first thing that we need to do is we need to create an EventGrid topic. If we go up here and search at the top, we can start typing event. You can see we've got event hubs and then a number of options for EventGrid. Our goal today is going to be a topic. So let's go ahead and select that. You can see that we don't have one here today, so let's go ahead and select add. And then we've got our ever popular screen. So let's go ahead and we're going to put this in our Skylines resource group. We're going to give it a name. We're just going to call it Skylines EG topic, if I can spell. We're going to leave that in the default location of East US. And then we have the option to where we can choose the schema for the events that are going to be sent to this topic. We're going to leave that as a default, but you can see we do have a couple different options there. We're not going to assign a manage identity or define any tags at this point. So let's go ahead and hit create, and this will go ahead and get our topic set up. And this shouldn't take too long. Perfect. Our topic's ready, so let's go ahead and open that resource up. You can see here we've got our access keys as well as our networking options. What we're going to do now is we're going to go ahead and create our subscription. So let's go ahead and add event subscription. And we need to give it a name, and we'll just call this Skylines EG subscription for subscription. We're going to leave the default schema. And if we wanted to, we could filter out some events types. So if we wanted to put some filter in there, we could do that. We're just going to leave ours as a default. And now we need to go through and select the endpoint type for the subscription. And for that, we're going to go ahead and select a storage queue. But you can see we can talk to an Azure function, a webhook, or send something to a service bus topic or queue, which we will talk about very soon. In the meantime, we'll go ahead and select storage queues. And now we need to select the specific queue. So let's go ahead and select that. It's going to be in the subscription, and it's going to be in the Skylines demo storage account. So select that. And then we've got a storage queue called EventGrid. So perfect. So all that's set up, let's go ahead and confirm this selection. And let's go ahead and create. So essentially what we've done to this point is we've created a topic. So we've got a location where we can send our events. That topic is then going to pass that information along to the subscription. The subscription in this case is our EventGrid storage queue. This is great. However, how does it really work, or how do we test that? Well, what we can do is I've got a Cloud Shell window open here, and we've got a few commands. So if we go through and take a look at these commands in Visual Studio Code, the first one is basically getting the endpoint. The first command, AZ Event Grid Topic Show, is going to look for that Skylines EG topic in the Skylines resource group, and it's basically going to look for the endpoint of that topic. It's going to save that as the endpoint variable. And then we're basically going to do the same thing again, except this time we're going to get the key, or those access key, for that event grid. And then from there, we've just got a few events that we're creating. So just some information, and we'll take a look at that once we get that in the storage queue. Lines 9 through 10 are then taking the events that we created, 1, 2, and 3, and then sending them to that topic. The topic will then take those and pass them along to the storage queue. So let's get started. Let's go ahead and copy these commands here. And if we go back to the Cloud Shell, and if I paste those in, it'll go through and run. And if we just do endpoint, oh, it's yelling at me. So let's try this in a little cleaner format. So we do echo endpoint, and we can see the URL that the topic will be listening on. If we do echo key, we can now see the access key that it's going to be using. And if we go back to our topic, look at access keys, and then show key 1, we can see that that matches with what we have in the Cloud Shell. Perfect. So I'm going to go ahead and run a clear here real quick. And now let's go back to Visual Studio Code. Let's copy those 3 curl commands. And let's go back and run those. So it looks like everything completed successfully. Let's go take a look at that storage queue to validate those messages are there. So we go back to the portal. Let's go home. We've already got the storage account listed here under recent resources, so we'll select that. We'll scroll down to our queues, and then we've got our event grid queue. We'll open that up, and there we can see our 3 messages. So let's go ahead and take a look at the first one, and we can see basically we're passing along some information, talking about a Triumph Street Trample. Cool. All right, let's take a look at the second one. Oh, close this, and let's take a look at our second one here. And this one is talking about a KTM Super Duke. Guy's got good taste. And then we'll look at the third one here, and it's another Triumph Thruxton this time. So again, basically what we're showing here is that we've got a event grid that we're sending information to. It's then passing it along to a storage queue to be processed. This is just one example. Again, we can use a Azure function or a webhook to go ahead and take that information and process it. Hopefully this helped explain the concept behind event grids and how you can configure them. Let's jump back into PowerPoint and take a look at another event-based tool. Let's take a look at another tool for handling events called Event Hub. Event Hub is a data streaming platform that gives us the ability to ingest and process millions of events every second. As it ingests these events, it can also work with a variety of other solutions so the data is not lost in the noise. It offers support to handle events in real time and can also batch process them so they can be reviewed later on. As data is being sent to the Event Hub, you can either store the data in a storage account or use Azure Data Lake. You can also use Stream Analytics to quickly review the data and then visualize it in Power BI. One of the more common use cases is to send data to a third-party tool so it can process that data. Say if you have a third-party tool that you're using to monitor your applications or resources. Event Hub can receive the data from those resources and then pass it along to your monitoring application. Event Hub namespaces are the first thing we create when we set up an Event Hub. These allow you to group one or more event hubs. Namespaces are also specific to a region, so any event hubs that are created within a namespace must be created within that namespace's region. It is also worth noting that event hubs can only accept events from the same region. So if you have a resource in the East US, it cannot send data to an event hub that is in the Central US region. An event hub is created within a namespace. At the event hub is where we define the message retention as well as the partition count. We can retain the messages for between 1 and 7 days. Within the event hub, we can also configure the capture settings, which we'll talk about in a little bit. Once we have defined our namespace and event hub, we can now look at partitions. Partitions can be thought of as queues for incoming events. The events are always stored in the order which they are received. As new events come in, they are added to the end of the sequence. Events will stay in a partition for however long the retention period is defined. If you have it set for 1 day, the event will remain in that partition for 1 day. No longer, no less. There is no way to remove that data from the partition manually. It must expire before it is purged. The more partitions you have, the greater scale your event hub has. You can define between 2 and 32 partitions when you create your event hub, and this cannot be changed after it is created. Let's look at the terms used within Event Hub. There are some carryover concepts from Event Grid, and I'll try to make these analogies where possible. The first is the event publishers. These are the resources that send the data to the Event Hub. These would be similar to event sources within Event Grid. Each event publisher has a unique shared access signature token that it uses to identify itself with the Event Hub. Throughput units describe the amount of capacity that is available to the event hubs. These are determined when you create the namespace. You do have the option to enable auto-inflate, which will allow you to set a lower amount of throughput units and will give Azure the flexibility to scale up as needed. Unfortunately, it doesn't offer the ability to automatically scale down, so this is something that you may need to monitor. A single throughput unit has roughly 1 megabyte of incoming data per second, or 2 megabytes of data egress per second. This follows that writes are typically more resource intensive than reads. A consumer group gives us the ability to allow each application to have its own view of the data. So as data being read by one application, it is not locked, so another application has the ability to read that same data. As long as both applications are using their own consumer group, they can both simultaneously read the data. And finally, event receivers. This is the resource that will read the data from the Event Hub. They are part of the consumer group that we just mentioned, and they connect to the Event Hub using the AMQP 1.0 session. The Event Hub will deliver events to the receivers as they become available. There are a few options within Event Hub that are worth mentioning. The most common is Apache Kafka. Event Hub has the Apache Kafka protocol enabled by default, so your existing resources that are built to use Apache Kafka version 1.0 and later can talk directly to Event Hub. With Apache Kafka on Event Hubs, we don't need to manage any of the underlying infrastructure. If we think about it, it is a similar concept to Redis Cache. It's a fully managed service that has the same interface as if it was a manually deployed solution. Apache Kafka is only available on the standard and dedicated tiers. The next option is Capture. As we discussed briefly earlier, Capture offers us the ability to take the incoming data sent to the Event Hub and then output it to either an Azure Storage Account container or Azure Data Lake. The advantage this gives us is now the retention policy no longer applies. You have the data sitting in that storage location until it is manually removed. When you define the capture settings, you also define a time window or a size window. The time window is between 1 and 15 minutes, and the size window can range from 10 to 500 megabytes. Essentially, this is saying whichever value is reached first is when the Event Hub will take that data and write it to the storage. Looking at the various tiers for Event Hub, we have 3 options. The first is basic and is the most limited. It does not offer Capture or Apache Kafka. It also only offers 1 day of message retention. The standard tier offers both Kafka and Capture. However, if you use the Capture feature, you do need to pay a premium for it. The dedicated tier offers the most features, as expected. This includes Capture built in, longer message retention, and more consumer groups than the other 2 tiers. Let's go into the portal, let's set up an Event Hub and see how it all ties together. So here we are in the Azure portal, and what we're going to look at today is setting up an Event Hub and see how that process works, including the namespace as well as the Event Hub itself. So to start off, let's get a Event Hub namespace created. So to do this, we can go up top and search for Event. And we can see here one of the first options is Event Hubs. So let's go ahead and select that. And you can see we don't have one in place today. So let's go ahead and select Add. And let's walk through the process getting a new one stood up. And we're going to place this in our ever popular Skylines resource group. And then we need to give the namespace a name. And if you notice here, we're actually creating the namespace, and there wasn't an option to create an Event Hub by itself from that list. And that's expected because we need to create our namespace first, and then within the namespace, we create our actual Event Hubs. So let's go ahead and give this a name, and we're just going to select Skylines EHNS, because again, Skylines Event Hub namespace. And we'll go ahead and select the location to put this in the central US region, and then we need to select the pricing tier. And since we want to look at auto-inflate as well as using Capture, we're going to go ahead and select the standard tier. We're going to go ahead then and bump up the throughputs. We'll set that one at 2 for now. And then let's go take a look at our features. And if we look under features, we have the option to enable availability zones as well as auto-inflate. we're going to go ahead and enable auto inflate, and then now we can set a maximum throughput unit, or basically the maximum number that we want to be allowed by auto inflate. We'll go ahead and set that to 5 for now. And we'll go ahead and select tags. We're not going to define any at the moment. Go to review and create. We'll let this validate, and then once it's done, we'll go ahead and select create. Now these can take a minute or two to deploy, so let's go ahead and pause here for a moment, and we'll come back. All right, looks like that's successfully completed. So let's go ahead and open up that event hub. And then if we look off to the left, we can see our shared access policies. By default, it has the root managed shared access key. We can go ahead and add another one, and we can say we want this one to only listen and send. So we're just going to give this a name of send listen. When we set up a resource to send information to an event hub, we need to select a policy that is going to use in order to send that information. This gives us the ability to provide some control around how resources are interacting with the event hub. We can also go down then and look at scale. We've got 2 throughput units defined right now with a max set to 5 via auto inflate. One thing to remember again is that auto inflate will automatically scale up, but it will not automatically scale down. So that is something you'll need to be mindful of as you're working through this. Additionally, if we look at networking, this is very similar to how we define networking within a storage account, where we control access from specific VNets, or we can do using an IP range on the firewall. We're going to leave all that for the default now. We'll go up to overview, and then you can see again here we're using the standard tier. We don't have any event hubs created right now. We also do notice that Kafka is also enabled for this event hub namespace since we selected this standard tier. Let's go ahead and add an event hub, and we'll give it a name here of Skylines EH for event hub. We'll leave the default partition count as 1, and we can also change our message retention. We can change that from 1 up to 7 with the standard tier, and then we also have the option for capture. So let's go ahead and turn capture on, and here we can define the window for the capture, and again, this defines the maximums. So by default, we've got a 5-minute window and a size window of 300 megabytes. Whichever one of those values is hit first, it will then take the information and forward it over to the storage account or the data lake. I'm going to drop this down to 1 minute just for this example, and we're going to set our capture provider to a storage account, and now we need to go through then and select the container. So let's do that, and we're going to put this in our Skylines demo storage account and the Skylines event hub container. So let's go ahead and select that. And then here you can see we've got our file formats that we want to send it to. So you can see we've got a couple different options there. We're going to leave it with the default, and let's go ahead and create. So now that this is created, let's go ahead and send some data to it. So if we go back to home, go to our NJAP01 app service, and we're going to scroll down to our diagnostic settings. And let's go ahead and edit this. And now instead of sending it to just a log analytics workspace, let's go ahead and stream that data to an event hub. And we're going to go ahead and we see we've got, by default, we've only got the one namespace, so it's going to populate that for us. But now we need to go through and select an event hub. And we're just going to go ahead and select the Skylines EH event hub. And then now we have that policy name. So we have the send listen or the shared root access key. We're going to leave that as a default of the root managed shared access key for now, and let's go ahead and hit save. Looks like that's updated, so now let's go back to NJAP01. Let's scroll up to the top. Let's open up the to-do list, and we're just going to go in here and make a few changes just to generate some data. So we'll go ahead and add 3.4, and we're going to go ahead and remove this. We'll just do example 23, and then we'll do example 456. And save. So now we've just generated some data. So now what's going to happen is that's going to take the data from the web app, it's going to save it as a diagnostic settings, and then pass that along to the event hub. The event hub is going to store that because of the message retention that we've defined of 3 days. As well, since we've defined capture, it's also going to take that information and send it over to that storage account. So let's go back to home. Let's go ahead and open up that storage account. Let's go ahead and open the container. And then we've got our Skylines Event Hub container. And look, we've got some information there already. So let's go ahead and open that up. Let's go ahead and browse down. And then you can see we've got that file. It looks like that was updated just a little bit ago. And essentially that AVRO file is an Apache format. And what that is basically just logging. But again, with the capture function, now we don't have to worry about that message retention. So this data will live here until it's manually removed. Unlike if we left it sit within the event hub, once that message retention is reached, then it's going to go ahead and automatically purge that old information. Hopefully this helped explains event hubs as far as how they're created, how they're used, and then also how you can leverage the capture function. Let's jump back to the PowerPoints. We'll take a look at our third event-based solution. One last item that we need to talk about is Notification Hub. Azure Notification Hub is a service that allows you to send push notifications to various devices. These push notifications can be used for a variety of use cases. We mentioned a severe weather alert earlier, but it can also be used for breaking news or sports notifications, location-based coupons for targeted users, newly assigned tasks or work items, as disappointing as that may be, or as a simple code or prompt for multi-factor authentication. Additionally, it can work with all of your popular devices, including Android, iOS, as well as Windows. Let's start by understanding how push notifications work. Push notifications are used for the application to communicate with the user. So with this in mind, it all starts with the application on the device. That app will reach out to the PNS, or Platform Notification System. The Platform Notification System will respond back with a temporary handle which is used to authenticate with the application's backend. Depending on the mobile device OS will determine which type of handle it will create. For example, an iOS device will receive an Apple Push Notification Service, or APNS, while a Windows device would use Windows Notification Service, or WNS. The app on that device will then reach out to the application backend, which will process and store that temporary handle. When the application backend is ready to send a notification, it then reaches out to the Platform Notification Service with the notification. The Platform Notification Service, or PNS, will then turn and send a notification to the device, which then dings and lets the user know of an update. This is why you often see applications need permissions to allow push notifications. If the app on the device didn't initiate the process and say that it wants push notifications, then the process wouldn't happen in the beginning. This doesn't seem that bad, but as you start to scale out, it becomes very complex. When the application wants to send out notifications, it has to retrieve each temporary handle and have the associated logic to handle that. Add in the fact that each platform's PNS is different, you can see how this can become an issue when we are talking about thousands of devices, let alone tens of thousands or millions of devices. This is where Notification Hub comes to the rescue. Steps 1 through 3 are the same. This time though, we add a step to where the application backend forwards the request to the Notification Hub. The Notification Hub now maintains the list of temporary handles and their associated PNS. When the application backend says it's time to send a notification, it then passes that message to the Notification Hub. The Notification Hub now determines what temporary handle to use and the subsequent PNS. It then manages the routing and notifies the PNS of the new message. The PNS then delivers a notification to the mobile device. This simplifies the backend notification process for the application dramatically because it now only needs to maintain one connection with the Notification Hub. The Notification Hub will keep track of all the platform-specific PNS settings and changes. There are two primary components with Notification Hub. The first is a Notification Hub. This is a resource that holds the push information for a single application. This means you have one Notification Hub for each application that are using. The other component is a namespace, and this holds a collection of Notification Hubs within a single region. The general recommendation, though, is to have one namespace per application. While you can do this at the Notification Hub, it makes things easier to manage. It might make a little more sense if we think about we have one application, but we've got a dev test, a QA, and a production instance of the application. You would then have one namespace for that application with 3 hubs within it, one for each instance of that application. Here's an example of how we would create a Notification Hub using Azure CLI. We're going to do this for our application called Skylines App, because marketing was never my forte. We start out by creating the namespace. We do this by using the AZ Notification Hub namespace create command. We then specify the resource group, the name of the namespace, and its location. The final line specifies the tier that we are deploying to. We specified Skylines App NHub NS. This signifies that we're using Notification Hub. the application that we're using, and that it is a namespace. Next, we create the notification hub within the namespace. This command is slightly different. We're using the AZ notification hub create. Again, we're specifying the resource group and the location. We're also specifying the namespace that we created using the previous command, and in the last line is the name of the notification hub. We're going to call this one Skylines App in Hub Prod. Again, specifying it's a notification hub, it's associated with the Skylines app, but this is the prod instance of that notification hub. Hopefully this helps give you some information about Notification Hub, how it is used, and then how we can create it. In the last section, we talked about ways we could use events to control our solutions. In this section, we're going to look at how we can do the same with messages. A message is in binary format. It contains JSON, XML, or just text. If we think about the events, this is the exact opposite. With events, it was metadata about the object, but not the object itself. In this case, it is the message or object. The underlying concept is very similar. By decoupling the various applications, it again gives us a lot of flexibility with how we create our solutions. Let's take a quick look at the image below. We have our sender of the message on the left. This could be one of multiple services. You are essentially calling an API in order to send the message to the service bus. Once the message reaches the service bus, it then sits in a queue. The receiver can be another service or application. To retrieve the message from the queue, we are making another API call. If there is a message in the queue available, the receiver can then view and act upon the message as needed. You may also hear that senders are referred to as producers and receivers are referred to as consumers. Same concept, just tomato, tomato. When we were discussing Event Grid, we were using topics to tell the event source where to send the event. With Azure Service Bus, we use the same concept except now we have two options, queues and topics. Let's discuss queues first. A queue is a single space where messages can be sent. As messages are come in, they are time-stamped in the order which they are received. A receiver will then request the message from the Service Bus queue. This works great in a point-to-point scenario where you have one sender and one receiver. If you have multiple receivers, they will then be competing with one another. You may be asking, why not just have the sender send the message directly to the receiver? One reason or advantage to using a service bus is it allows asynchronous communication. Additionally, if the sender sends many messages in a short amount of time, the receiver may become overloaded. By using the service bus queue, it allows both sides to send and receive messages at their own pace. Topics, on the other hand, are designed for use with multiple receivers. You still only have one sender, but instead of competing with each other, each receiver will have their own queue or subscription to pull from, this allowing you to create a one-to-many relationship. As the sender sends a message, that same message is populated within each one of the subscriptions. These unique subscriptions allow the individual receivers to get messages from within there without impacting others. So as receiver 1 is getting information from its subscription, it's not going to impact the subscriptions for receiver 2 or receiver 3. Once we have created our service bus queues and topics, we need to ensure that only the appropriate senders and recipients can utilize our service bus. To do this, we create shared access signatures. By creating a shared access signature, we have the ability to define who can send those messages and then who can receive them. And there are 3 permissions that we can assign to that shared access signature. The first is send, and this gives the ability to send messages to a topic or queue. Along the same lines, we have listen. This works the same way, except now we can receive those messages. And then finally, we have manage. This gives both send and listen permissions, but also gives the ability to manage the namespace. When you create a service bus namespace, it automatically creates the root shared access signature, much like we saw in Event Hubs. This provides managed access to the service bus, including any topics or queues created within it. And again, like Event Hub, you can create your own shared access signature and associate it at the namespace, topic, or queue with the desired permissions. Once again, Azure has a few different tiers we can choose from to help us make sure we are only paying for the features that we need. If we start with the basic tier, it allows us to only use queues. With this tier, we're not able to create a topic. It is also a consumption model, so we're only paying for the number of operations we use. If we move up to the standard tier, we now have the option to use both queues and topics. Additionally, we now move to a base hourly price. The base price covers the first 13 million operations per month. If we go above that, then we have a tiered pricing model. And then with the premium tier, we still get topics and queues, but in addition, we now also can run in an isolated instance. This can help if you experience some inconsistencies on the standard tiers because of the shared model. Additionally, we also get a higher message size limit, and we can use availability zones, which help with geo-disaster recovery. Let's jump in the portal and let's see Service Bus in action. So here we are in the Azure portal. What we're looking to do is get a Service Bus created and then look at some of the options within it. So to start, let's create a Service Bus. So I'm going to go ahead and select this, and you can see we don't have one today. So let's go ahead and create the namespace. So we're going to put this in the Skylines resource group. We're going to give it a name of Skyline Service Bus. We'll leave that in the default East US region. And then we're going to go ahead and select the standard tier so we can have the option for both queues and topics. We're not going to define any tags at the moment, and let's go ahead and create this. Alright, looks like our service bus is created, so let's go ahead and check it out. Once we're in here, let's go take a look at the shared access policies. And you can see by default we've got our default root managed shared access key, which has the manage, send, and listen. If we want to go ahead and add one, we have that option, and then we can again select our options, much in the same way that we did with Event Hub. We're going to go ahead and cancel out of this for the time being. And let's go take a look overview, and then we've got our option for creating queues and topics up top. Additionally, if we scroll down to the left, we have our queues and topics here. And you can see right now we don't have a queue. So let's go ahead and create our first one. And we're just going to call this Skylines Queue. And we'll go ahead and you can see we've got a number of options here as far as the maximum count we can have at a given time or at a given batch, message TTL, so on and so forth. We're just going to leave these at the default and go ahead and create. Alright, that queue's been created, so let's go ahead and open it up. If we go to Service Bus Explorer on the left, you see we have the option here to where we can basically send and receive. So let's go ahead and we're just going to send a plain text message, and we're just going to call this test message. And you can see we have a few other options here, but let's just go ahead and hit send. And now if we go up to peak, you can see we do have one active message. Let's go ahead and take a look, and you can see we've got a message sequence of 1, and if we go through and look at that, we can see the test messages there. So that's essentially how the queue works. We have the option to be able to send and as well as receive here. And if we do a receive here, we can see basically that message is received. Now if we go back to peak and look, there's no message there. Because again, we received that one message, so there's not any active messages in here. So peak essentially is a non-destructive way to review the messages. So now that we've looked at a queue, let's go back to our service bus and let's take a look at topics. And again, we have the option to create a topic because we selected the standard tier. We'll go ahead and we're just going to call this one Skylines topic, and we're going to go ahead and create that. And I clicked it twice, so we got an error message. That's okay. Let's go ahead then and open that topic, and we're going to create a subscription within it. And we're just going to call this sub 1. We're going to give it max delivery count of 10, and then let's go ahead and leave the rest of the defaults and create. What we're going to do a little different this time is we're going to create a shared access policy here. So we're just going to go ahead and add. We're just going to call this sample SAS, and we're going to give it full permissions and create. So since we're creating a unique shared access policy here, let's go ahead and open this up. And you can see not only do we get the primary and secondary key, but we also get a connection string. So let's go ahead and grab that connection string. And this time, instead of sending the messages through the UI, I've got some code in Visual Studio set up, and I'm going to paste that connection string in here. If we look at this, it's basically going to go through and send 10 messages to that topic. You can see we've got the number of messages defined here. We're defining the connection string and the topic name here. Then if we scroll down, you can see we've got the message body. So we're defining here Skyline sample, message, and then it's going to iterate through. So let's go ahead and run this. And you can see there it has sent our 10 messages. So let's go take a look back in the portal. If we go to peak, and then we're going to select our subscription, so sub 1, and do a peek, now you can see the 10 messages. So let's go ahead and peek at those messages. And we're just going to go ahead and select the first one here. And you can see we've got Skyline sample message 0 because it was the first message. And then we'll go back up, message 4, so on and so forth. And rather than starting at 1, we started at 0. And then we scroll down to message 10. Here we can see that it is actually showing as message 9. Hopefully that sheds a little more light on Service Bus, how we create a topic as well as a queue, how we create subscriptions within topics, as well as how we create a shared access policy. Let's jump back in the PowerPoints and take a look at one other tool we have within Azure to work with messages. Another tool we have when working with messages in Azure is the storage queue. If you remember back to blob storage, we briefly mentioned storage queues, both of which are built on top of Azure storage accounts. Storage queues provide us with a place to send our message, but doesn't have the same structure that the Service Bus provides. For example, message order is not guaranteed. It will typically be first in, first out, but we can't guarantee or trust that the order is correct. And we're also not able to do batch sends. Messages do have to be sent one at a time. However, storage queues does offer some advantages over the Service Bus. For example, higher storage limits. You can store up to 200 terabytes in a storage queue and create unlimited queues if needed. It also has a lower cost. Since we're only paying for storage, you're typically going to pay less than a Service Bus. Additionally, since it is part of a storage account, you have the same replication options available like zone redundancy or geo redundancy. When we access a storage queue, we can do so via the portal or by using a URL. Since it is URL based, we need to make sure we're protecting the content, and we have a few options for doing so. And again, being on top of a storage account, we have the same built-in options. The first is a shared key, and this provides access to not only the queue, but the entire storage account. And we also have the shared access signature. If we think back to the storage account blob module, we set up a shared access signature, and it had access to only the blobs. We can use the same concept, but this time we're only allowing access to the queues. We can also integrate with Azure AD, so we can define access by user or by group. And then on top of all of this, we have a firewall. So this way we can control access, so only defined networks are allowed to connect to that storage account queue. When we were working with Event Grid, we leveraged a storage queue, but it was already there. Let's create one, and then let's go look at some of the ways we can access it. So here we are on the portal, and let's take a look at our existing storage queue. So if we do that, let's go to Skyline's demo storage account. And if we scroll down here, we can take a look at queues. And you can see we already have our existing Event Grid queue, but let's create a new one. So to do this, let's click on queue up top. Let's go ahead and paste our name in this case, Skyline's queue. Hit OK. And we can see it successfully created the queue. Now before I jump too far into this, I wanted to take a look at the URL for that queue. And you can see it starts off with our storage account name, and then it's saying it is a queue, and then at the end you can see we've got our queue name. This is something to take note of, so if you're looking at any sort of URL or looking to connect to a queue, for example, you'll have a general idea how the URL is going to look. This could be helpful in the exam if you're being asked to differentiate between a couple different URLs as far as which one is actually a given resource. So with that said, let's go ahead and open up Skyline's queue, and you can see right now we don't have any messages in it. We could click add here, and we could do a test message. Go ahead and hit OK, and we can see that. If we go ahead and select it, you can see some information about it. We can go ahead and close this out, and if you wanted to get rid of that message, you could select it and dequeue, and then it's going to go ahead and remove that message. And again, if we look at the storage account and we scroll back up, you can see we have our access keys. So this could be how we're going to look at securing the queue. And just note, this is going to, again, access the entire storage account, not just the queues. We could also look at our shared access signatures, and then we would uncheck blob, file, and table. So this way, if we created a shared access signature, it would only be for the queues. And also, if we look at the firewall and virtual networks, you can see right now we pretty much have open access. But if we wanted to restrict that further, we could click selected networks, restrict it to a specific VNet or to a specific IP range. We're going to go ahead and discard that for now. And what I would like to do is look at a way that we can send messages to the queue using PowerShell. So let's go ahead and go to Visual Studio Code. And I'm going to close this and we'll scroll up. You can see lines 1 through 3. Essentially what we're doing here is we're going to define which storage account we're working with. So in this case, the storage account is again Skylines demo storage account under the Skylines resource group. And then we're taking that and basically saving that as a storage account variable. The next line is we're taking the context for that storage account and then saving it as a variable CTX. Looking at lines 5 and 6, we're using the command get AZ storage queue, and then we're specifying our queue name, which is Skylines queue, and then the context, we're specifying the CTX variable, which points back to our Skylines demo storage account. We're saving that as queue. What we did so far is basically define the queue that we're working with and how to connect to it. On line 11, what we're going through and doing then is we're calling the Microsoft.azure.storage.queue.cloud queue message class, and we're defining a new message in here, and we're just calling it sample message 1. We're saving that as queue message. And then on the line 14, what we're doing is we're basically calling our queue. We're calling the method cloudqueue.addMessage, and then we're passing in the message that we created on line 11. And then if we look at the remaining ones, we're just doing that over and over again for sample message 2 and sample message 3. So let's go ahead and I'm going to copy this. And if we go back to the Azure portal, we've got a Cloud Shell open here. And we're using PowerShell, and I'm just going to go ahead and paste this in. And then if we run the command queue, you can see here we've got the URI for the queue as well as the queue name, and right now we don't have any messages in there. So let's go ahead now and let's call these commands. And these are going to go ahead and send some messages. So I'm going to type clear. I'm going to paste these in. And looks like everything completed successfully. Now if we go back to our storage account, let's scroll down, go to queues, and let's look at our Skylines queue, and now we can see those 3 messages are there. So again, there's a couple different ways we can work with storage queues. The example I provided was just PowerShell. You can use .NET or Python, multiple ways to interact with it. Hopefully this helps, gives a little more insight into queues as far as how you can secure them and how you can interact with them.